like to welcome everyone to Seattle, and it's clear that Dave should welcome you to your first interim meeting, and glad to see you here. And Dave was just telling me you had a baby daughter just before Thanksgiving, and so congratulations, Dave, and it's great to see you here. A little bit surprising that it's only a week ago. So I imagine you might be a little bit missing out on a bit of sleep. But clearly a lot of effort has gone into developing the agenda, and I appreciate that as far as the annotations and clearly laying out who's doing what as we go forward. So I appreciate that as chair this year because it makes my job so much easier. Jim, I don't know if you have any opening comments that you would like to make.
Only that the United States is glad to host this meeting again here in Seattle. I guess we always do the interim meeting here, but we like it, and so thanks to the Canadian commissioners for traveling down. Look forward to a good meeting. I see we have a reasonably good crowd. We'll probably may gain some more as the meeting goes on, but look forward to this. Thanks.
Yes, as you say, it looks like a good turnout here within Seattle. And Steve, I guess the webinar is up and running. And do you know how many people we have online? Last year when we ran the same process, I think there was a lot of appreciation for having both the ability to attend here in person for people that could make it, but also great appreciation for having the webinar so that others that couldn't travel could still attend and hear the deliberations that are going to happen here today and tomorrow. I think with that, Dave, we can get going. So I guess the question is, are there any changes to the adoption of the agenda and arrangements for the session? I don't think we have any on our side. I'll just confirm. No? Is there any on your side, Jim? Okay. So that is moved and carried. So, Dave, you're going to speak to update on actions arising from the 92nd annual meeting and the IPHC working meeting. I'll turn it over to you.
Thanks, Chair, and thank you very much for the welcome. It's good to be here for my first IPHC interim meeting. It's been a bit of a whirlwind since arriving early August, but thoroughly enjoying it, and we have a fantastic staff in support of the Commission. So. Again, I'm very pleased to be the Executive Director for the Halibut Commission. In terms of paper 03, which you've just indicated, is the update on actions arising from the 92nd annual meeting and IPHC work meeting from 2006. The overall purpose of this document is just to formalize those action items to some degree, to give all of you as Commissioners an opportunity to consider the progress that's been made in the intersessional period and to consider whether any of the incompleted recommendations or requests for actions should be rolled over for the coming year. As part of that paper, Appendix A, you'll note that all of the actions are now formalized into a general numbering system with obviously the description and the update on that particular action item. I don't know if we could have that put up on the screen at all, if we could do that for each of the papers as well as we progress. Now, I'll just wait until that pops up onto the screen. It's paper 03. Just to explain a little bit of the coding, so we do have a numbering system for IM092, which is the action from that previous annual meeting, and then on the second page you'll see the work meeting recommendations or requests for actions again. In the right-hand column you'll see that we have a status update, just color-coded to make things a little bit easier for tracking purposes. I'm not going to go through them in detail, mainly because each of them will be addressed if they are either ongoing or incomplete throughout the course of this meeting. And I would request that tomorrow we come back to this list of action items and if there's anything that hasn't been discussed throughout the course of the meeting that we revisit. Okay, it's obviously taking a bit of time to get this document up on the screen. There we go. So if we go to Appendix A, page 2. Yes. So here you can see the list of items, the various actions, the description, and again an update. One request that we will have as a Secretariat is that as we develop new action items arising from this meeting is that we really try and formalize the items, including a specific action, a clear responsibility for who is going to undertake that task, and also a desired time frame for delivery, and we'll step through those as we go. One key item that I would like to highlight is the one there at the bottom, Annual Meeting 92.05, which refers to the preparation of a one-page outline of the risk-based decision table. That has been completed by the staff and is provided as information paper 01 for your reference. And when the decision table is spoken to by Ian Stewart, we will again just remind you that there's that how-to guide for interpretation of the decision table. So, Chair, with that I will pause. If there are any specific questions on any of the updates that have been provided in that document, staff is certainly willing to respond. Otherwise, it may simply be more prudent to revisit this document later in the meeting to see if there's anything that needs to be further modified or updated. Thanks, Chair.
All right, thank you very much, Dave. I'll just see if there's any questions from the commissioners, but I did neglect to mention one thing just to make sure that there's clarity both in the room and on the webinar that we will be taking public comment and questions at a number of points you'll see on the agenda throughout. However, so for example, we will be taking public comment and questions after agenda item 5 will be the first period for public comment and questions both here in the room and the webinar. But for us commissioners, a bit more latitude, and we'll see if there's any questions as we work our way through the agenda. So I'll just check and see. Are there any questions at this point, Jim from the U.S.?
Mr. Chairman, on the Nunavik Island issue, they were going to provide logbooks. I thought we were hoping to get some logbooks from a larger area in the Bering Sea from the groups that are using Snap-on gear. Is there any update on that, or is that, it says ongoing, but are we getting help from the residents up there?
Thanks, thanks, Commissioner. The answer to that is that I'm going to pass to our staff who received the logbooks for a further update. Whether it's an indication of yes or no, we are still receiving some additional logbooks, yes. Thanks.
Any questions? Any other ones? No? Any on the Canadian side? No? All right, so we could come back to that as we work our way through the agenda. Okay, thanks, Dave. So then I guess we move on to the next piece in the agenda. Yep, state of the fishery.
Turn on the mic. Good morning. I'm Jamie Goen with IPHC Staff. I am also new at IPHC as of this past summer, and I'll be going over the state of the fishery. It's agenda item 4, and there's a related paper 4 with this agenda item as well. An overview: overall landings are fairly static over the last 3 years in the fishery. Total 2016 landings are around 32 million pounds, including research catch. Commercial landings are up slightly, and sport landings are down slightly. And I've got a table here up on the screen of some of the summary of the totals for commercial, sport, tribal, and research, showing where that 32 million pounds is coming from. I've displayed the data a little differently here than you may have seen in past years, and I'm open to feedback on how we're presenting the data for the state of the fisheries. So let me know as we go through this. And the data here is a little bit different than what you'll see in Ian's table. Ian presents total removals, and what I'm showing here is just total landings, so it does not include discards and personal use, things like that. The total area catch limits, and there's more detail on the catch limits and landings by regulatory area in paper 4 in your briefing book. So for area 2A, the sport, commercial, and treaty Indian users, the allocation is from the catch sharing plan from the Pacific Fishery Management Council, and they are coming in at 1% over catch limit. For area 2B in British Columbia, it's split between sport and commercial users, allocated by DFO, Department of Fish and Oceans, and it's coming in at 3% under catch limit. For area 2C and 3A in Alaska, it's allocated between sport and commercial users by the North Pacific Fishery Management Council's catch sharing plan. 2C is coming in at 5% under catch limit, and 3A is 4% under catch limit. A little more detail on the commercial fisheries in area 2A off Washington, Oregon, and California. The directed commercial fishery, there were 3 10-hour openers this year, which is a little different. In past years, it's usually been 2 openers. We had 3 this year, and it's at 2% over catch limit. The incidental commercial catch with the salmon troll fishery was open April 1st through November 7th. There's the ratio displayed there of the catch of halibut to salmon, and it came in at 24% under catch limit. Incidental commercial catch with the sablefish fishery was open April through October. The ratio of halibut to sablefish is listed there, and it came in at 40% under catch limit. Treaty Indian commercial fisheries in 2A, they had several openers between March and November. They came in at 1% under catch limit. Commercial fisheries in British Columbia and Alaska, these are the quota share fisheries, were open March through November. British Columbia was 2% under catch limit, so that's much better attainment than in 2015 where it was 15% under catch limit. Alaska is 3% under catch limit, again much better attainment than in 2015. For sport fisheries, area 2A, the catch sharing plan divides the coast between 7 sport subareas. I didn't list the percentage attainment of all of the subareas there. They are in your paper 4 in the briefing book. There's more detail. But the Southern Oregon region came in at 52% under allocation, and Puget Sound came in at 79% over allocation. The overall is 8% over allocation for area 2A. For area 2B in British Columbia, it was open February through December with a 1 fish daily bag limit, possession limit of 2 halibut, and an annual limit of 6. It came in at approximately 5% under allocation. Sport fisheries in Alaska, they were open February through December. For private anglers, which are unguided anglers for all Alaska areas, they came in at 2.8 million pounds. There's no allocation for that fishery. And so they came in at about half the sport landings for Alaska. Area 2C, which is the charter sector guided sport fishery, came in at 13% under allocation. That's not including the guided angler fishing. And then permit. And then area 3A for the charter sector came in at 8% over allocation. I wanted to highlight a few of the activities going on in ports just briefly. Coastwide, weights are being collected with lengths coastwide as part of the market sample collections. And you can see a picture of Dave over there for our Kodiak port sampler with one of the weight tables and length tables. There's a sex marking project in area 2B to determine the sex of the commercial catch. We'll be using that to inform the stock assessment ideally. And you'll see a request to expand this to coastwide in 2017 as a voluntary effort, and I believe more will be spoken to under the research agenda item. In area 3B, we're seeing bigger fish. There were reports of larger fish from area 3B than previous years, and preliminary average weight was 1 pound greater than in 2015. And you guys probably saw this in the news. We had a big fish caught in Area 2C in August, and it was just under 400 pounds round weight, and our port sampler Levy there in Petersburg was able to see that fish. And then I also just wanted to give a thanks to all of our IPHC port samplers. They are the face of the IPHC in the communities. Many of you have seen them in your community. So I wanted to thank them for all the work and the good data they bring, and to the captains and skippers that take the time to record data in their logbooks and give it to the IPHC so that we can have great data for our stock assessments. So thank you. Any questions?
Thanks very much, Jamie. I'll just see if there's any questions on the U.S. side.
So can you show the slide of that big halibut again?
Yes.
So it looks to me like the port sampler is half as tall. So is it really like 45 inches tall? Sorry, that's...
I did not display him to scale.
Yeah. Okay, thanks. A good report, thank you.
Thanks for clearing that up, Jim. Linda, did you have a question?
Thank you, Jamie. I just had a question on the lease of commercial quota in 2B by the sports sector. Do you have data on how much was used?
I do. If you refer to paper 4 in your briefing book, it splits that out specifically. You said it was for Area 2B?
Yes. Oh, I see it. Thank you.
So they landed approximately 5,000
Yeah.
in that fishery, 5,000 pounds. Any other questions?
Are there any questions on the Canadian side? Go ahead, Dave.
Just looking at the Area 2B again there, I don't see the FSC landings in 2B. Usually I think the figure is 430,000 pounds, at least that's what has been now allocated in previous years.
Thank you, Dave. I'm not familiar with what FSC is. Oh, this report does not show, I'm just showing the landings, and I did not report the ceremonial and subsistence fish catch in this report.
I guess for the future, though, would we not include all those regardless?
Thank you for the question. You'll see those numbers in total removals that's coming up in Ian's presentation, and I welcome feedback for what we're showing as the state of the fishery, so if the commissioners would like that information reported in the future, I could absolutely do that.
Yeah, I think it would be useful, Jamie, in the future.
Great, thank you.
Jim?
And of course, put in the U.S. subsistence fisheries as well. I guess that's obvious, but thanks.
All right, Jamie, I don't see any further questions. Thanks very much.
Thank you.
Get someone. Okay, so moving on to agenda item 5, stock status of Pacific halibut and the harvest decision table. Is Ray up? So we're just bringing up the presentation now?
Good morning, Commissioners and other attendees. Today I'll be presenting a discussion of our new space-time modeling of the setline survey data, which is a new approach we've developed over the last couple of years to replace our previous methods for estimating weight per unit effort indices for each of the regulatory areas. So as a summary, this year in 2016, new space-time modeling approach was adopted to estimate the weight per unit effort and numbers per unit effort indices. Previously, we used an empirical approach based on direct calculations from the observed data, and the new method was recommended for adoption by our Science Review Board. Space-time modeling has a number of advantages, which we'll discuss. It reduces random variation in the indices, improves how we deal with incomplete survey coverage, and improves estimates of uncertainty. The results are generally consistent with the results we got from the old approach, very similar but smoother time trends in weight per unit effort and numbers per unit effort, and some small but locally important differences in the apportionment results. But basically our overall understanding of the time trends and distribution of the stock remain the same using this method. So our annual setline survey, which are the data that we use for calculation of weight per unit effort and numbers per unit effort, is undertaken on a 10 nautical mile grid from Area 2A, from sometimes in California coast, but from Washington, Oregon, up to the Bering Sea. And in an average year, we have 1,200 stations, though we've been undertaking annual setline survey expansions area by area over the last few years, and we'll be discussing those in a different presentation. Survey weight per unit effort and numbers per unit effort. Weight per unit effort is the weight of halibut caught per station, average over across stations for a regulatory area, and numbers per unit effort are the count of halibut caught on each station of all sizes. Weight per unit effort, we only use 032 halibut. Those are halibut that are 32 inches in length or more. So the average of those indices, average of those values across stations for an area are used as indices of halibut density. They index the density in each regulatory area, and they're weighted by bottom area to create coast-wide indices. Survey weight per unit effort provides the most direct comparison with commercial weight per unit effort and is used for apportionment, whereas for survey numbers per unit effort, that's an input into the stock assessment. So as I mentioned, until this year, those indices were, for each area, were based on simple arithmetic mean of station weight per unit effort and numbers per unit effort. Now, there's lots of other adjustments that we made, including for incomplete survey coverage, which we dealt with in a number of somewhat ad hoc ways. We used adjustment scalars when there was more complete coverage in at least one year to account for missing coverage in other years. We made use of some complementary data from other surveys, particularly NIMS troll surveys in the Bering Sea. And we sometimes simply assumed that catch rates in observed regions could be applied to unsurveyed regions in the absence of any other information. So why would we change from this empirical approach to a space-time modeling approach? Well, using the same data, we can actually extract more information by fitting appropriate models. So in the past, we've just used the weight per unit effort at each station, but there's some information about the relationship among those stations. For example, or in particular, stations close to each other in space are more likely to have similar halibut density than those far apart. That's known as spatial dependence. Sets made at a station in consecutive years are more likely to have similar weight per unit effort than those made several years apart, temporal dependence. So in other words, halibut density is patchy, and those patches persist with time. So if you're looking at a particular location and you have some data on that location, information from the locations nearby are also providing some information about what the weight per unit effort is at the location you're focused on. And also prior weight per unit effort in previous years provide some information too, because if you've got a patch of halibut, it tends to hang around for a few years at least. So the space-time models can make use of this information to provide estimates of density indices. And I mean, this information is not something that's a surprise to anybody out there fishing. It's obviously well known that if you're going to go fishing, you're probably better to go to the place you've gone last year if you've got good catches in that location. And there will be places that people tend to avoid because they're known to be places where halibut are at low density. We're finally making use of that knowledge in our estimation. So here's an example. This is Area 3B observed weight per unit effort in 1998. It's a map showing our station locations and with colors coding the amount of weight per unit effort from 0 is a dark blue to red as 1,500 pounds per skate or greater. And you can see that there's a lot of variability among stations, but you tend to get some areas, appear to be some areas where you have higher catch rates and some areas where you have lower catch rates, patches of possibly high density and low density, but there's still quite a bit of noise in the data. So let's have a look at one of these higher density patches and zoom in a bit. So if we say focus on the station in the middle here, we notice that the weight per unit effort in the surrounding stations, which is a relatively high weight per unit effort station, the weight per unit effort in the surrounding stations tends to be more similar to the center station than say weight per unit effort at some station picked at random. Okay. So where we have high weight per unit effort, we're more likely to have high weight per unit effort in nearby stations. On the other hand, if we have a low density patch, we have a low density station, we're more likely to have stations with low density in nearby. So we don't only have information on this station here, this yellow station, from the data we collect at that station. There's information from nearby that tell us that this is likely to be a high density station because the surrounding area is also high density, and this is likely to be a low density station because the surrounding area is low density. And likewise, if we have a missing observation here, we have some information about what density is likely to be there from the data in surrounding stations. This helps us estimate weight per unit effort where we have gaps in coverage. So we can go ahead in time, that's 1999, and we see that although there's some changes, and we have some higher catches in some stations and lower catches in some stations in these areas that we're looking at, in general, this is still a relatively high density area, and this is a relatively low density area. If this one's high, then the neighboring stations are also more likely to be high. A bit of a change in the subsequent year. These stations decreased, but they decreased in unison. So we had a patch of halibut density, and that patch had a decrease in density. And this one remained much the same, and then density kind of increased somewhat in the following year, and likewise in the year after. So we have patches of halibut. Even from the raw data, we can see there's some patches of halibut, and those patches tend to persist with time, move in similar, change in similar ways with time. Okay. So the space-time models can improve an estimate of weight per unit effort or a numbers per unit effort at each station by making use of data from nearby stations in the same year or data from the same station and other nearby stations in other years. And so we can predict weight per unit effort and numbers per unit effort at locations with no data. Examples of this would be ineffective stations. These are stations that we tried to fish using the setline survey, but for some reason, maybe we lost gear or some other problem. Interactions with whales, for example, those stations were not, the data were not suitable for use in our calculations. We can estimate what we would have caught in those stations. In regions with no survey coverage in a given year, we can use the information from nearby stations, or the modeling will use the information from nearby stations to estimate weight per unit effort in those gaps. So by estimating the degree of spatial and temporal dependence, we can help distinguish the underlying halibut density from the random variation in halibut catch. Even if you went to the same station repeatedly in quick succession and with all conditions remaining equal, you're not going to get exactly the same catch. There's a random component to what you get when you catch halibut. Station with the same underlying density might get a very high catch one moment or 1 year, and then a lower catch the next moment, even if the underlying density hasn't changed. So what we're trying to do here is basically sort out the signal from the noise, trying to find what the underlying density is and separate that from the random variation we get in these catches. So estimation of weight per unit effort and numbers per unit effort can be further improved by use of covariates in the models. We have some additional information that can help us understand better the underlying density process. So for example, we've used depths in the model. Weight per unit effort tends to decrease with depth, increasing depth in general. How it might do that in a different way in different parts of an area or different locations, depending on the density, but that's a general observation, and the models can make use of that. There tends to be a trend with time. In many areas in recent years, we've had decreasing trends which have flattened off in the most recent years, and maybe gradients with latitude and longitude, and there are other variables you can think of and other variables that we're investigating. Regarding coverage gaps, well, the model can deal with this in a number of ways. Areas that have had an expanded survey, like 2A and 4A in 2014, the 4 CDE flats in 2015, and the edge in 2016, the model can predict, as I illustrated before, can predict weight per unit effort in years when the survey coverage is incomplete by using the information from previous years in which we did have coverage. The areas that are weighting expansion, 2B, 2C, 3A, 3B, and 4B, when areas adjacent to those expanded areas, so 2B, 3B, and 4B, 2B is adjacent to area 2A, so we have some information from deep shallow data from area 2A, and that can inform our understanding of the relationship between weight per unit effort and depth in area 2B, and likewise for 3B and 4B adjacent to area 4A where we have some data. We're also still continue to make use of auxiliary data from other survey stations and surveys. For example, the Sablefish longline survey is used to estimate weight per unit effort in deep water, which is 275 to 400 fathoms, which is outside our standard depth range, but part of our expanded depth range in 2C, 3A, and 3B. But otherwise, prediction and coverage gaps is informed by covariate data and by data from nearby survey stations. And this is all done within the model. So, through modeling, we can take some observed data that look like this. This turns out to be area 2C observations in 1998. And process that and get something that looks like this. It may take a few seconds to digest the differences here, but after a few moments you should notice that we've got much noisier data on the left than the estimates that we get from the model on the right. So the model has used our understanding of spatial and temporal dependence and covariate relationships, in particular depth here, to produce a much smoother picture of halibut density and maybe, at least to me, a much clearer definition of how we have high patches of density and patches of high density and patches of low density. You can illustrate that perhaps more clearly by zooming in again. And this is going to blink through 5 years worth of raw data, and you can see that there is a lot of noise in this data. It takes a bit of time for the eye to sort out where might be a high density patch and where there might be a low density patch. The red are very high, but they're not always on the same station. In fact, it's very unusual that the same station is red in more than 1 year. There are a couple. Likewise, the green blinks in and out of yellow and orange, which are higher density areas. It takes a bit of time to sort out that we possibly have high density close to the edge and lower density inshore, but it's much easier if you're looking at the results of the space-time modeling. And even where you can more clearly, which is basically coming up with some weighted average of these within the model and making use of covariate data and so on to come up with a much smoother picture of weight per unit effort and how it changes with time. Whereas it's hard to see in this blinking time series patterns in the time trend, the general time trend, we can see over here that through the modeling there appears to be over that 5-year period an increasing time trend in weight per unit effort. We start off with somewhat lower values and move to somewhat higher values towards the end. So how does the space-time modeling improve the density indices? We've talked a little about this. We're reducing random variation in the annual and index values, figuring out the signal from the noise. So we're modeling the underlying mean weight per unit effort process, or numbers per unit effort process, which typically has strong spatial and temporal dependence. We're also including uncertainty due to unsurveyed stations, and I haven't shown that in the plots yet, but estimates of uncertainty in the new modeling estimates, they may be higher or lower than the previous empirical estimates. For example, if we have a lot of unsurveyed area, I mean the previous estimates would have not assigned any uncertainty to that. There would have been no change to the weight per unit effort standard deviations because of those gaps. Well, now we can estimate if those are not well estimated, if those estimates are imprecise, then we're accounting for that, and we would get a higher estimate of uncertainty because of that. That's not a good or bad. It's a good thing. I mean, we're getting a better understanding of how well we understand weight per unit effort or numbers per unit effort. It could be lower because we're making better use of the data. We're making use of the space-time dependence in the data, which would work to lower weight per unit effort. So those things are working together. So just because the estimate of uncertainty is higher or lower doesn't mean we're getting worse or better estimates. We're just getting a better understanding of how good those estimates are than we had previously. And prediction is less precise at unsurveyed regions that are distant in time and space from the regions we've actually surveyed. Again, that's neither good nor bad. Getting a better estimate of the precision at those unsurveyed regions is a good thing. But the previous empirical approach was likely biased, for example, by assuming that weight per unit effort in unsurveyed regions was the same as the regions we surveyed, and it ignored that uncertainty. So we're improving our estimates of uncertainty and getting a better understanding of the quality of the estimates that we're getting from this process. Some conclusions for this talk. The modeling approach offers clear advantages over the previous method for estimating weight per unit effort, numbers per unit effort. We're using more information in particular. And we can dispense with the inelegant and ad hoc collection of adjustments for incomplete spatial coverage that we used in the past, which to me leads to greater clarity and consistency in how these indices are calculated. And at 2 meetings in 2016, our Science Review Board recommended the use of the space-time modeling approach starting this year. And so that is what we've done in calculating weight per unit effort indices, numbers per unit effort for use in apportionment and the stock assessment. Now, these indices are based on the weight per unit effort that we get from the survey, but there are some adjustments that we've made in the past, and we continue to make, but there's some changes to those adjustments. So we have an adjustment or standardization for hook competition, and the purpose of this is that competition for baits among halibut and with other species varies among regulatory areas, and it varies among years. And we base this on the number of baits that come back. If we have more baits coming back, we infer there's less competition, and we have a smaller adjustment upwards or an adjustment downwards than if we have few baits back, which we infer means higher competition, and an area would get a positive adjustment for that. Previously, we based this on area-wide aggregation of the data. Now with the space-time modeling being based on station-level data, we can use adjusted station weight per unit effort, numbers per unit effort as the input. So we're calculating a competition adjustment for each individual station and using those adjusted values as the input data for our modeling. And this does a much better job at accounting for local effects of competition, which in the past were smoothed over in the adjustment. And in fact, the adjustments tended to be most influenced by stations which had relatively low levels of competition. And the survey time adjustment, we still have to continue estimating this at the regulatory area level because a lot of the input data sources, which are summaries of catch, commercial catch and sport catch and other sources of information are not available at the level of stations. So we're still using this at the regulatory area. There's been some small changes this year following Science Review Board recommendations, which we're detailing in the RARA. They haven't made any meaningful changes to the outcomes in terms of apportionment. So we're calculating a regulatory area level adjustment factor, but applying those across the board to the station level data that we use for the modeling. So as I mentioned previously, the indices were based on straight averages of the station level values for each regulatory area. We mimic this somewhat in the output of the space-time modeling and using that output by estimating weight per unit effort and numbers per unit effort from the results of the modeling at setline survey stations, both those that we fished previously, including ones that may not have been fished this current year, and for areas that have yet to receive the setline survey expansion, potential future stations. And that way we're dealing with the coverage gaps in any given year. And then we average those estimates, those station level estimates, to come up with an estimate of an index for each regulatory area. These are the indices for weight per unit effort by regulatory area. Ian's going to talk about these in more detail, but I'm presenting these So we can compare the output of the space-time model, which is the black lines with the gray shaded regions showing uncertainty, with the red dots, the empirical method that we've used previously. And it should be clear that the trends in these are basically the same. They follow in all regulatory areas with some minor subtle differences in some regions, but the trends are pretty consistent, very consistent. If you look closely, particularly at Area 2, you'll notice that the black time series line is smoother than the lines we were getting from the empirical method because we're accounting for the space-time dependence using more information than we used previously. In Area 2A in particular, that's quite striking how much smoother the line we are getting from the space-time model is compared to the previous estimates. In particular, you notice a couple of large spikes that we got in the historical time series using the empirical method, the previous method. Those red spikes there in 2002 maybe and around 2005, and a somewhat of a dip in 2009. Those are smoothed out now, and those spikes were always biologically suspect that the underlying density would change so dramatically. And at least for the first couple of spikes, those are due to very high estimates for the Hooke adjustment factors in those years. And using the station level data and the space-time modeling has led to a much more biologically sensible time series for Area 2, I think. So I'm going to look briefly at the special case, Area 4 CDE, which is a much more complex modeling situation. I had to write a whole set of new code for Area 4 CDE. We have three data sources for this one. We have the IPHC Satellite Survey, which we've had on the Bering Sea shelf edge since 2000, and around the Area 4 islands, St. Matthew and the Pribilof Islands since 2006, and in the Eastern Bering Sea flats in 2006 and 2015. We also, a very important data source for this is the NIMS Trawl Survey, which has been undertaken on the Bering Sea flats, Eastern Bering Sea flats since 1982, and included a Northern Bering Sea expansion in 2010, which was very important for us to allow us to index the Northern Bering Sea region for halibut. The third data source is an Alaska Department of Fish and Game Norton Sound Trawl Survey. It's approximately a triennial survey, most recently done in 2014, so due again next year. It also had a couple of years with the expansion outside the Norton Sound region in 2006 and 2008. So that allows us to improve our index in the northern part of the Bering Sea, where we've never had our own satellite survey. So the trawl survey station level data calibrated and scaled to convert to observed trawl catch, to convert observed trawl catch into predicted setline weight period effort. And so that gives us station level data from the trawl survey that we can use in the space-time modeling as well as the satellite survey data. And methods for those calibrations and scalings were presented in recent RARA reports. Nevertheless, despite these three sources of data, there remain large coverage gaps in many years, mainly in the northern Bering Sea. Just to give you a sense of the coverage of the survey data, these are the data locations we had in 1998, and this figure also shows weight period effort as the circle size proportional to weight period effort, and the X's meaning no halibut were caught at that location. These are primarily the NIMS Trawl Survey locations in 1998 with a little bit of our own edge survey in 1998 in Area 4A and a few stations in 3B that we use in the models for CDE. Because the data in Area 4A that's close to the Area 4 CDE is also informing estimates just over the boundary. So we do make use of data in parts of the neighboring regions as well. 1999, we have the Norton Sound Survey, some information from that, which told us there were no halibut up there. They caught not a single thing. It turned out to be a year in which the water bottom temperatures were particularly cold. 2001, by that point, we'd had our own edge survey coming online, and NIMS has also expanded that survey somewhat north and included some onshore stations, which we're also making use of in 2001. Another example, 2006, is kind of like where everything came together at 1 year. We had an expanded Norton Sound survey with halibut caught as far up as here, which I think is some of the most northern halibut that we've ever recorded, along with our own edge survey, our new stations around the Pribilof Islands and St. Matthew, and our own stations in the eastern Bering Sea, which you can see as overlapping pairs of stations. And finally, okay, not quite finally, 2010 was the year that NIMS had their expanded survey in the northern Bering Sea. And in 2016, we had our own expansion along the edge here, providing data. So an important question for modeling Area 4 CDE is how well does the model predict weight per unit effort in these coverage gaps? So we've noted that predictions of locations far in time and space from the data may not be very good, and they tend to approach the mean for an entire area. So if you're trying to predict an area which your best data, 2010 for example, in the northern Bering Sea, shows there's almost no halibut there, and the model is saying, well, if it's 1998 or 2020 or something, far away from that survey, that there are more halibut than there should be, than you would think there would be, because it's just tending towards the mean for the entire area. That's not a desirable feature of the model. So we can work to avoid this by adding appropriate covariates to improve our estimation in those unsurveyed areas. And in this case, we added distance from the shelf edge, which was a Science Review Board suggestion. Distance from the 400 fathom contour in this case is a covariate, because weight per unit effort generally decreases with increasing distance. It doesn't do that everywhere, but the predictions will combine the local data with any overall covariate effects. And hopefully this improves the modeling. And in fact, fitting these models for Area 4 CDE, I was rather nervous in general at how this was going to work out. There's a lot of different moving parts to this, and that they take 2 days to run, so it's not like it's easy to rerun the things if something's not working. So I was crossing my fingers when I got the results. And it turned out, to my delight, the model and relief, the models worked very well, giving very sensible predictions, not only in the areas where we have data, but in the areas where we have coverage gaps. So basically where we, excuse me, the area of the northern Bering Sea where we didn't have coverage in many years, and where we did have coverage, we estimated very low catch rates. It was continuing to estimate low catch rates in the years in which we had no data. So here's another of my moving maps. This shows weight per unit effort in Area 4 CDE by station. The large circles represent the NIMS stations, and the smaller circles along the edge here are our own satellite survey stations. These are the locations in which we predict weight per unit effort for use in compiling an index for this area. It takes a bit of time to watch what's going on, but again, the dark blue is 0 or close to 0 catch weight per unit effort. The brighter colors up to red, green through red, indicate higher weight per unit effort. If you track the year, you can see the start of the series, which is about to happen now. We had much higher catch rates on the edge, and that tends to decrease with time. Whereas in the flats, we've just had sort of moving patches that have come and gone. But up here, note up in the northern Bering Sea, we've got consistently low weight per unit effort, consistent with the observations direct observations that we got in 2010, and somewhat higher values in Norton Sound, as we have some catches from the ADF&G survey there, and some catches in the 2010 survey in somewhat shallow waters south of there. Now we can also look at the uncertainty in these estimates. So these are the standard deviations, are on a somewhat different scale. Note that no station is relatively precise. One data point is never going to be precisely estimated. If you want a precise estimate for anything, you need lots of stations. So we can get quite a precise estimate for the whole of 4 CDE, and maybe some reasonable subregions. But if you're looking at a small region and you want to get an estimate for that, the survey data we're using are generally not going to provide you with a precise estimate. But we can also see how precision changes with time. Of particular interest here is how precision changes in this coverage gap. And early in the series, these circles tend to be a lighter shade of blue, and as they move on towards 2010, they get darker, and then they lighten again as we move towards 2016. So information, the quality of prediction depends on how close in time and space you have data. Even if the predictions themselves seem reasonable, the precision depends on how close in time and space. Another nice feature of this modeling is much easier to extract estimates of weight per unit effort or numbers per unit effort from sub-areas. And we do get requests for that. People are interested in particular sub-regions. For example, stakeholders in Area 4CD are interested in the WEP unit effort trend around the Pribilof Islands. There's also interest in Area 2A in estimating WEP unit effort by different sub-areas, for example, the Salish Sea, Washington Coast, Columbia River, Oregon Coast, and Northern California. But as I mentioned, once you start breaking things down into smaller sub-areas, you can get an estimate, but it might not be very good. And so this is Area 4CD broken down by sub-area. We have red for the edge, where we had a survey, our own survey from 2000. And you can see, at least in recent years, we've got reasonably precise estimates because we have quite a number of stations there. We can get estimates for the 4C Islands, Pribilof Islands. This is the yellow or orangey yellow color here. It's got a different trend from the edge, and the trend has been trending upwards in recent years, rather fairly consistently, but it's much less precisely estimated than the edge. Likewise, St. Matthew Island, which only has 10 stations and only a handful of troll stations informing that, is less precisely estimated, particularly prior to 2006, when we didn't have any of our own stations there, and the troll survey stations that you do get near St. Matthew are in somewhat different habitat and telling you something different. And the flats themselves, the largest area, obviously would have the most precise estimate. We're also using the output from the model for apportionment purposes. And here's a comparison of the output from the space-time model with the previous empirical approach for the 2017 apportionment estimates. That is the proportions that can be applied to apportion biomass for the 2017 harvest. So eyeballing this at a glance, the general understanding of the distribution of halibut among regulatory areas does not change dramatically or even meaningfully between the two methods. We don't have a completely new understanding of the halibut stock based on changing to a new model, which is reassuring. But there are some local differences. The proportion estimated in Area 4B and 2C has gone up compared to what we would have got under the old method, and it's gone down somewhat in Area 2B and 2A. Another thing, and I'm happy to go into the reasons for that, but another thing we can do this year for the first time is estimate uncertainty in the apportionment estimates. So we never really spend a lot of time or any time recognizing that these are estimates along with everything else we get. We've always just presented a single number. But these bars here represent 95% intervals for the estimate of apportionment for each of the areas. And we'll notice that those bars in every single case overlap the estimate we would have got from the empirical method. That the estimate from the empirical method is contained within those intervals. We're not getting anything that's inconsistent from what we've got in the past. Having a look at 2A as an example, we have something of a decrease in apportionment for Area 2A, and that's a meaningful decrease for the folks in 2A. That's a change from 2.22% from the space-time model to from 2.62%, which we would have got using the old method. That's about a 15% reduction in the share of the biomass that we're estimating. But the 95% interval for that estimate is 1.76% to 2.82%. The real apportionment amount could be somewhere in that interval, and that's not inconsistent with this value. So why has Area 2A's apportionment estimate decreased with the new method, or why has any estimate changed with the new method? Well, we're doing something different this time, so you might expect some changes. We're making better use of the data. But there are some things that have changed which are influencing that more than others. And I have some additional slides on that. I realized I was filling up the time pretty well with this talk, and I'm happy to go into those additional slides if there's interest in that, and for 2A in particular. But it relates to the change, in particular it relates to the change in calculation of the hook adjustment, hook competition adjustment, using station level data, in which we're much better accounting for local variation in competition compared to the area-wide approach we used previously.
So, Ray, maybe let's check and see if U.S. commissioners or Canadian would like to see the other slides about why the changes. Linda?
Okay, then I will come back to my final comments. Okay. So 2A, this is a particular issue in Area 2A. So why did it change in Area 2A? Well, partly because weight per unit effort went up in some areas, and it's a zero-sum game. If weight per unit effort up goes in some areas, weight per unit effort goes up in some areas, it's going to go down in others. But it's largely because it changes to the hook competition adjustment. And we think these are appropriate changes. We're better accounting for local effects of competition, but they do have an effect. Previously, the adjustment factor for an area was most greatly influenced by stations with low levels of competition. It tended to smooth away, basically, high patches of competition. Now, with station-level adjustments, the station's influence on the overall weight per unit effort adjustment depends on its level of competition. The number of baits returned is the data that informs that, and its weight per unit effort. If you have high weight per unit effort and levels of high competition, that's going to make a higher adjustment than if you have low weight per unit effort in the areas of high competition. And the old method didn't account for that at all. So here's an example. This helped me figure out what was going on, and hopefully it helps you too somewhat before we look at the 2A data itself. So here we have two survey stations, and one is a high competition station, and the other is a moderate competition station. Combining them, you end up with a picture of moderate competition for the combined two stations. We have an adjustment factor, competition adjustment factor, based on the level of competition of 1.69 for the first station and 0.93 for the second station. This one gets adjusted upwards quite a lot. This one gets adjusted downwards. Combined, if you combine the data that were informing these adjustments, you'd have an adjustment factor of 1, which is clearly much closer to this moderate station than it was to this station. It was smoothing away the effect of the high competition here. Now suppose weight per unit effort in this high competition area was 10. Could be pounds per skate, it doesn't really matter. And then the second station was 50. The average of these is 30. Okay. The adjustment using the old method would have taken 1 times 30 and got 30. Under the new method, we would have calculated the weight per unit effort for this station as 1.69 times 10, 16.9, and 0.93 times 50, 46.5, and average these. Now that's not exactly what we're doing. Those are data that go into the model, but this is essentially how it would play out. And we get a slightly higher weight per unit effort with a small positive adjustment relative to this. But suppose we switch things around, and now this high competition area is also the high density area, the high weight per unit effort area, and this is the low weight per unit effort area. The old method still gives you 30 because it just has the same aggregate adjustment factor. But the new method would adjust this upward to 84.5, and this one downward to 9.3, and the average suddenly is much higher. It's taken into account the effect, I think more appropriately than the old method, of local competition around this station and the lack of local competition, lower levels of local competition around this station. So, sort of summarizing that, effects of the changed station level adjustments, if you have low to moderate competition plus high weight per unit effort, you get a small increase in overall weight per unit effort. If you have high competition and high weight per unit effort together, you'll get a much larger increase in overall weight per unit effort. Area 2A happens to be an area where the stations with high competition have relatively low weight per unit effort. And this is not the case in almost all other areas. It's somewhat true in Area 2B, and it's part of the reason 2B has a lower apportionment value as well. There are other reasons in 2B. Where for the first time we're estimating weight per unit effort in areas like Dogfish Bank and the Strait of Georgia based on depth relationships and the proximity in the Strait of Georgia to information we have in Area 2A. So that's also reduced weight per unit effort in Area 2B through improved information. But in other areas, we don't have this. In Area 4B, for example, the opposite is going on. The areas high competition are also the areas with higher than average weight per unit effort. So looking at 2A, after broken the station, just to simplify things, they've broken the stations into those with a weight per unit effort greater than 30 pounds per skate in 2016 and those with a weight per unit effort less than 30 pounds per skate. The average is about 29.3, so that's about average. So these are above average stations, these are lower than average stations. And the level of competition of these ones, these higher weight per unit stations are somewhat lower, and these ones are somewhat higher. The mean adjustment factor, we calculate an adjustment factor for every station now, is 1.39 for the high weight per unit effort stations, but it's higher for the lower weight per unit effort stations. The mean weight per unit effort for these stations is 85.1, for these stations at 9.7. Clearly there are more of these than those, for the average to be 29.3. The mean adjustment factor is 1.5. Now the adjustment factor using the old method is also 1.5. That's a coincidence. It need not have turned out that way because the calculations are quite different. This is based on aggregating the data over the area. This is based on the average of the station level values. Using the old method, we'd multiply the 29.3 by 1.5 and we get 44 pounds per skate as the adjusted value. The new method instead adjusts all of the individual station weight per unit efforts, and the average of those for these high weight per unit effort stations is 107.8. For the low, it's 15.0, and then we average all of the adjusted station values, we get a value of 39.1, because it turned out we had more competition in the areas where we had lower weight per unit effort, and that leads to a lower adjustment than we would have got using the old method. It's not dramatic, but it's enough to contribute to a lot of the way to the change in apportionment that we've seen. We think this is an improvement. It's a change, but it's an improvement because we are much better accounting for the effects of local competition than we were previously. So that is, in a nutshell, the explanation why, most of the explanation why the apportionment in Area 2A and to a lesser extent in Area 2B have gone down, and somewhat the reverse and happened in Area 4B. Okay, final comments, and this is the first year, some additional comments. This is the first year in which a consistent approach has been used to estimate both weight per unit effort and numbers per unit effort. Previously, numbers per unit effort using the assessment did not have those competition and survey timing adjustment factors applied. But now we're fitting the same models with the same adjustments to both indices, so we have a more consistent way of dealing with estimating these indices. And the use of the space-time modeling brings us in line with the modern analytical approaches used elsewhere. This is not a new method that we've conjured up out of nothing. In fact, I've been working on some version of this since 2008. And finally, the method's kind of caught up with what I wanted to do. But this is being used on the West Coast and other areas for their own index calculations. And these model estimates are going to be further improved as additional data become available. This is not something that is frozen in time. We're going to be doing survey station expansions in areas 2B and 2C in 2018 and 3A and 3B in 2019. And we've heard word of possible expansion of the Stroll survey in the Northern Bering Sea, maybe in 2017. We'll be getting new Alaska Department of Fish and Game data and Northern Sound in that year as well. And so estimation will continue to improve as more data become available. So there's not a static process, and we certainly think this is a vast improvement in what we've been doing previously. And hopefully the output you've seen so far affirms that in your own minds. Thank you.
Thanks very much, Ray. Any questions for Ray from U.S. Commissioners? Jim?
Yeah, so thanks, Dr. Webster. That's a good presentation, and it's the first time I've seen any of this stuff. And it may not be a dramatic change, but it's going to be significant and important to some people. So I'm wondering, does the public have access to this? And if not, I think they need to have it very soon, because we're going to require some intense examination of these things so that they can understand it before we get to the annual meeting. So I know that's on the Commissioner's website, but I'm not sure what the plan is for putting presentations on the regular website. And of course, the people on the webinar are seeing these, but people at aren't on the webinar, perhaps in this room. I don't know if they're taking pictures or if they have enough in their notes to go forward in this or not, but it's kind of overwhelming even for us with these things here, even though I looked at it a little bit yesterday. So long question.
Steve Keith has whispered in my ear that these presentations are going to be posted to, today for the public.
Thank you very much. I appreciate that. So,
Linda?
Thank you, Ray. I just compliment you. This seems like a really significant improvement in the survey and our ability to estimate abundance and do the apportionment and all of it. Just a really big step forward. I was going to add to what Jim said that it might be helpful to include the extra slides for 2A but also 2B, 2C if you have those, so people can see if the patterns, the explanation is somewhat the same of going from specific survey sites to the whole area and that change, and to be able to follow that on an area-by-area basis.
I can add those slides. I have the information. I'll take it. May not come up today, but we can update as I calculate those values.
Thank you.
Bob?
Yes, Mr. Chairman. Ray, on the modeling component, do you use the current year's survey information in that?
Absolutely, yes. That's very important. Probably the most relevant information for the current year is the survey data that we get in the current year. So we have current year's satellite survey data, including the expansion in Area 4D. We have the current NIMS troll survey information, and we have the current NIMS sablefish data.
Mr. Chairman,
Go ahead, Bob.
Another question. So when we had our new survey stations for a year in southwest 4A, those numbers came in as a surprise to the staff in that they were more robust than we thought they might be. Which drives a question on the modeling. How far out is the modeling good for per station? Is it 2 years, 3 years before you have to redo a station in order to keep it up to date?
And that's a very good question, Bob, and that's something that's an evaluation that we'll be undertaking in the coming year. It's not a simple question. It depends on the area. For example, that part of Area 4A and the western part of Area 4A where we had very high catch rates, including in deep water, there are some stations that we fished on an annual basis. So those the gaps there are relatively close to stations in which we fish. So the need to go back in a short period of time might not be as great compared to an area like the Salish Sea, which is more separate from, I haven't evaluated this, but that's a possible example, which is more separate from the coastal stations in Area 2A. So it seems that the estimates we're getting in that part of Area 4A are still consistent with what we got in 2014. They're consistent with the trends that we're getting now, and also that we observed greater catches in deeper waters. But if something different is happening in that area, if something unique is happening in that area, it's got a unique trend, we're not catching that without revisiting that area. But it is a relatively modest part of Area 4A. It continues to inform the data. The evaluations, the need to revisit areas will depend also on their effect on the overall weight per unit effort for that area.
No other questions from U.S. Commissioners? Jim?
Just very briefly, Rick, you said that the X's, way back in the surveys where there was an X, and I think your language was, it says no data was acquired at those stations. But basically...
No halibut were caught, yeah.
Right, so there's data there.
There's data. If I said that, I misspoke. I mean that no halibut were caught at those stations.
I wasn't faulting you. I just wanted to make sure I understood.
No, thank you. The areas with no data are the big white areas with nothing in them.
All right. Any Canadian commissioners have a question?
Good morning. Ray, I appreciate your hard work here, but I think I asked this question a couple of years ago even about, I was looking at how you presented the stations in a color-based format where they're continually changing, and then you had all kinds of area that was continuously blue, like the patches of bottom that were consistently unproductive when it came to quantities of halibut that were relative to an argument as far as I could see. But I was talking to Dave about it, and he basically said it's really important that even zero calculations are important in your equations, but still on the basis of like the cost associated with expanding surveys versus going back to survey sites that are consistently zero, it didn't make any sense to me that there would be need to do that. Why wouldn't you revisit these, put an assumption there and revisit these stations every third year or something like that?
Okay, I've got the Bering Sea example up. There's a couple of things about that. One, fortunately we don't have to do the work in the Northern Bering Sea, or we don't currently do the work in the Northern Bering Sea. NIMS does, so we're making use of their data. So that would be a question for them. Of course, they're not just surveying halibut. But an area like this is particularly interesting because the distribution is quite likely changing with time, or quite possibly changing with time. As the ocean warms, more habitat might become suitable for halibut. By having stations in those areas, we're able to track the changing distribution of halibut with time. And that may be also the case in the southern part of Area 2A, which is the other area where we have catch rates close to zero in parts of Northern California. It's a relatively small area compared to this, so I need to revisit this on a regular basis. On an annual basis is not great for our purposes, although the local folks that are be interested. But in general, we don't have a lot of empty wilderness of halibut habitat where we don't get anything. And we do have changes in the distribution. If I produce maps for other areas, for example, 3B, where the distribution has come down a lot in years, you look at the 3B now, and you say, well, you might say, why would we put stations in some of these parts of 3B? But they were very productive areas back in the early part of the time series. And so if we keep stations there, hopefully we can track the increase in productivity in those areas as well. So zero to us is worth as much in understanding the index as data, but non-zero catches. But I think there are good reasons for keeping those stations there as the distribution of halibut changes.
Dave, go ahead.
Ray, could you give me a quick refresher on the methodology and the drivers of the hook competition calculations?
I will try. Excuse me, I'm losing my voice somewhat. Okay, and I will be detailing, reviewing this in the report that accompanies this presentation, which is with the editors now. So the idea here is that the amount of bait that we get back on a station gives us information about the level of competition that halibut had to face for those baits. So if we get relatively few baits back, that implies that there was a greater level of competition at that station than compared to a station which had many baits back. And if there are lots of baits coming back, then presumably there isn't so much out there, because they tend to get eaten. If there's something that's hungry and it's in the vicinity of the line, then they'll generally go for the baits. And we see this in looking at the values we get for competition. We kind of ground truth those by looking at the catch rates of non-target species. And we tend to find in competition changing, say, in areas 2B and 2A, increasing levels of hook competition adjustments when we have increasing catches of dogfish, for example. Those things tend to go hand in hand. So we can come up with some sort of understanding of why these things are changing by looking at those data. Although those data themselves don't directly feed into this, apart from the fact that those creatures had to take a bait, and they've reduced the number of baits. So the number of baits as a proportion of the number of hooks that were set, that proportion goes into some formulae which, excuse me, which then produce the adjustment factor. It's based on some theoretical considerations regarding how quickly baits are likely taken by fish. So early on in the set, early on in the soak, there are more baits available, and they decrease exponentially with time. Most of the baits are taken early, and then they start trickling out. So there's a theory behind the rate of bait removal that goes into the formula for the adjustment. And I'm not sure what else to say. Does that help in any way, Dave? Or you'll wait for?
Yeah, I'll look and I'll await your other documentation.
Yep. Yeah. And I can refer you also to the reports in which this was detailed in more detail. Bill Clark came up with the method back in 2006 or 7 when we first went to the apportionment process. We revised it slightly since, but there are a couple of RARA documents I can direct you to as well, Dave.
Thank you.
Ray, can you just remind me of which areas we've undertaken the survey expansion in?
Sure. We actually began the expansion with a pilot in Area 2A in 2011. And that area was targeted because it was an area which had previously had relatively imprecise estimates of weight per unit effort for the area. So we prioritized that as an area which we'd like to see more survey effort. And so we did a pilot in 2011 where we added deep stations and cellular stations and filled out some gaps and added the Salish Sea. In 2014, we repeated our expansion in Area 2A and added stations in Northern California down to 39 degrees north. And we also undertook the expansion in Area 4A. In 2015, we repeated our 2006 Eastern Bering Sea Flats survey, the less dense grid of pairs of stations, 83 stations we fished in 2015. In 2016, on this figure here, we fished these stations up on the northern part of the Bering Sea edge, plus filled in some gaps along the edge. And now we can predict at those stations, as the map in front of you is showing. We only got data in 2016, but we get predictions in all years. And as we'll mention in the talk that's coming up, next year we'll be doing Area 4B. In 2018, we're planning 2B and 2C, in particular interest in filling in the gaps in the Strait of Georgia and around Dogfish Bank and some of those inside waters in 2B. And finally, not counting any repeats of expansions we decide to do following an evaluation, we'll be rounding things off in 2019 in 3B and 3A. Okay. So for now, we haven't done most of the Gulf of Alaska is the summary. We've done most other areas, and we haven't done 4B.
All right, thanks, Ray. Dave, just checking on time. I wonder if it's a good point to take a break now. Steve? I think we'll just hold that for now. Is this a good point to take a break?
Certainly, Chair. I think on the schedule we're due to break at 10:30 for 15 minutes. So now's a suitable time before we move on to the stock assessment.
And Steve, is this question around Ray's presentation? Okay, so why don't we take that question and then we'll take a break.
Thank you, Mr. Chair. The question is from Bruce Gabris, who asks, Ray, how do you adjust for a rough bottom and baits that are suspended and not available to bottom fish?
No, I'm not sure that's related to the whole competition. The rough bottom, so is that's habitat that's generally unsuitable for halibut, is that correct? Or okay. Bait's not on the bottom. I mean, there's no specific adjustment made for that in general. We're sampling habitat in proportion to its presence with a 10 nautical mile grid. That does a good job of doing that on the large scale that we're doing undertaking our survey in each area. So habitat that's unsuitable for halibut will be surveyed in proportion to other halibut habitat. Two similar words. I'm getting tongue-tied. I don't know. I have to defer to other people to answer the part about baits suspended on the bottom, above the bottom, because I'm not familiar with that.
Bob?
I think what Bruce might be asking is it is good habitat for halibut, but because the gear is suspended, it may not be, they might not be able to take the bait.
So that may be a question for our survey staff and how they undertake the survey. But maybe that's something we can come back to after the break, perhaps.
Sure. Why don't you do that, Ray? And I think that would be good. So it's 10:30. So let's get back together here at. We'll start at sharp at 10:45. Thanks. Questions from the public and online. I did take that one question there on Ray's presentation, but we're going to hold off on any other questions until after the presentation from Ian. Is it just yourself, Ian? Okay. And then we can go back and cover both presentations, questions, both here in the room and for people on the line. Just wanted to clarify that. So I'll turn it over to you, Ian.
Thank you, Mr. Chairman, and good morning. I guess maybe before I start, I'll follow up on that question that we left at the end before the break there. Ray covered a lot of the heavy lifting already this morning, so I'll cover him on this last question. The question, I think, as we talked about it a little bit, was really about clotheslining the gear and how that might influence the relative catchability of that set for halibut and or other species. And I think the short answer is that we try to standardize that. Talking to our survey team, they do their best to standardize the weights that they put on intermediate to the set, and we allow the skippers some latitude to set in an orientation that would minimize the poor fishing that we might achieve by clotheslining the gear substantially. But stepping back from that, I think we have to remember that our survey is a pretty blunt tool to measure the entire population, and certainly something like an area, a broad area of very rough habitat could lead to a slight difference in catchability for the survey across that area, relative, for example, to an area with broad sandy or gravelly areas where the gear was fishing very consistently on the bottom. So with that answer, I'll go ahead and launch into my presentation here of the 2016 stock assessment, decision table, apportionment, and harvest policy results. I'd like to start off by noting that we are essentially doing a real-time stock assessment. We had a question earlier about whether we're using this year's survey data. We're using this year's everything data, and we just closed those data sets about 18 days ago. Not about, actually, exactly 18 days ago. I know, because I've worked pretty much every one of them. It takes a lot of work to make this happen, and although I'm going to be giving the presentation today, I'd really like to thank everybody who provides the data to me. I think that the lesson here is that it takes an entire team to land a big fish. The IPHC staff, this is my 5th year doing the stock assessment, and every year I'm amazed at the quality of the data and the timeliness of it getting to me at the end of the line. A lot of other people don't have a lot of turnaround time on their products either, but I'm sort of the last deadline on the whole schedule. So I definitely want to thank the IPHC staff for all their work. As you noted, it took Ray 45 slides to describe his work, but he needed to complete all of that with the final data just in the days since we finished this year's setline survey. I'd also specifically like to thank the various agencies that report to us, particularly the National Marine Fisheries Service, Alaska Department of Fish and Game, Fisheries and Oceans Canada, and the 3 state agencies down here in Area 2A. If they don't report their numbers to us on time, then we're hung up and we're waiting on them. And again, this year they've done a great job of getting the information to us. So I really appreciate all of the timely information that we get that really make it possible for us to do an assessment and show you guys the results that reflect the best available data that we have right now, not last year or the year before, but as complete a data set as we can generate. So I'm going to start with a summary, and the summary for this year is really no surprises. We see continued slow stock increases coast-wide. Importantly, we've seen some pretty big bycatch reductions in 2016 relative to where we were in 2015. And as you'll see, and I'll talk a lot more about each of these points as I go along, as you'll see, the harvest policy results are somewhat variable among areas. I'm going to present a little bit more information on harvest policy calculations this year than years past. But all of that information shows somewhat variable results. Some areas up and some areas down with different harvest policy calculations. So to outline what I'm going to discuss today, I'm going to start out with the data. And a good chunk of this talk is about data because I think it's very important to be able to see the trends right in the data. And the models are really just there as smoothers to help us visualize the trends in the data and to produce some specific numbers from what we should already be able to see in each of the various data sets. So I'll go through the removals from the halibut stock, some trend information from the survey and from the fishery data, as well as talk about the biology and the various observations we've seen from age and size at age and size of fish. Then I'll go into the stock assessment modeling, show you the output of the models, followed by the summarizing that output into the decision table for this year. I had allowed for a break there, which we can take or not at your discretion. I'm happy to go right through this presentation. It's about 70 slides long, and it'll probably take about an hour and a half, so I'll leave it to your discretion when we get to that point whether you'd actually like to take a break or whether I should continue on. I will then go through the apportionment results, both the time series and the results specific to this year, and finally I'll finish off with the harvest policy calculations and the specific catch tables by regulatory area. I really thank Ray for going first this morning and giving you a detailed look at the new survey results. That was really a down-in-the-grass look, and we felt it was important to provide the details so that you could really understand where some of the changes for this year came from and why some of them have occurred, and really also just to show off the work that Ray's done, because it's really brought the IPHC back up to kind of the forefront on that kind of modeling. We're really back up with the state of the art for that kind of survey modeling. So I thank Ray for going through that. This presentation will focus more on the mile-high view. I'm going to be focused more on the broader trends, comparisons across areas, and some of the specific numbers that feed into the subsequent calculations. So with that as a preface, I think I'll launch right into the data session. You've seen this figure before. We just added 1 year on the end of a 100-year time series. This is the time series of historical removals, and each of the various sources that we've delineated them out is listed here, from fishery landings, which is the dark green band across the bottom, fishery wastage, orange above that, sport or recreational removals in blue above that, personal use and subsistence in the black band above that, and finally bycatch in non-halibut fisheries, or bycatch mortality in non-halibut fisheries at the top there in purple. And what I just want you to note, remember from this slide from previous years, is the amount of variability we've seen over the time series. We've seen 4 big peaks in removals, followed by, most of them followed by dips, some of them quite substantial, even below where we've been recently. And then you can see at the end of the time series, things have flattened out, and we've now had 3 years of more or less similar overall removals from the halibut stock. I'm going to zoom in now at the very end of actually before I do that, I want to note that the 100-year average removals from this stock is about 63 million pounds. And without any models whatsoever, we can get an estimate of, yeah, that's probably about the average level of productivity we might expect to get out of the stock over 100 years. That's several generations of halibut, and that's a pretty good estimate of something like MSY. But I would point out here that if you count the number of times we've actually passed through that, it's exactly 4. So it's not a static target. We certainly shouldn't expect that if we did everything right, we would get 63 million pounds every year. That's just the long-term average out of the stock. If we zoom in now at the very end of the time series, so you can see a little bit more detail, what you can see here is that the rainbow of colors gets more and more pronounced as time goes on. And I think that's been kind of the lesson both in terms of the spatial exploitation of the stock, as well as the exploitation across different user groups, different sources of removals from the halibut stock. The halibut fishery and stock is essentially fully subscribed now. We are exploiting this species across its entire geographic range, and today in 2016, perhaps more so than at any other point in its time series, the overall removals are more divided among different user groups than they ever have been. Early in the time series, it was pretty much just the directed fishery with very little components of other sources. Beginning in the 70s, we saw the sport fishery take off. And with the imposition of a size limit, we saw more wastage in the fishery. Bycatch started in the 1960s, but essentially today, this pie is divided into more pieces than it's ever been in the past. So I'm going to zoom in now on the 2016 removals, and I'm looking at this by weight because weight is the term that we use to describe most of the regulatory limits, both for bycatch and commercial landings, as well as recreational removals. That's all done in weight. Noting, however, that if I made this pie chart in terms of numbers of halibut, it could look quite different, and that's something we'll look at more in the context of harvest policy in the future. But I want to point out on this figure that today in 2016 across the entire coast, 60% of the removals from the halibut stock are coming from the directed commercial fishery landings. About 17% are coming from recreational and mortality due to bycatch in non-halibut fisheries, and there's about 3% each coming from wastage and personal use and subsistence. So this is the broad view across the entire halibut stock. To give you a sense of how this has changed over the last 5 years, this is a table that reflects those same categories over the last 5 years, so we can start to see where we've seen some trends. And I will note, based on the question that we had earlier from Jamie's talk about some level of detail of recreational and personal use and subsistence across each of the regulatory areas, this is a coast-wide table, and I have a table at the end of this talk for each of the regulatory areas with these same removals. So if you're interested in a particular component in a particular regulatory area, please ask me after the presentation, and I can call up that slide. It'll be included here. So I want to point out a couple things, a couple trends over the last 5 years. The first is we've now gone 2 years in a row with increases in landings in the directed commercial fishery. And this is pretty important because this is the first time since in more than a decade that we've seen increases at all, even for 1 year, in the landings from the directed commercial fishery. So I think this reflects some of the relative stability that we've seen over the last couple of years. In contrast to that, I'll draw your eye to the fourth column here, which is the estimates of bycatch across the entire coast. And this is from all non-halibut fisheries across all regulatory areas. Noting here that we've seen a substantial reduction in bycatch from almost 9 million pounds in 2014 to almost 7 million pounds in 2016. So one of the points that I noted in last year's presentation was the substantial reduction we had seen from 14 to 15. And that reduction was even ahead of the changes in PSC limits that were put in place by the North Pacific Fishery Management Council. Those changes in PSC limits didn't take effect until 2016, but the reductions in bycatch in many of those areas were seen actually in 2015. So these are preceding the actual regulatory action. You'll note at the bottom here that there's a star next to the 2016 value, and I want to talk about that for just a second because this is a place where the National Marine Fisheries Service, particularly the Alaska Regional Office, provides us with in-season estimates of bycatch as of the end of October, and as well as projections that extend through the end of the year. So that 7.1 million pounds is a preliminary estimate because obviously some of these fisheries are still ongoing. And I'll note that when we get to the annual meeting, the catch tables that I'll have for you at the annual meeting will reflect updated values that will be reported to us after the first week in January. So this is the best estimate we have at the moment, noting that we will have perhaps a slightly more refined estimate when I show you the final tables at the annual meeting at the end of the year. The last comment I'd like to make here is that these two things have more than offset each other. So you'll see that from 2014 to 2016, we actually estimate that we've been able to reduce the overall mortality on the halibut stock slightly, not a huge amount, but slightly, despite the fact that we've actually increased the landings in the directed commercial fishery during that time period. And again, that's due to this very large decrease in bycatch. And I'm going to talk a little bit more about the relative value of bycatch in the last couple of years. So this next figure shows you a time series from 1990 onward of bycatch from all non-halibut fisheries. This is bycatch mortality, not the total number of fish handled, but the total number of fish that we think died as a function of that handling. The black line at the top shows you the total across the entire coast and all regulatory areas. And you can see each of the regulatory areas down below, although noting that there's really only a couple of them that are visible. Most of the bycatch on a coast-wide basis comes from just a few of the large regulatory areas. And I want to particularly draw your eye to these last 3 points here for Area 4, C, D, and E, noting that we saw a big reduction between 2014 and 15 in bycatch in Area 4, C, D, and E. And again, we saw a further reduction from 2015 to 2016 in Area 4, C, D, and E. And that pattern is what's largely driving that reduction in overall bycatch. The other regulatory areas are somewhat varied. That, as you'll see when we get to the harvest policy calculations, that reduction in Area 4, C, D, and E is going to be very important for the amount of yield that we estimate to be available for the directed halibut fishery in that particular regulatory area. Now, this is the picture since 1990. I'd like to broaden the context a little bit and go all the way back to our first estimates of bycatch back in the early 1960s. Now, this reflects a time period when much of the bycatch was coming from foreign fleets operating off the U.S. and then slightly later both the U.S. and Canadian coasts before the imposition of the EEZ. And I'll note that these bycatch estimates, particularly before, say, the mid-1980s, are much less certain. There was a lot of fishing going on. Not all of it was observed, although there was an observer program at the time. So certainly a much broader degree of uncertainty. We do, however, think that prior to that period in the early 1960s, there was probably substantially less bycatch because there was just a lot less fishing going on. Really, industrial fishing first ramped up in a very broad scale when these big foreign fleets hit the coast in the early 1960s. And what I want to point out, what I want to focus on this figure is that, again, that 7.1 million pounds in 2016, and putting that in context, that is in fact the lowest estimate of bycatch that we've seen in our entire time series. Now, granted, there was some bycatch prior to the early 1960s, but we do think it was probably of a much lower magnitude than the values subsequently seen, because the foreign fleets really did arrive in those years in the early 1960s. So again, to reiterate, where we are right now is at the lowest level of bycatch that we've seen in our reconstruction of that source of removals. Okay, I'm going to move now into some survey trends. And again, I thank Ray for doing the really heavy lifting and explaining to you where these data come from. What I'm going to be providing you in the next several figures here is trend information that comes from the analysis that Ray just did. So these are not raw data, so to speak, but these are actually the output of Ray's space-time modeling. And again, that's really brought the IPHC up to standard with the state-of-the-art of how other agencies and organizations are analyzing their fishery-independent survey data. So in this first figure here, just to orient you, I'm showing you the trends by regulatory area of legal or O32 weight per unit effort captured in our setline survey. Each of these panels represents a regulatory area with the label in the upper right. And you'll see in this figure they're all plotted on the same scale. And that's useful because it allows us to very quickly see, well, historically, where were the highest catch rates? Well, they were across the center of the stock, particularly Area 3B prior to 2000 had some of the highest catch rates we've seen on the coast. And we can also see where are the highest catch rates today. And I put a line there just to draw your eye to Area 2C, which at around 250 pounds per skate is currently the highest average catch rate in our setline survey for any regulatory area across the coast. Now, the downside of this figure is that it's really difficult to see the trends, for example, in Area 2A in the upper left or Area 4 C, D, and E in the bottom center panel. So I'm going to go now, my second figure here, to the same figure, but now each of these panels is going to have its own scale, so you can see the trends a little bit better across each of the regulatory areas, noting that since they're on a different scale, they're not as directly comparable as they were on the last figure. Now some stronger patterns come out, and I'll point out that the upper right of each panel indicates the label of which regulatory area it is. The bottom right indicates the total across the aggregate total across the entire coast, or the entire setline survey. The percentage below each of the area labels represents the percent change from the 2015 to 2016 survey estimate. Again, these are the estimates that come out of Ray's space-time model. So I'm going to go, even here, it's still a little bit hard to see the detail. So I'm going to step through row by row through this figure, and I'll highlight a few of the trends that I see. The other thing I want to point out here is a couple places where we do see some difference between the trends that we see in the setline survey and subsequently, I'll show you in a second, trends that we'll see in the fishery weight per unit effort. And that's primarily why I spend so much time on the survey legal size weight per unit effort. One, because it feeds into apportionment, and two, because it's most directly comparable to those trends that we see in the fishery logbook data. So starting with Area 2, now zooming in, just zooming in on the top row of that previous plot. Now hopefully you can see the trends even better, and maybe even at the back, from the back of the room, read the labels and the percent change. What you see is across Area 2, we see strong increasing trends over the last 5 to 10 years, depending on which area you're in. Now you may note from previous years, when I was showing you raw survey indices, that these are somewhat smoother than they've been in the past. Again, Ray commented on this as well. The use of the space-time model has removed much of the observation error that we had in previous surveys. Things that we used to view as a change in the index and possibly a change in the population now is being accounted for with a more savvy treatment of hook competition and a better treatment of some of the gaps in our survey. And so what we tend to see is a smoother trend across these surveys. And in fact, I think across Area 2, this new approach has essentially sharpened our understanding that, yes, the stock appears to be increasing across Area 2 pretty consistently. Note that there is a 5% decrease in Area 2A between 15 and 16. But again, given the confidence intervals there, I think it's quite clear that all of these areas are showing a fairly clear increasing trend with all three slightly different time periods. Area 2B being the longest pronounced increasing trend, and Area 2C perhaps the steepest of the three. I'm going to contrast that now with Area 3A, 3B, and Area 4A across the center of the stock. All of these areas, although these series are slightly smoother, all of these areas have come down from historically very high catch rates around 2000, slightly before or slightly after, depending on the area. And what you can see is at the end of the time series now, for the last 3 to 5 years, we've seen some stability in our survey index. Some of them are slightly up and some slightly down at the very end of the time series, but I would generally focus on the trend in these areas. Noting that even in a case like 3B, where we saw a 12% increase between 15 and 16, and actually a slight increase between 14 and 15, we're still, the last 4 to 5 points in this time series are essentially the lowest in the whole series. So we are basically at historical low catch per unit effort in our setline survey in that regulatory area. I'll comment here as well that just to note that we'll see something slightly different in the fishery catch rates for Area 3A and 3B. So note that this flat trend in the survey, and I'll revisit that when I get to the fishery trends. Moving now to the farther west and northern parts of the stock, Area 4B looks a lot like Area 4A with high historical values and perhaps some stability at the very end of the time series, although again here some of the lowest weight per unit effort of legal fish that we've seen in the entire series. Slightly different in Area 4C, D, and E. As you noted from Ray's presentation, there are a lot of moving parts in Area 4C, D, and E. This index represents an amalgamation of 3 different surveys and lots of different pieces of coverage of different parts of the Bering Sea, around the islands, around the edge, the flats, Norton Sound. However, you can see here, maybe not that dissimilar from Area 2, that we see a period of 5 to 8 years of somewhat increasing trend at the end of the time series. Not much change between 15 and 16, but it's clear that we have seen some increases over the last, say, 5 to 7 years in that area. The right-hand panel here now shows you the aggregate across the entire coast. And this, again, this is very similar to what we've been seeing essentially for the last 4 years in the survey output, which is that we saw that long decline through about 2010, and basically since 2010, with a little bit of up and down, we've seen some stability in the stock. Now, I will note that when I first started this assessment in 2012, there was that slight uptick there, but at the end of a long decrease, it was very hard to say whether that was just 1 year up or one, slightly different, whether we could still be on a downward trend in just 2 years outside of that. What we can say, I think, now is with 5 or 6 years in a row of essentially flat survey trend, I think it's pretty clear that we've seen the stock stabilize at its current biomass level for legal size halibut. Now, I want to compare that to the fishery weight per unit effort, noting that because we're doing a real-time stock assessment, these data are incomplete. This is probably the most incomplete data set that I have to work with, and that's because we closed the data sets this year on the 11th of November, and the fishery itself only closed on the 7th of November. So not only are there still some log books that are in people's wheelhouses that we haven't had a chance to collect yet, but we've even got a few that we've collected and didn't have a chance to enter back at the office. I will say, though, that our data entry team and our port samplers did an incredible job of this year of increasing our sample size relative to what we've had in previous years. And so we actually have, in terms of data quantity, we have nearly the quantity of data that we have in most years. We've probably fewer logs outstanding this year than in most years. But still noting that the 2016 data are always incomplete. And we will continue to pick up those logs. So if we didn't, for example, we didn't get your log at the end of your fishing season this year, we'll get it next spring. We'll get it included. And when I show you the next year's stock assessment, those data will be included in the 2016 estimate. I'm going to do the same thing I did with the survey, and I'm going to go row by row here so you can see a bit more detail. The layout of these figures is the same. It's weight per unit effort, and of course it's legal weight per unit effort because it's commercial fishery log books. And I'm going to start with Area 2. And the big difference between what we saw with the setline survey and what we see in the fishery log books is the 2016 value for Area 2A. It was down 47% in the log books. And when I first saw this number, I actually sent it back to our data entry and port sampling crew and said, I'd like you to take a little deeper look at this. I want to make sure this isn't a data entry problem. And they went back and went through the logs, and we actually had pretty good logbook reporting. I believe this represents 150 or 160 logs, which is not too far off what we usually end up with for Area 2A. And in fact, even after finding a few minor errors, this estimate didn't change very much. I want to note here that the fishery in Area 2A is different than any other on the coast in that both the tribal and the non-tribal fisheries in Area 2A are still essentially derby fisheries. The commercial fishery had, I think, a 3-day opener, and I think the tribal fishery was more or less of similar duration. So these are short duration fisheries. There's a lot of effort in a short amount of time, and perhaps not the same luxury that the other areas have to make the best use of their time in fishing. That said, this is a big difference from what we saw in the setline survey. Looking back through the time series, you can see there are several other years between 2006 and 2007, between 1998 and 1999. We've also seen some big changes in 99 and 2000, some big changes in the time series, big drops of a similar magnitude to this. I would say that of all of our regulatory areas, the commercial catch per unit effort is probably most variable in Area 2A relative to these other areas. That said, I'll draw your eye to areas 2B and 2C, where I think more so than in the past, these increasing trends in both of these areas in the fishery are more closely matched by the output from Ray's space-time model in the survey, where in the past we've had some slight divergence between the survey estimates and the fishery. Both of those increasing trends at the end of the time series quite closely mimic what we see here in the fishery catch rates. The other thing I want to note about this figure is that these time series go back farther than we have for the setline survey. These go back all the way to 1984, which is the first year that circle hooks were broadly used. For the setline survey, we only have currently coast-wide estimates from Ray's model from 1998 onward, although he is working over the next year to piece together longer time series for some of these regulatory areas where we do have additional survey effort prior to 1998. Moving now to the center of the stock across Area 3A, 3B, and 4A, you'll note that the same general pattern holds that we saw in the setline survey, which is quite large historical catch rates through sometime in the late 1990s or early 2000s, followed by that long period of decline, just like we saw in the setline survey. However, at the end of the time series, I'll draw your eye to both 3A and 3B, where we saw an increase last year in fishery catch rates in 2015, and slight increase or pretty much the same value for 2016. So we now have 2 years in a row where we've seen a bit of an uptick in the catch rates in the directed fishery, but we have yet to see that same response in the setline survey. Now, one explanation for this would be there's been an increase in the catch rates in certain dense patches of fish, and that has, as of yet, not spread out broadly across the geographic area. The fishery has the luxury of focusing on those areas with the highest catch rates, and so if we see localized increases in catch rates, the fishery can capitalize on that, where the survey continues to maintain the same design, and we'll only see that same sort of increase if and when those fish tend to spread out and occupy a broader distribution. It's one of the benefits of a survey, but it's also something that we can perhaps learn in addition to that survey information from the commercial fishery. I'll also note that Area 4A looks a lot like the setline survey in that although we've got some stability over the last 3 to 4 years and a slight increase from 15 to 16, we are currently at the lowest catch rates we've seen in both the survey and the fishery data for Area 4A. Moving finally to the western and northern areas of the stock, on the left-hand panel you see Area 4B, which was considerably down in 2016, 24% below where it was in 2015. But again, Area 4B is also an area where we have a substantial amount of variability in the logs. And I would say that over the last 3 to 4 years, there's some evidence of a relatively stable trend there, although we certainly want to watch that area to see if that low value in 16 persists in future years. Recalling for a second a question that came up earlier about logbooks in the Bering Sea, you'll note that I have a series plotted separately for Area 4C and 4D here. What's missing is Area 4E. And although it's correct to say that we are getting logs from Area 4E, I went back and checked the numbers after that question came up. In 2015, we got 6 logbooks from Area 4E, and in 2016, we got 1. And so that's not enough data for me to plot on this figure, and it would be extremely helpful for us in understanding the dynamics of the stock and the fishery in that area if we could get a larger sample size of logs. To do this is probably going to require that some vessels under 26 feet in length voluntarily report their logs. They're not required to if they're under 26 feet, but that does represent a good chunk of that fishery. Now I realize in the last couple of years that fishery's been prosecuted slightly differently in 4E. I believe there's been more quota leasing from some of the small boats to other vessels, and the vessel that we are getting from Area 4D I think is one of the vessels that leases some of that quota. Nonetheless, 7 logs in 2 years is not enough to give us trend information for Area 4E, so it would be very helpful, and it's really the only direct information that we might get from that fairly large area, as you saw from Ray's talk. Focusing on the 2 areas that we do have data for, they're both somewhat variable, but you can see that both Area 4C and Area 4D are at essentially historically low catch rates in the commercial fishery, where we had seen some slight increase in the catch rates in Area 4C that Ray showed you in the breakout from the setline survey for that particular sub-area within the Area 4C D&E. It's been relatively flat with a slight upswing in 15, but then back down again in 2016 in Area 4C, the blue series in the center panel here. Looking at the far right-hand panel, I could almost change the label and it would look exactly like the setline survey series, except that it extends a little bit farther back in time. We essentially have that long decline from high catch rates in the late 1990s through about 2010, and with a little bit of up and down, we've got essentially a flat series since 2010. And so I find this reassuring that we're seeing signs of stability in the catch rates in both the fishery and the survey across the entire range of the stock. As we know, halibut are dynamic, and as you'll see later in this talk, there's been a lot of changes and dynamics going on area to area, but in aggregate across the whole stock, it's quite clear that now after 5 years, I think we can conclude that the stock has reached some level of stability at a coast-wide basis. Now, I want to also show you, and this is something that Ray didn't bring up in his presentation, other than to note that we are now also calculating the survey numbers per unit effort in the same way that we're dealing with the weight per unit effort. And this is, again, this is a reprocessing of the data, and some of the patterns here are slightly different than I've seen in previous year's results. So this figure shows you across a constant scale all the regulatory areas so that you can, again, see which are the areas with the highest numbers per unit effort in catch from our setline survey. I'm sorry, I'm back to the survey now. And this is all halibut, not just legal halibut, but sublegals as well. And you see that we see the largest numbers of fish across the center of the stock, area 3A and 3B primarily, of essentially 20 fish per skate on average in the recent time period. I'll draw your eye to areas 3B and area 4A, which have shown a prolonged decline. Instead of stabilizing the way the weight per unit effort series has done, perhaps a little bit in area 3B, but not so much in area 4A, you see a pretty long period of decline in the numbers per unit effort in both of these areas. So now we're starting to be able to see the separation between the weight of these fish and the numbers in the catch rate. I'm going to zoom in on that bottom right-hand panel, or the total numbers per unit effort, because I think this is an important input for the stock assessment. And what you see here is that in aggregate across the whole stock, the total numbers per unit effort show a similar pattern. There's the decline through about 2010, and with a little bit of up and down, some stability after that. However, you also note that you really kind of have to look carefully to see that decline from the late 1990s to 2010. The reprocessed output from Ray's model suggests that there's only been about a 15% decline from the late 1990s in terms of total numbers of fish through about 2010. So although that's important in terms of the stock's productivity, it really turns a little bit more of the emphasis back on changes of weighted age. So it makes us understand that perhaps a slightly greater fraction than we've thought in the past of that decline we saw in weight per unit effort is attributable to weighted age rather than numbers of fish overall, although there's still a substantial decline in numbers of fish here as well. So we've learned a little bit, something a little bit new, or a slightly different take on something that we've seen in the past based on Ray's new analysis of the survey data. Now that brings up the question of what about the weight of these fish, and that brings us into the biological data. Now this is a time series going back as far as we can reconstruct the average size fish that was landed in each of the regulatory areas. So it goes all the way back to 1935. The black line down the middle of this series represents the coast-wide average fish that was landed in the catch. And you can see we started in the late 1930s and early 1940s with fish that were less than 20 pounds on average being landed across the entire coast. That increased steadily all the way until the late 1970s. The big jump there in the mid-1970s, of course, was the imposition of the minimum size limit. So the fish didn't grow a whole bunch right there. That little offset is because we essentially eliminated the very small fish from the commercial landings. However, even without that change, it's quite clear that the fish were as big as they had ever been in 100 years in the late 1970s, and subsequently to that, they've declined substantially back almost to the average fish size that we saw in the 1950s. One other thing I draw your eye to here is the two blue series, Area 3A and 3B, which you'll note up until the mid-1980s, those were the biggest fish on the coast on average, bigger than all the other regulatory areas. And sometime around the late 1980s or 1990s, those two areas, 3A and 3B, dropped down to about the average coastwide size of fish, and then in recent years they've been below the coastwide average. And this is important because, as you'll see later in the talk, we have and still think that a very large fraction of the biomass of the halibut stock has always been in Area 3A and 3B. And so the trends in size of fish in those areas are really going to push the dynamics of the entire stock. I'm going to zoom in now on the very end of this time series so you can get a little bit more resolution and see perhaps a little bit better the trends that are going on among the regulatory areas. So this is just that same series zoomed in on the data from roughly 1990 onward. And what I want to point out here, the upper series in this panel, the upper red series, the triangles there, is Area 2C. And Area 2C, since about 2002, has consistently produced the largest fish in the landings across the whole coast. They have ranged from roughly 30 to 35 pounds, and that's been larger than all the other regulatory areas during that time period. At the end of the series, over the last 4 years, you can see the next series down, also in red circles there, is Area 2B, which, although it had a decline in 2016, has also produced, on average, larger fish than coastwide average. Looking now at the two blue series, Area 3A and 3B, you'll see that since about 2011, we've seen some consistency in the average size of fish being landed, right around 20 pounds in both of these areas. With Area 3B, interestingly enough, increasing over the last couple of years through 2015 and 16, the average size fish has actually been increasing quite rapidly there over the last 2 years. I'm not sure at this point whether that's indicative of a trend or whether that's just some of the variability that we see in these series. But what's important about seeing some stability in those two areas is that, again, those two areas contain much of the biomass of the stock. And that's largely why you see that black line has stabilized and is actually increasing slightly since about 2011, because we've finally essentially seen that the fish in Area 3A and 3B are no longer getting any smaller relative to what's being landed at the dock. But this is the average weight that's being landed, and this is rolling two things together. It's both the weight at age and the age structure of the catch. So this is a figure that you haven't seen before, which represents the reconstructed weighted age for a female halibut of age 12 back through the entire time series. Now, I've had to piece together both survey and fishery data because we don't get sex-specific information from the fishery. Those fish are dressed at sea, although you'll note that we have a research program addressing that very need right now. And you'll also note some similarities in the series, specifically Area 4B and Area 4, because much of the data, we don't have very much data for Area 4B. So most of that is representative of data that's pooled across both of those areas. However, what I want to draw your eye to here is overall the change in the size of this age of female halibut. Now, why did I choose a female of age 12? This is the quintessential commercial halibut. The average age in the commercial fishery has been between 11 and 12 years old for most of the time series, maybe 10 and 12 years old through most of the time series. And these are the fish that comprise a majority of the fish that are landed in the commercial fishery, as you'll see in a few figures. This is a very important age, and females again provide most of the biomass that's produced in the commercial fishery. So this is an important age to focus on. If you're interested, I have some figures later on that show some other ages, but qualitatively the trends are quite similar. What's important to note here, again, the black line down the center is the coastwide average. And each of the geographic regions now, I've lumped all of Area 2, all of Area 3, and Area 4 represents 4A and 4C, D, and E together. And what you'll note here is that we are at essentially historically low weighted age for females of age 12. And I think that's important because this is essentially our exchange rate. For a certain number of fish that we catch, the weighted age dictates how much biomass comes out of that or how much yield. And right now, we're getting a lot less on our exchange rate than we were in the late 1970s and early 1980s. That female in that time period was 40 to 45 pounds across most of the range of the stock. That same female today is between 20 and 25 pounds. It means we were getting almost twice as much yield for the same number of fish hitting the dock. You'll notice that our reconstruction for Area 4, although somewhat uncertain because there's not a lot of data, suggests that the change in fish size has not been as pronounced in Area 4 as it's been in Area 3 and in Area 2. But again, this has been an important driver in the amount of yield that's available to the stock. And although it has stabilized at the very end of the series there, you can see from 2010 onward, the coast-wide weighted age has been relatively constant. We are at very low levels. We're getting a very low return for the same number of fish now than we've gotten in the past. Which brings us to the age structure of the stock. So this is the age distribution from the setline survey, and I'm sorry, you don't need your 3D glasses for this one. The red and blue here denote females and males, females in red and blue, males in blue. The y-axis of this figure denotes the age of halibut from age 5 to 25, and the size of the circle represents the number of fish caught at that age in our setline survey in each year, with years going across the bottom. So this is the time series of our catch in numbers. What that means is that each of these columns adds up to 100% of the fish. So each of the circles represents some proportion of that total catch of halibut in the setline survey in that year. A couple things jump out right away. The first is this 1987 year class, which shows up as a strong diagonal. Each year those fish get 1 year older, and each year moving across the bottom, it creates a diagonal line through the panel. And that 1 year class produced, we estimate, somewhere between 200 and 225 million pounds of yield from that single year class. So that's been a very important driver of the yield available through the late 1990s and early 2000s. You see that the first year I did this assessment in 2012 was essentially the last year that stock or that year class was separated out. Age 25 includes all fish age 25 and greater, and you'll see that that's a relatively low contribution overall. So that 87 year class had essentially hit the old folks home in 2012 and really hasn't been producing much since. But you can see that the setline survey catch has basically gone back to fish that are in the survey dominated by fish that are roughly 8 to maybe 15 or 16 years old. And we've seen some stability in the last 5 years of essentially similar age composition across this whole time period, with perhaps a slight increase in 11 and 12-year-old fish in 2016. If we look now at the commercial fishery, again, we don't have this broken out by males and females because we don't have those data at this point, but you can see a very similar trend, which is that strong 1987 year class. You see somewhat fewer fish of ages 5 through maybe 8, and that's because of the minimum size limit. Those are fish that we catch and see in the survey as sublegal, but we don't see in the fishery ages, which are sampled in port. But again, here you can see at the end of the time series, after that 87 cohort had moved through the population, we're now back to a relatively stable age structure dominated by halibut that are age 8 to 15 or 16 years old. Again, this is good news to see that stability, because a bad sign in a stock is a crash in the age structure, but the downside of that is we don't see evidence of another really strong cohort of the magnitude of that 87-year class coming in. We would expect to see some big bubbles at the bottom and then moving up through as a strong diagonal. And as of yet, there's no strong indication of that in the commercial fishery data. Brings me to the last biological observation, and it's not a biological observation directly from the halibut stock, which is the Pacific decadal oscillation. And this is a gross metric of productivity in the North Pacific, primarily in the Gulf of Alaska. It's an environmental index that's a composite of a lot of different factors representing sea surface height. It's a reasonable proxy for current speed and direction of the Gulf of the gyre in the Gulf of Alaska. But generally, when these values are above 0 or positive, that means a warm and relatively productive regime in the Gulf of Alaska. When they're cool or negative below the 0 line here, shown in red, that's generally a poor phase of the PDO and corresponds to lower productivity in the Gulf of Alaska. There's a lot of literature on the effect of the PDO on salmon and other species. What's important for halibut is that a couple of decades ago, some smart people identified a strong correlation between this index and the subsequent recruitment of halibut into the stock. Fish born in years when the Pacific decadal oscillation was positive tended on average to be about 30 to 50% higher than year classes that were born in negative years of the PDO. Now, this is not a good predictor of interannual variability. So you'll see that that 87 value isn't the largest one in the entire time series. But on average, when we're above that line across the middle of this graph, historically, we've seen a correlation with stronger recruitment. Now, there's no guarantee this is going to hold up in the future. We've certainly seen some anomalous conditions. And in fact, the values that we've observed for 2014, 15, and 16 have in fact been some of the most positive values we've seen in quite a few years. However, as I'm sure you're all aware, there have been a lot of other anomalies in the Gulf of Alaska and even in the North Pacific in the last few years. The warm blob has created warm conditions which look a lot like a positive phase of the PDO, but honestly, I'm still waiting for the oceanographers to tell us whether or not this really is another phase of the PDO or whether this is just a whole new phenomenon going on. It's really very difficult to tell. Importantly for the halibut stock, and in thinking about our recruitments in the next few years, are these years here from 2007 through 2013. Again, these are year classes that are out there. They were born, they're out there in the water. We've seen them maybe slightly with some of the trawl surveys, but we've yet to really see these fish recruit either to the setline survey or the directed halibut fishery. And if historical correlations hold up, would suggest that they have some chance of being below average. However, again, this is not a good index of individual years recruitment, but just a gross index of productivity. So to summarize the trends that I see in the data, the total removals as well as, or particularly the bycatch, were down in 2016 relative to where we were in 2015 and in 2014. Based on the space-time modeling that Ray has produced, I think we've seen an improved correspondence between the trends that we see in the setline survey and in the fishery catch rates, noting a couple of exceptions that I tried to point out there, particularly the fishery catch rates in Area 2A being down this year and in Area 3A and 3B being up in the last couple of years that we didn't see in the setline survey. On the biological side, I think we now, with about 5 years under our belt since 2010, we can say with some certainty that the biological patterns in the stock do appear to have stabilized. But we've stabilized at a level, particularly for size at age, which is quite low relative to the historical series. So it's good to see it flatten out, but it's flattening out at a value that's honestly not giving us a very good exchange rate. It means that we're flattening out at a level of lower productivity for this stock than we've seen through most of the historical time series. So that brings me now to the modeling. And again, stock assessment models are really just fancy smoothers to help us better see the trends that we probably can already see right in the underlying data. The 2016 assessment is an ensemble of 4 stock assessment models, and these are in fact the same 4 models that we've used since 2014. We've made some refinements, more refinements in 2015 than this year, very few changes this year. These 4 models represent a cross of 2 different treatments of the data, two ways that we aggregate the data over space, and 2 ways that we aggregate the data or use the data across the historical time period. So we either are using a short time series or a long time series, and we're either aggregating these data into one coastwide index and one coastwide series, or we're keeping the individual regulatory areas separate. Now, to give you sort of a visual representation of this, if I look first at the short coastwide series, we can think of this as short and simple. So this is just a graph of the data availability. The bigger the circle, the more data there is, or the more catch there is. And you can see that over the short time period, everything's filled out. We've got observations in all of the pieces, and this is pretty simple to model. But potentially we're missing a lot of the story. I've just spent 20 or 30 minutes talking about the detail in different trends among the regulatory areas. And this approach just basically uses that bottom right-hand panel, which is the coastwide index. So potentially we're losing some information, but the benefit is that everything's rounded out. It's very simple to model these data relative to the messy details of area-to-area dynamics. At the other extreme, when we treat areas as fleets, keeping the data separated, and we also look at the long time series of information, now going all the way back into the late 1800s, you can see just visually, well, there's a lot more information here. In some areas, we've got abundance indices and age compositions that go all the way back into the 1930s. This is a very rich data set. Frankly, it's one of the reasons I love working at the Commission, because there's so much data to play with and work with. But the downside of this is that there's a huge technical overhead to working with a lot of these historical data. They weren't all collected in the same standardized manner. And as you can see, there's a lot of gaps. These series are quite ragged. And so it's not obvious whether one of these treatments or one of these approaches is necessarily better than the other. But nonetheless, each of these 4 models represents a different way to treat the spatial and temporal dynamics of the stock. Now, when we compare the results across these 4 models, thankfully, we get a very similar perception of where we've been in the past. So each of these series shows you the output from one of those 4 models. The shaded area represents a confidence interval from within that model. And what you can see here is that all 4 of these models broadly are telling us, well, the stock has declined, the spawning biomass has declined from where it was in the late 1990s pretty consistently through about 2010. And since 2010, there's been some increase. All these models are estimating a slight to modest increase since 2010, with some of them flattening off a bit more across 2015 through 17. Now, this is essentially exactly what we saw. If we overlaid the fishery catch rates and the survey catch rates at a coast-wide level, it's basically the same trend we're seeing there. Noting, however, that not all of these models tell us exactly the same thing about the absolute scale. So if I zoom in for a second on the value at the beginning of 2017, or the value that we have in front of us to make decisions coming up at the annual meeting, if we look at that distribution, turn that on its side, each of these curves here shows the output from a single stock assessment model. The line would be a point estimate from that model, and the distribution shows you the relative uncertainty from within that model. And the important thing to take away here is that we have a lot of uncertainty in exactly how many fish are out there. I'm not here to tell you we know exactly what the spawning biomass is in the halibut stock. But all of these models are telling us generally that it's around 200 to 250 million pounds. And if we look across the range of models, it's suggesting a much broader range than any one of these single approaches to the stock assessment would have given us on its own. And this is important. You might look at this and say, well, geez, you guys have a lot of data relative to other stock assessments. How come you can't tell us more specifically exactly how much biomass is out there? Most stock assessments would only be reporting one of those and not showing you the rest of the information. It's particularly important for our approach to decision making to be able to include this kind of among model uncertainty, because when you look at the decision table, that uncertainty is included in the decision table. So if there's a small probability of stock decline or stock increase at a particular harvest level, that's reflected in, that's a reflection of this uncertainty in our estimates of absolute stock size. So if I take all of these distributions and integrate them together, at this point we use equal weighting across the 4 models, because they're all essentially equally plausible ways to aggregate the data and the spatial dynamics. If we aggregate that all into one distribution, we can turn that on its side. This is called a cumulative distribution. The line down the center represents the point estimate, or the median, from that distribution. So that's 212 million pounds. And you'll note that in terms of times out of 100, you read this by looking at the y-axis and saying, well, what's the chance out of 100 that the stock is at least as big as a certain biomass? So you can see there's about a 50-50 chance that the stock is at least 212 million pounds, with a considerable amount of uncertainty. We can also see, if we drew, say, an 80% confidence interval across here, we can see that would range from 170 million pounds up to 270 million pounds. So again, we don't know exactly the size of the spawning biomass, but the current data suggests that it's between 170 and 270 million pounds, with our best estimate being around 212 million pounds at the beginning of 2017. If we compare to the biomass estimate we had from last year's stock assessment, slightly larger. It was in fact 219 million pounds. So although this year's estimate is slightly lower than where we were last year, relative to this range of uncertainty, statistically it's essentially the same estimate. That's a very small change relative to the overall uncertainty we have in stock size. Putting all of those 4 models, not just at the end of the time series, but the full time series together now, the colors here represent the relative probability of that spawning biomass. So you can see the dark blue line down the center represents the median value, and each of the blue grading out to lighter and lighter colors suggests a lower probability of a biomass in that range. And so you can see this is, again, the same as those 4 individual models I showed you, that in aggregate we estimate the stock has come down from the late 1990s to about 2010 and has been increasing slowly since then. And this is actually very consistent. If we now put this in the context of where our estimates have been for the last several years, it's very consistent with those estimates. So now what I've overlaid in black here is the median or the point estimate values from all the stock assessments since 2006. And you'll note that from 2006 to 2011, we had some technical problems in the stock assessment which were leading to values and trends that were really not consistent with the data. And it's much more obvious now in hindsight than it was at the time. But in 2012, we fixed those technical problems. And you can see that since 2012, although we've been up and down a little bit year to year, we've essentially had very similar predictions of a gradually increasing stock since that time period. Noting, of course, that all of our data are relatively imprecise, and that even if the stock were on a perfectly smooth trajectory, our estimate of that trajectory would vary somewhat year to year. We would expect to be above the true value half the time and below it half the time. Even if our models were perfect, we'd see some interannual variability up and down. You can see that our current estimate, or the blue at the very end of this time series, is slightly above the last point in 2016, and in fact slightly below the point in 2015, but it's actually greater than our estimate that we had at this time during 2014. So moving to a few reference points now to summarize the output from this year's stock assessment. I've already noted that at the beginning of 2017, we estimate a spawning biomass that's a little more than 200 million pounds, and one which we estimate has been increasing gradually over the last 5 years. Our stock estimates are slightly lower than they were last year, but again, statistically, essentially the same answer we've had in the past. Given the amount of change we've seen in some of the data series, it's actually very similar to the estimate from last year. Relative to some of our reference points based on harvest policy, or our 30% spawning biomass relative to long-term unfished conditions, we estimate a very low chance that the stock is below that level, only a 5 out of 100% chance that we're below that 30% threshold. And our best estimate, or the median value, is that we're currently at 41% of the unfished biomass level. And that, although we don't have a specific biomass target for halibut, relative to its biology and the management of other similar groundfish species across the West Coast, both in US and Canada, I would say that a spawning biomass estimate of 41% of B0 is probably in the ballpark, or roughly consistent with what would be considered a target for many groundfish stocks. A little below some targets for very unproductive species, and a little above targets for shorter-lived and more productive species. So with that, I can move now into the decision table. And the decision table wraps up the results from the stock assessment into one convenient place to make decisions from. The decision table utilizes 3-year projections, and it doesn't go out 3 years to presuppose any decision that's actually going to be made in the next 3 years. These are not predictions. These are projections if we were to assume a constant catch. And this is essentially just to give you a yardstick so that you can gauge where we would be headed over 3 years if we made set the same catch level for all 3 years, noting that we'll be back here next year making catch decisions anyway. Now, I only go 3 years because I have an aversion to electronic fish. And electronic fish would be fish that we have yet to see in the data, and if I went much beyond 3 years, those fish would start to be important in those projections. And those fish are created by the assumptions that are built into these stock assessment models, which it's one thing to have assumptions that are consistent with the data we see. It's another thing to have assumptions that are able to make predictions outside the data we see. And that's why I only go 3 years in the future. So a 3-year projection is largely going to be dominated by dynamics of fish that we've already seen a couple times. I provide alternatives for 2 reasons. The first is so that we can see a clear trade-off between relative removals, or yield from the stock, and risk associated with that level of removals. And the second is several alternatives, both harvest policy and non-harvest policy alternatives, so we can place the dynamics that we see, or the relative risk, in both a biological context of what the stock would be doing if we weren't harvesting, as well as a management context of where our harvest policy calculations fall. So I'm going to take a couple extra slides this year, perhaps more than I did in previous years, and just step back through how to work with the decision table. So the decision table, and I'm showing you the first section now because this is a harvest policy free. This is essentially just the output of the stock assessment with no lens of harvest policy put over it. And the way you look at the decision table is this. We have some metrics of risk, and risk being something bad happening, and it's reported in times out of 100. Down the rows on the left-hand side of the table will be benefit or yield, and that's expressed in the total amount of removals that are available from the stock at that level of yield. And down the middle, I'm going to report the fishing intensity associated with that, or the level of reduction in the spawning potential of the stock associated with that level of yield that then subsequently creates that level of risk. And what's convenient about the way we have the table laid out is that all of these things are increasing from top to bottom. So we have low yield, low fishing intensity, and low risk at the top, and high yield, high fishing intensity, and high risk at the bottom of the table. And so you can read your way down and see increases in yield and increases in risk. So the first row I want to introduce on the decision table is the no removals row. And so this row is just a gauge so that we can see, well, how fast could the stock increase if we didn't take anything out of it? So this imagines that there's no mortality from any anthropogenic source occurring on the halibut stock. Essentially, what would the stock dynamics look like if it were increasing at its biological maximum? So in purple there, you see the projection of the rate of increase from that stock. And in the decision table, which is the exact same information put in the table, you see in terms of stock trend, and in here the 4 columns of stock trend I'm reporting are the spawning biomass and what the probability of the spawning biomass decreasing in 1 year or 3 years, and whether it decreases at all or whether it decreases by at least 5%. And the reason we have both of those columns in there is because there might be a very high probability that the stock decreases, but if it only decreases 0.5%, that's really not a meaningful decline. So we're interested in both of these columns. Is it decreasing, or what's the probability of decrease, and what's the probability of a substantial decrease of at least 5%? So this first row just gives you a sense of how fast could the stock increase if there were no removals. The second row is intended to illustrate the removals, the effect of removals that are not under the direct control of the IPHC. So if the IPHC set all of the fishery CEYs to 0 for 2017, we would estimate that there was still 11.2 million pounds of removals from bycatch, from personal use and subsistence, and from other sources that are not included in the FCEYs. What this would mean, and now looking down the fishing intensity row, you see at the top there it said F100%, meaning we hadn't reduced the spawning potential of the stock at all. At this level, we've reduced that to F77%. So the way you'd understand that is that we've lost, even with fishery CEYs set to 0, we've already lost 23% of the spawning potential of the stock. It's already been removed from those things that are outside the control of the IPHC. The good aspect of this, though, is that at this level of removal, there's still a very low risk of short-term decreasing trends. So even over a 3-year time horizon, there's only a 3% chance of seeing any stock decline at this level. So again, with this level of removals, the stock is still pretty stable or even slightly increasing. Now the next 2 rows down are just incremental values. You notice they're roughly 10 million pound increments, just to illustrate how the risk is changing with increasing removals. And so you see that the risks do increase as removals go from 11 to 20 to 30 million pounds. By 30 million pounds, we've essentially reached the median value, or the tipping point for any decline over a 3-year time horizon. At 30 million pounds, there's a 53 out of 100, or a 53% chance that the stock will decline over a 3-year time horizon. But there's only a 31% chance that that decline would be as great or greater than 5%. So it's projected to decline, but not by a whole lot over a 3-year time horizon. Now the next 2 rows are both right around 40 million pounds, one slightly under and one slightly over. And what you see from both the risk and the projection here is that right around 40 million pounds is the point at which the stock is projected to flatten out and even start to decline slightly. So for both of these catch levels, and the graph here shows you the projection for 38 million pounds, shows that the stock starts to decline slightly over the next 3-year period, noting, however, that there's still a pretty broad amount of uncertainty in that projection. It could actually still be increasing, or it could be decreasing slightly more than that. This degree of fishing corresponds to a 52 to 54% reduction in the spawning potential of the stock. And again, relative to other species and other target levels, this is probably similar to what would be considered a target level of exploitation for many groundfish species in other fishery management contexts. And that level of reduction, again, is generally consistent with the biology of halibut, and as I said, target levels for other fish species of similar biology. Now if we look now to slightly higher levels of removals, 50 and 60 million pounds, you'll note that the risk in the decision table begins to increase quite sharply. And right about 40 million pounds, it really increases rapidly, such that by 60 million pounds, as shown in the graph here, we're projecting a relatively strong decline in the stock over the next 3 years, and there's a very high probability of decline in the 1 or 3 year time horizon. At that level of removals, at 60 million pounds, the spawning potential of the stock has been reduced by 65%, or that would correspond to a fishing intensity of F35%. For example, for comparison, in the North Pacific, stocks in Alaska, that would be considered for most stocks an overfishing level. Fishing beyond that level of fishing intensity would be considered overfishing. So this sort of gives you a little context for people that are familiar with other processes of about where that row in the decision table would correspond. I do want to point out, though, with regard to that F35%, that you'll note the range below it is 23 to 54%. And that's a broad confidence interval from extremely high fishing intensity to not so different from target levels. And that reflects our uncertainty in the absolute stock size. If we don't know exactly how many fish are out there, we can't tell you exactly what the fishing intensity would be. Our point estimate would be F35%, but there is a considerable confidence interval around that value. So now to summarize the assessment results. Ray's improvement in modeling the survey and the other new data that we've got have flattened out both the recent and the projected trends. Last year we were projecting, there was a little bit less risk in the decision table last year. But if you stop and think for a second, we've got one more year of data, and what we've seen is another year of relatively slow increase in the stock. Not rapid increase, but relatively slow increase. And so that means that we have slightly more risk because we saw another year's data and we have yet to see any large increases in stock size. And so that's why we see a slightly higher level of of risk in the decision table. The bright side of the additional data this year, though, is that it's actually reduced some of the uncertainty among those 4 stock assessment models. So the most pessimistic of those 4 actually came up a little bit, and the most optimistic of the 4 actually came down a little bit. And that's actually how we would hope and expect these assessments to respond, is that as we add data, they're tightening up. They're getting a little bit closer together, regardless of how we treat the spatial and temporal dynamics. I think to summarize the assessment, and honestly, we could have put this, this summary bullet point after the data section as well, which is that for the last 3 to 5 years, for the last 3 years, we've been removing roughly 40 to 43 million pounds of halibut from the stock. And we've seen a slow but consistent increase in the stock dynamics. And that tells us, even without a stock assessment model, that we've essentially been harvesting right about the surplus production of the stock, maybe slightly below, because we've seen a slight increase in the stock dynamics over that 3-year time period. Again, that's a result you almost don't need a stock assessment to tell you. This would be the point where I would offer a break, and I'll leave it to the chair to decide whether you'd like to take it or whether you'd like me to continue on.
How much longer do you think, Ian?
I'd say I'm about 3/4 of the way through the presentation.
Well, then I anticipate we're going to have quite a number of questions, both from the commissioners and I'm sure from the audience as well, both online and here in the room. And I wonder if it might be better just to take a break for lunch and come back to this, and that gives people time to think about their questions too. And we might beat the rush hour for lunch a little bit, but I'd leave it up to get some direction from you too, Dave. I noticed that we have other items on the agenda and we want to get through today, but I think some of them are quicker, and this is a pretty substantive piece here. So my recommendation would be to break for lunch and then have Ian carry on after, and then take questions around the whole presentation, both here from commissioners in the room. Do you think, do we need a whole hour for lunch or 45 minutes? Jim, any views?
I'm certain we can eat in 45 minutes, but I'm not sure how quick the service will be. It took me a long time to get breakfast. So.
All right. Well, let's get back here at 10 to 1, and we'll reconvene and start the meeting at 10 to 1. Thanks very much. Just remind me where we left off there, Ian. You still have a bit more presentation to go.
Yeah, so I concluded the data section and the assessment and decision table, and I have left apportionment and harvest policy.
Okay.
Which is roughly 1/4 of the overall presentation, so
right.
It shouldn't take that long.
Okay, so why don't you finish off the presentation, and then we'll take questions that cover all aspects of the presentations that we've heard from you and from Ray as well. And we're back online and people are there. Steve? Yeah? Okay. Okay.
Great. Thank you, Mr. Chairman. I'll continue on now with the last two sections of the presentation, which include the apportionment results, as well as the harvest policy and some more detail in terms of catch tables and actual regulatory area specific results. Ray Webster mentioned apportionment already this morning and noted that we've now unified the apportionment and the assessment model data in that all of the same corrections and things are being applied to both processes. This piece is particularly important because apportionment is how we see the stock currently distributed. And the important parts of apportionment are these. Each year we use the survey catch of 032 halibut. And this calculation is updated each year. So regardless of the accuracy of our understanding of the stock, each year we go out and do the survey and we get a new estimate of how the stock is distributed. And we use that estimate to update our understanding. This year's estimate, as Ray noted, has been improved because we're now using the new space-time modeling to provide this estimate, which still includes, just to remind you, still includes the fishery timing and hook competition corrections. And this serves as one of the major inputs to all of the harvest policy calculations that will follow. So I've shown this figure in the past. This is the apportionment trends by regulatory area from 1999 to 2017, noting that 2017, that's the projected value for 2017. So that's using the 2016 survey. The survey results project the upcoming year's apportionment. And what each of these panels shows you is the percent of the stock that we estimate to be in that particular regulatory area over that time period. Now each of these is scaled independently for this figure, so don't try to compare across the regulatory areas. For a moment, just look at the trends within each regulatory area. In a second, I'll show you a second figure that will allow you to compare across the regulatory areas. But the points I'd like to make on this figure are these. One is that you can see in concert with the increases that we've estimated from the setline survey, you can see that the estimate of apportionment for all of Area 2, 2A, 2B, and 2C, has been increasing pretty steadily over the last decade or so. You can also see Area 4, C, D, and E, up in the upper left of this panel, has also been increasing over that time period, although slightly less smoothly. Now, apportionment these are fractions of 100%, and so if some areas are going up, some areas must be going down, and you can see that the western side of the stock, 4B, 4A, and 3B are the areas, and actually the center of the stock as well, 3A, are the areas where most of the decrease has been realized. And so you can see from, particularly in 4A and 3B, the percentage of the stock that we estimate to be occurring in those two regulatory areas has declined almost continuously till the end of the time series. Now, again, these are scaled independently, so if we want to now visually represent the actual percentages for each area, that would be this figure. And it's a little bit harder to see the trends, which is why I started with the previous figure, but now you can see essentially a visual picture of how we see the stock being distributed over the last couple of decades. And you can see that the bulk of the stock is in Area 3A, and these are results that haven't changed regardless of any of the modeling that we've done. We've always thought that the 3A is the core of the stock and most of the biomass resides there. You can see those declines in 4A and particularly in 3B, which used to be a major contributor to the stock, and now, although it's actually increased for a couple years at the end of this time period, is much lower than it was historically. You can also see those same increases in Area 2, but you can also see there that all of Area 2 added up is still only a similar magnitude to what we see in Area 3A. Again, just giving you a relative sense of how we see the stock distributed across the whole range of Pacific halibut. So Ray showed you a similar figure to this using the empirical estimate and his new model-based estimate. And I'm showing you something slightly different here, which is how apportionment has changed from the estimate that we had last year, here shown in blue, which was from 1 year back in the survey time series, as well as using the old method, compared to the estimate coming out of Ray's model for this year in red. And so there's actually two moving pieces here, but I felt it was important to show this because this is what the change that's actually going to be perceived when we see the harvest policy results. And a couple of important things stand out here. One is that we've seen a decrease in the estimate of the fraction of the stock occurring all the way across Area 2. And that's a little bit counterintuitive because I just spent quite a bit of time showing you that generally the trends are increasing across Area 2. But what this represents is a scaling down of those trends relative to our estimates for the other regulatory areas. So it's that we definitely have estimated increasing trends for Area 2, but relative to our estimate from last year, they're down slightly in overall scale. Second thing I want to note here is Area 3A and 3B. And this is the flip side of that, which is that we're estimating slightly more of the biomass to be occurring across the center of the stock than we did previously. And as Ray took some great lengths to explain one particular example for Area 2A, but there's a lot of moving pieces here. So we've added another year's survey, so we get slightly updated information there. We've got changes in the way the hook competition correction is being done. And we've got several other changes that are involved in the use of that space-time model. So there's a lot of moving pieces that feed into here, but this is the net result of that. And somewhat mixed patterns across the rest of Area 4. With apportionment as the preface, now we can move into the harvest policy and catch tables. So the harvest policy is based on two concepts. And Alan Hicks is going to follow me with another presentation on the harvest policy and go into perhaps even a little bit more detail than I am. But I want to provide a little bit of delineation here into these two pieces of the harvest policy. The first is the scale, and the second is the distribution. So that the scale of our harvest policy determines how hard are we going to fish the coast-wide stock. And we can read this scale right out of the decision table because it's a sense of what's the fishing intensity we're going to be applying. It's a combination of two things. The first is stock status, although we're currently estimated to be at 41%. So we're above our harvest control threshold of 30%, which means that stock status is not feeding into our target level of fishing intensity at this biomass level. The second is the overall level of fishing intensity that we're going to be applying to the stock. The second part of our harvest policy is distribution, and these are largely two separate pieces, although unfortunately they're not entirely independent. The distribution is how are we going to distribute these removals across the regulatory areas. And the way we get the distribution from the current harvest policy is through a combination of two things. The first being the apportionment results to tell us how the biomass is distributed, and the second being the relative target harvest rates that we have among the areas. And remember now that we have a higher target harvest rate on the eastern side of the stock, Area 2A through Area 3A, than we do on the western and northern part of the stock, Areas 3B and all of Area 4. So we can go now back to the decision table and think of it in the context of scale. And so here I've added the labels on those two rows that were right around 40 million pounds. Because now I'm finished with the assessment section and now I'm talking specifically about harvest policy ideas. So the first row that you see there is the blue line. And the blue line, as it has for the last several years since 2012, represents just the application of the current harvest policy. And you see the blue line would be consistent with 38 million pounds or 37.9 million pounds of total removals from the stock. And it would correspond to an F48, or a reduction in the spawning potential of the stock of 52% from an unexploited condition. The second row that I'm providing here in the table this year is slightly new, and this is a row that we're providing at the suggestion of our scientific review board, who have watched this process unfold for a couple of years, and we show them how we calculate the blue line. And in previous years, as well as this year, they suggested, well, okay, you've got the blue line, and that's your harvest policy, but perhaps it would be useful to look as well at what you've actually been doing over the last several years. And so this row represents the status quo SPR, the status quo spawning potential ratio. And all this means is it represents the average level of fishing intensity that we've applied to the stock over the period from 2014 to 2016. So each year we can look back. So this year we're taking this year's model and looking back and estimating, well, how hard do we think we were fishing the stock over that time period? And this represents the average level of fishing intensity over that time period. And as a de facto harvest policy, you can consider the local or the current performance of that to be, well, what we've seen over the last 3 years is a gradually increasing stock, and this is the level of fishing intensity that corresponds to that behavior right now. It doesn't tell us anything about the long-term behavior of a harvest policy based on this, but it does tell you about how it's influencing the stock right now. And so again, that row suggests a slightly larger total removals of 41.6 million pounds, a slightly higher fishing intensity resulting in an F46 or a 54% reduction in the spawning potential of the stock, and as you can see, a slightly larger level of risk associated with spawning biomass decline over the next 1 to 3 years relative to the blue line. Now, I'm going to change now from the first part of the decision table, which is with regard to stock trend. Since we're now into harvest policy, I'm going to show you the second part of the decision table, which is with regard to stock status. Stock status being part of the harvest policy because we define these threshold and limit reference points of B30% and B20%. The choice of those reference points is actually part of the harvest policy, so it's not necessarily an output from the assessment. Our current status is an output of the assessment, but the choice of what to measure that against is part of the harvest policy. And you'll see that for both of these rows, both the blue line and the status quo SPR, they both correspond to a relatively low risk that we would dip below either of those reference points over the next 1 to 3 years. In fact, the greatest risk there is only a 15 out of 100 chance that we would dip below SB 30% over a 3-year time horizon if we went with the status quo SPR. That brings us now to the blue line TCEY comparison. And so here, what I'm showing you here is the TCEY, or the O26 yield available as estimated in each of the last 3 stock assessments. So this is not looking back now, this is just taking the values that were available in each of these years as we went along. And you can see that the overall, the TCEY has increased by several million pounds from 33.5 million to a little more than 36 million over this time period. And each year the distribution has changed as well. Now if I put the 2017 estimate on there, you can see 2 things. The first is that there's been a small decrease in the stock size estimate. And so that leads to a slightly lower TCEY than we saw in 2016. It's actually back pretty close to what we had in 2015. Now, you might be thinking, well, wait a minute, you just told us that the stock has been increasing, but the TCEY is now down just a little bit. And that's because our overall estimate of absolute abundance in the stock has come down slightly this year, even though the trend is still estimated to be positive. Again, we've got a broad level of uncertainty, and we would expect this to bounce around up and down year to year. This is a very small decrease relative to the uncertainty that we have in overall stock size. Now, the distribution among the regulatory areas, though, is going to change. It's not just as simple as scaling that total across the areas in proportion, because each year we've got a new apportionment estimate. And so you can see the distribution of that TCEY that we would project at the blue line differs relatively substantially from some of the previous years because we've got new estimates of apportionment. So again, we see a decrease relative to areas 2A, 2B, and 2C from what we estimated last year, and an increase in area 3A and 3B in particular. Now this is the TCEY. And sorry, I did want to point out before I move on that there are 3 regulatory areas, 3A, 3B, and 4A, that have all shown an increase at the blue line. Sorry, 4B. Thanks, Jim. Area 4B that have all shown an increase in the TCEY relative to 2016, despite the fact that we saw a small decrease overall. Again, this is reflecting the change in apportionment. If we compare then to the status quo SPR line, you can see that the total TCEY at that level of fishing intensity would be just over 39 million pounds, which is actually much closer to the overall status quo total mortality. And again here you can see the difference in distribution because this row is also reflecting the results of the apportionment. Now the TCEY is not the whole story though. So our harvest policy operates like this. We have a total estimated yield of O26 fish being the TCEY, and that gets translated into the fishery CEY or the O26 FCEY. But there's some important pieces in the middle here, and those important pieces are the removals, the O26 removals that are not regulated by the IPHC. And these are comprised of several important components. One is wastage in the directed fishery. Again, wastage being fish that are captured and subsequently die as a function of prosecuting the directed halibut fishery. The second is bycatch mortality in non-halibut fisheries. So these are fish that are caught and subsequently die due to fishing for things other than halibut. Unguided sport fishing in Alaska, which you'll see in a second, is relatively important in this calculation, as well as personal use and subsistence harvest that comes off the top of the TCEY, leaving us with the FCY at the bottom. So I want to go through these and compare year to year, because this is the second moving piece. The first moving piece is apportionment, and the second moving piece in the area-specific distributions is what's being taken off the top. So here I'm showing you in the red bars are what we were taking off the top of the TCEY in each of the regulatory areas last year, and the brownish or tannish bars are showing you what's coming off the top this year. And what you can see is that there's quite a difference in some regulatory areas in the magnitude of what's coming off the top. I'm going to go now through each of the top three of these, 2C, 3A, and 4C, D, and E, and give you a sense of which removals are comprising the biggest components of this. So zooming in first on Area 2C, we can see that in Area 2C, the primary thing that's coming off the top of the TCEY is the unguided sport fishery. Now remember, the charter fishery is included in the catch sharing plan, so that's part of the fishery CEY. But the unguided sport fishing in Alaska, which has different size and bag limits than the charter fishery, just comes off the top. It's not regulated by the IPHC, and we need to account for that on a year-to-year basis. So we take the TCEY and we subtract that off to get to the FCEY. So about 3/4 of what's being taken off the top is that source, and about 1/4 is personal use, with just a very small amount being bycatch in Area 2C. Noting that overall the scale in 2C, what's coming off the top, is somewhere around 1 3/4 million pounds. So this is not a trivial amount of removals even in 2C. Moving now to Area 3A, you can see a very different distribution of what's coming off the top. In Area 3A, it's only 50% from the unguided sport fishing, and it's 43% bycatch now, primarily trawl and line fisheries for cod and other species. It's also 7% personal use in Area 3A. Going back to the bars for a second, you can see in Area 3 what's coming off is actually greater than 3 million pounds. So it's close to twice as much as in Area 2C, and it's coming from different sources. Moving now out to Area 4, C, D, and E, you can see that the composition of what's coming off the top changes yet again. And it's now over 90% bycatch coming off the top, with just a small component of personal use and wastage. You can also see, and probably the biggest difference proportionally in this figure and what's coming off the top, is Area 4, C, D, and E, the difference between last year and this year. And the difference is that almost 500,000 pounds less bycatch is coming off the top in Area 4, C, D, and E. And again, this is just the 026 bycatch, so this isn't even the total amount of bycatch coming off the top. Just the 026 is estimated to be 440,000 pounds less than we took off the top in 2015. So this is essentially yield that's now directly and immediately available to the commercial halibut fishery in that area. This is particularly important for the fishery CEY in Area 4, C, D, and E. Another way to interpret this would be if there hadn't been that reduction in bycatch, the fishery CEY in Area 4, C, D, and E would be almost 500,000 pounds lower than you'll see in a second. So this is an important reduction for the directed fishery in Area 4, C, D, and E. So now we can compare across the fishery CEY values that we've seen over the last 3 stock assessments from 14, 15, and 16. Again, there you can see the total value has been increasing slowly over this time period. If we compare now to the 2017 blue line, you see that the fishery CEY is slightly smaller than 2016, but not quite as small as it was in 2015. In aggregate, there's less coming off the top in 2017 than there was a couple of years ago. But you can see again here that the distribution has changed somewhat from previous years. Noting that the fishery CEY now is actually larger in 2017 than it was in 2016 in 4 different regulatory areas. Areas 3A, 3B, 4B, and now also 4C, D, and E. Noting again that 4C, D, and E would have been almost 500,000 pounds lower had we not seen that reduction in 026 bycatch in that regulatory area. We can also compare that now to the 2017 status quo SPR row. And again, the total fishery CEY would be larger. And at that level, we can see that there's an increase across the board relative to the blue line. We can also compare that to the actual adopted catch limits from last year. And you'll note that the status quo SPR is very close to the total adopted catch limit from last year. And that's to be expected because we're trying to apply the exact same level of fishing intensity. It's not exactly the same because we do have some change in the composition of those removals, some shifts between sectors that access different size and age components. And importantly, that's reflected in the status quo SPR calculation. So even though the total is slightly smaller, we would estimate this to be applying the same level of fishing intensity across all sizes and sources of halibut. You can also see that there's, again, a difference in the distribution of those removals relative to what was adopted in 2016. Now, in the past, I've spent quite a bit of time stepping through the individual results, and this is the 2017 blue line, but it's broken out into all the various components, showing you what's in and out of the fishery CEY. This will still be provided as background material, will be in the documentation, and this slide will be available on the internet when this PowerPoint's posted, or it may even be available already. I'm not going to take too much time stepping through, but I want to highlight several places in this table. First, the 3 rows that are colored here. The top one in purple shows you the total amount that's being taken off the top before we get to the fishery CEY. And I want to point out that that's about a quarter of the total removals here. It's just over 9 million pounds out of about 38 million pounds total. The second row is the total of the fishery CEY, just a little more than 26 million pounds at the blue line. And then that lower one that I have highlighted in red there, that's the U26 mortality. And what's important about that, and I think I'll even call your attention here, is that we have about 2.5 million pounds of removals of U26 halibut, and they are not included in any of the calculations that feed into the blue line. So if that value were to change from 2.5 to 4.5, or from 2.5 to 1.5, none of the rest of the figures in this table would change. And that's because our current harvest policy doesn't address those U26 removals. If we move now to the same table, but now showing you the status quo SPR calculations, you can see the same similar distribution of fish that are coming off the top, about a quarter, a slightly larger amount of fishery CEY, and a total that's now 41.6 million pounds. You see it's still that same 2.5 million pounds coming off the top. What's important here is if that 2.5 million pounds were actually 4.5, or if it were 1.5, these calculations would change, because in this case we're trying to maintain the total amount of fishing intensity or the same level, and we're accounting for all those removals, not just the ones that fit in our current harvest policy, but all sizes and sources of removals. Again, you're going to hear a little bit more about this from Alan following my presentation. But the important part is that a change in that number in this table would correspond to a change in the rest of the numbers. We would be accounting for that. So to sum up the harvest policy results, the apportionment for this year suggests somewhat more biomass in the central portion of the stock than we've seen in the past. And this is a function of all the factors that both Ray and I have talked about. The scale of the projected removals is quite consistent with what we've seen in recent years. Yes, the blue line calculations and even our total estimate of biomass is slightly below where we were last year, but the trend is still the same. We're still estimating that the stock is increasing gradually. It's just that our overall scale of that trend has come down slightly. And finally, the bycatch reduction in area 4C, D, and E has provided for a substantial amount of additional fishery CEY in that area relative to what we've seen in previous years. And with that, I'll be happy to take questions about any part of this presentation.
All right. Thanks very much, Ian. I'll start with U.S. commissioners and see if they have questions or comments.
Yeah, I got it. So, Ian, on apportionment, is there some place the public can go to on the IPHC website and figure out their own areas, how you come up with the numbers? If there's 5 or 7 steps, is there some place that they can go to figure out what how their own area has been calculated?
Yes. So we provide in the RARA document every year, we have a chapter specifically devoted to apportionment, and it outlines the results of the particular year. The details about where those percentages come from, they're coming out of Ray's space-time model. So all those steps that he talked about this morning feed into these apportionment estimates. The apportionment estimates are just our current estimate of how the survey biomass is distributed. So you won't be able to step through intermediate calculations at every place, but you can definitely go in and get the detailed results in terms of percentages for each area. And actually we provide a table in that document as well, which has the information that I showed in those blue charts on the maps, so you can see how those percentages have changed over time among the areas and also within each area.
Yeah, go ahead, Jim.
So thank you, Mr. Chairman. So the apportionment is done, whereas your stock assessment, when you look at everything, includes the information from the commercial fishery and a variety of other places. But the apportionment is entirely based on survey results. Is that correct?
That's correct.
Okay, thank you.
Linda?
Well, one follow-up question to Jim's then. The survey, as you're using it for apportionment, is 032. You're not incorporating any estimate of fish below that.
That's correct.
And that won't change because you must take some fish in the survey that are under 32. But there's no, I mean, as we look at accounting for removals of all fish with a different approach than the current harvest policy, do you see ever incorporating smaller fish coming into the population and when you look at the survey, when you look at apportionment, or do you not see that changing?
That's a good question, and it points out how our treatment of these things differs slightly. So we're dealing with removals that are 026, but we're calculating the apportionment based on 032. And so there is a slight disconnect there. However, the trouble is that we would still need, under any accounting framework, we would still need some limit to how far down we would go to apportion these fish. And the reason for that is because if we're interested ultimately in yield available to the directed fisheries, if we look at very small halibut, say the U26 halibut, they still have the opportunity, and based on our tagging, we think they still probably will redistribute broadly across the stock during the intervening years between the time we see them as small fish in, say, in the trawl surveys and the time they might subsequently recruit to the directed halibut fisheries. And so under any of these accounting approaches, we would still need to allow for that effect. And for that reason, I wouldn't see us apportioning all the removals and all of the fish all the way down across all sizes. I think it's still appropriate to apportion the fish that are available directly to yield in the directed fisheries.
Okay, any other questions from U.S. Commissioners? Linda?
I did have one other, Ian, and this is going back to quite a bit earlier. I think it might have been slide 23 even, so it was before the lunch break. But no, that might not be right. Anyway, I'm sorry, I may not have the slide number right, but you had a discussion, and we've been looking at this for years, of the change in weight at age and the big change we've seen in the age 12 fish. And thinking about how many more fish we're taking in the directed fishery to make up the poundage than we would have been taken back in the 70s when the fish were so much bigger. And I just wonder what effect that has on the stock's productivity and what that might suggest about harvest rates between those time periods and as we move forward at these historic low levels of weighted age.
It raises a very good question, which is, has there been a biological response to this change in size at age, perhaps in terms of maturity? And the evidence that we have right now suggests that maturity at age actually hasn't changed very much at all. So the halibut appear to be maturing at a similar age, roughly between 10 and 13 or 14 years old than they did back in the 1970s. But the implication is that they're maturing at a much smaller size. And I think it's a very pressing research question. That's a somewhat unexpected result biologically. I would have expected some response. And as you'll hear, I think, later on this afternoon, it's one of a main focus of our research program that we're proposing. I think it's a very pressing question to know whether or not there's been a response in the spawning schedule, because you're quite right. If in fact there has, and perhaps these fish are not producing as much spawning output, then we definitely need to know that. So I think that's an important research question that you hear more about from Josep later on this afternoon. In terms of the yield, I think you reiterated a point that I made earlier, which is really important. And we saw a period in the 1990s when we were approaching 100 million pounds of removals. And if we were to go back now to back up to the same size fish, so this is the figure you were referring to, if we were to go back now to the 1990s, we'd see that the average fish was more like 30 pounds instead of now it's more like 20 pounds. So that's roughly 1/3 more yield per fish now. So right now we're generating 40 million pounds. We might be in the mid 50 range just for the same number of fish being removed for the stock. Unfortunately, there's no apparent way that we can control size at age through management. It would be great if we could manage to have this change. What we see over the long time horizon is that this tends to change slowly. So I think we need to be prepared for relatively low size at age. Even if it starts to turn around, it's probably not going to do so very quickly, given how long it took to go up and down historically.
Okay. If no more questions from the U.S. commissioners, Dave, did you have one?
I had an observation and then a question. Slide 23, Ian. We noted between 2015 and 2016 in 2B there was a precipitous drop in the size there, and I just wanted to highlight that there was a pretty significant regulatory change in 2B between those 2 years. The yellow ITAC was ratcheted down 39%, and it had the effect of driving the boats out of the shallower, harder bottom. So that may be at least part of the explanation for that. And I talked to you at the break. You were going to see if you could see anything in the survey that would either prove or disprove that as being a cause. So that'd be good to hear about. Second, now my question, how much of a reduction in bycatch do we expect in 2017 as a result of the regulatory changes up in the Gulf and the Bering Sea? Is that played out yet, or I'm not sure where we're at with that?
Thank you. I think those are both good observations. I'd like to follow up on the first one before I take the second one. I think you're quite right to observe that changes in the way the fishery is prosecuted could definitely be realized into the average size fish being landed at the dock. If people are spending more time targeting big fish or less time, or maybe they don't have that luxury if they've been forced out of areas due to other species concerns. This particular figure, to me, responds to a lot more than just the biology in the stock. This responds to the fishery condition as well. In some regards, it's still, I think, a valuable metric of fishery performance. It's good to see what's actually hitting the dock. But you're quite right that it's not a perfect reflection of biology, and some of these ups and downs could be a reflection of the fishery, not the biology, which is why I usually follow this up with a more detailed look at age structure and size at age. With regard to the second question, where could we end up in terms of bycatch and or how have the regulatory changes played out? I have that information available for Alaska. So this is a figure of the aggregate level of bycatch is the bars. In red is the Gulf of Alaska, and in blue is the Bering Sea and Aleutian Islands. Now, noting that these include several IPHC regulatory areas, but these are now reported at the resolution that the North Pacific Fishery Management Council manages the bycatch. The lines on here represent the PSC, or the prohibited species catch limits that have been in place in each year, and including 2017. So this gives you a sense of where the limits are. You can see this is the reduction that the North Pacific Council made from 2015 to 2016, and you can also see that the reduction that was made ahead of that by the fisheries in 2015, and then the further reduction we saw in 2016. So I think a couple things are important to note. One is there's a substantial amount of headroom left in the Bering Sea relative to what we saw this year compared to the overall PSC catch limits. The second is that in the Gulf of Alaska, the overall bycatch was actually quite close to that PSC limit. In fact, they experienced several closures in the Gulf of Alaska this year, and you'd never expect them to be able to get all the way to the full PSC limit just because of management implementation. So I hope that answers your question. I'll also note that these slides that we refer to during the question period, if they're not already posted on the web, we'll add those back so that anybody that missed this can see these slides as well. Noting that if you did want to see a particular source of removals within a particular regulatory area, I also have those tables available as well.
Ian, I have an observation and a couple of questions. I think it might be around slide 16, but you were showing the trends in the commercial WPUE and as well you had other slides showing the survey WPUE. And just looking at 2B from the commercial fishery itself, it's I would say from 2008 it's increased pretty much year over year, and it's kind of hard to tell from the graph, but it would seem it's probably up by 50% from 2008 or maybe even a bit more. And if you go back to what you have there from 1985, you're probably up over 100%. And then if you go and look at the survey data, it doesn't reflect those changes to the same percentages, I would say, in 2B to the same extent. And so I wondered if you had an explanation for why there was such a difference. And I guess when I do a comparison across the other regulatory areas, I don't see that type of increase in the commercial fishery to that same extent in 2B.
Well, thank you. I think that's a fair question. I see a similar rate of increase over this recent time period in both series. Honestly, I wish we had survey data that went back even farther. We have some survey information in Area 2B, and Ray may be able to piece together a series that goes a little bit farther back. We don't have comprehensive coverage over broad areas. It's a little more piecemeal prior to that. So I guess it's really difficult to say what we would have seen in the survey if we went back over the same time period. The biggest difference between these two panels, note that this panel goes back to 1998, and when we move up to the commercial fishery, this would be 1998 right here. And so actually that increase, the decrease from 98 through the mid-2000s is actually pretty similar in both these series. The scale is slightly different, but the same general pattern is there. I wish we could go back a little farther and corroborate that. Getting to the second part of your question of what factors could make these two things different, I think there are a number of factors that could lead to differences. The fishery is by nature going to target areas with more fish, and we spent some time last year looking at, particularly in 2B, the fact that we have seen some consolidation of fishing effort on areas of higher catch rates. And it's not necessarily that people are moving from lower to higher catch rate areas, but that there's more effort being expended in those higher catch rate areas. That was a particular look last year. I would say in general that the survey patterns are more consistent between these two series this year, given the output of Ray's model, than we've seen in the raw data in the past. But I think it's a fair observation that there are still some differences in these time series.
Going to where you were, I guess, more around slide 63, and you were making some comparisons about what was in the FCEY and what was out. And I'd raised this previously as well, I guess, last year at the annual meeting about what was not included in the FCEY in the 032, and in particular the rationale and policy around the unguided sport fishery, which are substantive amounts in two of the areas. So it seems to me that a direction that one may want to consider at least is not just looking at what we're talking about as far as setting limits around FCEY, but also on fisheries that are impact and should be a broader and maybe around TCEY. And similarly, that the SPR, this direction that we seem to be going in, would be consistent with that. So I was wondering if you had an observation on that.
Yes, I think the short answer is that the choice of which of these pieces are in and out of the FCEY is largely a management decision. In terms of my calculations, the calculations will be the same. It's just which rows of the table I put them in. Be much simpler for everybody if everything were in the FCEY. Then we wouldn't even have the distinction between these two things, and we could just talk about the yield available and the various pieces. Historically, the way I understand, the reason that I understand it's been treated this way is because we need to account for sources that aren't under the IPHC's direct control. And in order to do that, the only way to account for that year to year without ending up with a substantial difference between the target yield and the actual yield is to take those removals off the top. But this is largely a question within each regulatory area. I'll draw your attention back to, just as an example, to this table here, because I think it will help to discuss this. And just draw your eye to areas 2C and 3A. The top section up here, the 026 non-FCEY, are components that are not included in the fisheries CEY. And these components up here are a reflection of what the catch sharing agreements are in each of the areas. And I apologize, I forget what the catch sharing terminology that's used in BC is, but generally there's an agreement in areas 2A through 3A about which pieces are in and which pieces are out of the fishery CEY, and that's largely up to the regulatory agencies in those areas to make that decision. But it would certainly be simpler if all of those pieces were moved down. You can see that there's, for example, sport removals in 2C occur both in the non-FCEY and in the fishery CEY, and that's the delineation between non-charter and charter sport fishing.
Yes, okay. But I mean, it's clear that there is an impact on the FCEY. So Jim, I think I saw your hand up. No? Are there any other questions from commissioners? Linda?
Thank you. One more while we're on the unguided sport 2C issue. I haven't had a chance to look, but I assume that part of that jump from last year is that unguided sport number has gone up.
I can show
between
you that for
2016, 2000.
Area 2C.
15, 16.
And I have these tables. This is the same table I showed at the coastwide level, but this is now just Area 2C. I have these tables for all the regulatory areas if you're interested. I don't have the breakout of charter and non-charter, but actually you can see that there's the aggregate recreational removals are basically the same across these 2 years. There's been very little change in the recreational removals over the from 2015 to 2016.
Okay, thank you.
Steve, do we have questions from the online?
Yes, we do. Let me go back and read them here. Oops. So the first one is actually a question at the end of Ray's presentation, so maybe I'll ask the ones for Ian first. Ray Milovodov asks, does the 4C commercial WPUE data include logbook data from vessels using Snap-on gear? Many vessels operating out of the Pribilofs utilize Snap-on gear.
No, at this point, the indices for all areas except Area 2A and 2B do not include snap gear indices. We provided, two years ago, I did an analysis with Cole Monahan, and we looked at our ability to include all the various gear types in a logbook standardization. And at the time, we compared the trends that we were getting from snap and fixed gear and found pretty similar trends overall. The long-term goal of that project is to include all of the gear in our annual standardization of logbook catch rates. Cole has since gone on and expanded that, actually using a spatial model, much like the one that Ray presented this morning, to look at catch rates and also to compare between snap and fixed gear. And I would suggest that sometime in the relatively near future we will be ready to include all of those sources of data in the the standardized logbooks. But for the moment, the graph that I showed you today includes only the fixed gear logs. The rationale for that is because we have historically seen a difference in catch rate between the two gear types, and we want to be careful not to confuse a change in the rate of each gear type being employed with an actual change in the population. That would be the danger of not accounting for that properly. So that's why we've focused on fixed gear previously. But that is something we're looking to improve in the future.
Okay, thanks. The next question, actually we've already answered, but I'll repeat it online so everybody can hear it. Lyle Pierce asked about any way of scrolling back through the screens through the presentations, and I'll remind everybody that all the presentations from today will be posted at the IPHC website as the day goes on. The first two presentations are already up there. So the next question is from Nicole Fredrickson, who asks, going back to the stock assessment section, you mentioned that we are seeing historically low weight at age for females. There were studies, specifically by Hutchings 2005, which looked at the effects of overfishing on age and size at maturity in Atlantic cod. The study found that recruitment overfishing resulted in fish maturing at an earlier age and smaller size. Do you think that something similar has or is occurring for Pacific halibut that is driving this historical low weight at age?
It's a good question, even including a reference. We've already sort of touched on that. The short answer is that the evidence we have right now suggests that no, we haven't seen a big response in maturity at age, but it's certainly something that we'd like to know more about, and that's, you'll hear from Dr. Josep Planas later about our 5-year research plan to look specifically at that for evidence of changes in maturity. The question, though, sort of presupposes that this trend in size at age is somehow necessarily a function of fishing, and I don't think that's necessarily a conclusion that we can draw at this point. I would say that thinking back over the historical record, we saw a long time period from the 30s through the 1970s where we think that the stock was very heavily exploited, and yet we saw an increase in size at age. And so I think it's quite likely for halibut that there are multiple factors influencing size at age. Fishing is certainly one of them, but it may not be even the dominant one in that mix. The other thing I would point out is that one of the first places to look for evidence of the effects of fishing would be on the variance of size at age. So we look at, what I'm showing you there is the mean, but we can also look at the variance, and when we have looked at the variance in size at age, we find that it's quite conserved in the halibut stock. So even though we've seen a reduction in the mean size at age, we still see a large variance. It's actually interesting that Jamie chose to show a picture of a 400-pound halibut. That fish wouldn't exist if you had a strong size selective fishery that was actually cropping that variance down. The probability of getting that fish would be extremely low. Of course, it's low anyway. But there's more to it than that. Jane Sullivan at the University of Alaska just completed a graduate student project looking at this, and she found that some of the reduction in size at age might be accounted for by fishing, but not all of it, and that there's definitely, there has to be other factors contributing to this.
All right, thank you. And then the question from earlier is for Ray. And could Ray please explain for Area 2A how the change in total area before and after adding area from Northern California was accounted for in his modeling by years?
Could you repeat the question, please?
Yeah, so Deb Wilson-Vandenberg asks, could you please explain for Area 2A how the change in total area was accounted for in your modeling over the years, so before and after adding area in Northern California. So I think it's about adding that area in Northern California.
Thanks for the question, Deb. Last year we extended the bottom area of Area 2A that we use in our calculation of the biomass indices down to 37.75 degrees north, which is near San Francisco Bay, based on reports of halibut north of that area from the NIMS Trawl Survey. And we use the NIMS Trawl Survey data to help scale the weight per unit effort downwards to account for the lower densities in the area. And together, combined with the increase in the bottom area, that led to a slightly higher estimate of biomass for Area 2A. In the space-time modeling, we're modeling data down to 39 degrees north, which is the southern limit of the IPHC setline survey data. We're using station-level data in the space-time modeling and the station level data from the NIMS Troll survey that's down there, it's the only thing available to us, we don't think is a reliable enough data source at that level. It can give us a very coarse estimate of relative density in the southern part compared to the northern part, averaged over many years, but there's otherwise little relationship in the catches on that survey compared to our survey. So the answer to the question is we are modeling down to 39 degrees north, but we are accounting for all the biomass down to 37.75 degrees north as we did last year by weighting the weight per unit effort index by the bottom area down to that latitude. And we are using the scalar that we calculated last year to slightly scale down that weight per unit effort index to account for the lower density in there. So we're basically doing the same thing we did last year in Area 2A, except the model output is used for 39 degrees north and north of that.
Is that it for questions online, Steve? Okay, thanks. Let's see if there's questions here in the audience, and that's in Seattle. If there are, I'd ask you to come up to the microphone. There's one here beside me, and then there's one over on the other side of the room as well. All right, I don't see anyone running up. It's not a stampede yet. Okay. So we will move on then to the next item in the agenda. Thanks very much, Ian. So Alan, are you covering off both items in 6?
I'll be covering one item, and I think Adam and Michelle will cover the second.
Okay.
Should I close this? Which one is it? Those aren't it.
Yeah, why don't we do that? There's apparently a couple more questions from the online, so please go ahead.
Yes, both of these are for Ian. First, Philip Lestenkoff asks, does the unharvested 2016 catch limits, in other words, fish left in the water, get carried over into next year?
That's a good question. We often get questions about overages and underages. Overages and underages are already included in this year's results. So if fish were caught above a catch limit or below a catch limit, we use the actual catches or the best estimate of mortality that we have from each year. So if, for example, if there was a catch limit that was not reached in a particular regulatory area, the removals that I apply in the stock assessment model for that year reflect that, and so this year's status already reflects those extra fish. So they're already built into these results, any difference from regulatory catch limits. That's a good clarifying question that I get frequently.
Thank you. And then the second question is from Laney Welch asking, according to the 2017 Blue Line table, is it showing recommended increases for areas 2C, 3A, and 3B? I'm a bit confused. Thanks.
I'll go back to the table for just a second so we make sure we're talking about the same thing. I'm going to assume that the question is with regard to the fishery CEY. And this is now showing you the 2017 blue line in comparison to recent blue lines, the status quo SPR, and last year's adopted catch limits. I'll point out that none of these are recommendations, that the recommendation from the staff is to use the decision table to make the decision for the halibut stock, that we provide the entire decision table, which is a risk analysis, and it's up to the commissioners to do risk management and decide what the appropriate decision is. So none of these, in contrast to the previous process prior to 2012, none of these represents a recommendation from the staff as to what catch limits should be set. What's highlighted here for 2017 in the two purple boxes are the differences, or the areas that would show an increase in the blue line from 2016 to 2017, just for comparison. But also the lower rows, the status quo SPR, and then the bottom in purple is the adopted catch limits that we actually were put in place for 2016. So that should provide enough information for that question.
That's it for questions? Okay.
It'll just be less than a minute. We'll have it up.
Thanks, Alan.
Okay, thank you. The presentation is available now.
Could you identify it?
Let's see. This I don't know that it's posted on the SharePoint site yet, Jim. But there is a document that should be on your SharePoint site that is labeled 08. I forget the exact name of the document, but it's the MSE update paper. And I'll be presenting to that document.
The question was, I may have misunderstood. I thought when you said it was available, I thought you meant to the world at large. But, okay, thank you.
It's available to me right now. I will present it, and then it will be posted on the website. But that document is available, which explains this. So thank you very much, and thanks for your patience on that. I'm Alan Hicks, a new IPHC staff member since April of this year, and what I want to do is present to you a very short update on some of the management strategy evaluation work that we have been doing at the Commission recently. And the purpose of this is to really update the Commission on a task that was assigned to IPHC staff and the MSAB at the 2016 annual meeting, and that was to review and provide recommendations for updating the harvest policy and harvest control rules. A little bit of background before I get into that is when I started in April, we thought it would be a good idea for me to put together a 2-year work plan, and this was to be presented to the MSAB as well as the commissioners to give an idea of what I might be working on over the next 2 years. And those are things that range from me becoming familiar with halibut, which is really an ongoing process, to investigating spatial model complexity in the MSE that we'll be conducting. But today, what I would like to focus on are 2 of these subtasks under a task identified as number 5. And that is 1, to outline our current harvest policy, and 2, to identify other management procedures that might improve upon the current harvest policy. And that's what I'll focus on today. So what is the current harvest policy? And by that, I mean it's the policy that defines the catch that's defined by the blue line, by that blue line that Ian presented earlier today. And this harvest policy was designed to meet 5 goals when it was designed, I guess, over a decade ago. And that was 1, avoid very low stock sizes, and a low stock size is defined as 20% of unfished biomass. 2, mostly avoid low stock sizes, which is defined as 30% of unfished equilibrium biomass, and by mostly it means 80% of the time. Don't go below this 30% unfished equilibrium biomass more than 20% of the time. Third objective was to achieve most of MSY, 80% of the time. A 4th one, reduce variability in catch. And then finally, to distribute the removals in proportion to the current stock biomass, which is preserving biocomplexity, and that's what Ian was talking about with apportionment. So Ian set this up nicely for me because I'd like to present the current harvest policy in terms of scale and distribution. And as Ian defined scale as the amount of fishing effort on the entire the entire stock, or you think of it the fishing intensity on the coast-wide stock of halibut. And scale in the current harvest policy is defined through two concepts. One is exploitable biomass, or EBIO, and the other concept is through harvest rates, and I'll define these in more detail shortly. The second concept of the harvest policy is distribution, and this is how you distribute those catches throughout all the different regulatory areas across the coast-wide stock. And this distribution right now in the current harvest policy is defined through apportionment and also through relative harvest rates, which I'll define in more detail. But it is important to note, you see harvest rates is involved in both the scale and the distribution parts of this harvest policy, and they are not independent. One of these cannot be made, a decision cannot be made on scale without a decision also being made on distribution in this context. And that's something we'll talk about more in this harvest policy. So to show how that works a little bit better with a picture perhaps, is we have here a coast-wide assessment, and that's what Ian presented today. And from that, he determines an exploitable biomass, and I'll try to explain that in a moment. From this exploitable biomass, or EBIO, you apportion that out onto the regulatory areas, and then you apply a harvest rate to each of those regulatory areas, where each regulatory area has its own harvest rate. There's two different harvest rates, basically. And then if you wanted, you could sum up those catches determined for each regulatory area, and you could sum those back up into a total coast-wide catch. So a little bit more detail about these different components. The scale of exploitation in the current harvest policy. I mentioned EBIO, and this is that exploitable biomass. It's basically using an externally derived selectivity, or selectivity curves, to represent what the fishery might be encountering. The problem with this is, right now it's not representative of the current stock assessment. It is outdated. The second concept in the scale of exploitation are harvest rates, and these are area-specific harvest rates, where in western areas, 3B, 4A, 4B, and 4C, D, and E, it's a lower harvest rate than in the eastern areas, area 2 and 3A. And note also that the harvest rates can be reduced when we go to low stock sizes, less than 30% of unfished biomass. Those harvest rates would be reduced linearly to a value of 0 harvest at 20% of unfished biomass. So that's how the scale is determined, calculating an EBIO and then applying harvest rates to those different EBIOs. But that requires the distribution, because this apportionment occurs before the harvest rates are actually applied. And so the distribution of exploitation along our coast is done first by apportioning that EBIO to the regulatory areas, and as mentioned earlier, that is done with the 032 biomass, or the 032 WPUE from the set line survey to do apportionment. And then those relative harvest rates are applied to each of those regulatory areas. So you can begin to see how those distribution and the scale are intermixed and not independent of each other. So what are some of the problems with this current harvest policy that I've at least identified? And working with the Management Strategy Advisory Board, we've also identified. One is that I've been mentioning, the scale or the fishing intensity and the distribution, the catch across the areas is confounded. We have this coast-wide assessment, calculates an exploitable biomass, which is related to the scale. It's apportioned, which is related to distribution. Harvest rates are applied, which is related to scale. And then you can sum that all back up to get a total coast-wide catch, which determines the total scale on the stock, or the fishing intensity on the stock. The second issue with the current harvest policy is that EBIO is inconsistent with the assessment results. The selectivity is out of sync with the current assessment. It does not include all sources of removals, the EBIO, and it doesn't exactly represent what mortality is from the directed fishery, mortality. So it is out of date, and that's what the MSAB has stated it as. And then finally, we've also discussed today at one point was that the mortality of U26 are not explicitly accounted for in this harvest policy. So all mortality is not explicitly accounted for. We have apportionment which works on O32 fish. We have harvest rates, which works on O26 fish. And then we have eBio, which we don't really know exactly what fish that's working on. So the TCUI or the FCUI, as Ian showed earlier, remains unchanged regardless of the amount of mortality on U26 fish. So he noted earlier, if you switch between those tables, if the total mortality on U26 fish changes, that does not change the catches coming from the current harvest policy. The thing is, we will realize the mortality later as we see a change in productivity of the stock in later years. If we're if more under 26-inch fish are dying now, we will realize that as a decrease in productivity in future years. The issue with this is that let's say the commissioners would like to set some target mortality rate, and they're basing that on a O26 harvest. What happens is, depending on the amount of U26 mortality, they might exceed that target or they might be below that target, depending on how much U26 mortality there is. What can be really dangerous is if they want to act precautionary and set a lower harvest rate for some reason, depending on the U26 mortality, they could actually be exceeding the target harvest rate that they wanted to set in the beginning. So really it's down to accounting for all sources of mortality. So a little bit of history on managing on total mortality, or how this has been thought of. Early assessments included only age 8 and older halibut in them. And then it was decided, okay, well, let's include age 6 and older because it appears that some mortality is happening on fish a little bit younger than 8 years old. And then management was based on O32 mortality. And in 2011, they updated management to account for O26 mortality in the TCUI. My proposal is, why don't we just go to O0, over zero mortality, and account for all of the mortality. This would account for removals across all fleets and all sizes. The problem with this is we need a measure that accounts for all sizes and all sources. So selectivity varies between the different fleets, so it's not as simple as just saying, okay, what's the harvest rate? Because we have multiple fleets, we have multiple sectors, and we need a measure that will account for all the sizes and all the sources of mortality. So let's think about this as a way of rearranging the current harvest policy and thinking about it from the concept of scale and distribution. Again, we're starting from a coast-wide assessment that Ian's presented already, and we want to determine what the total mortality on the stock would be, say, in 2017. So what we'd want to do is set a scale that measures the total mortality. And then once we have the total mortality, then we want to distribute that across all the different regulatory areas, across the habitat of the Pacific halibut. Well, we can do that by defining a coast-wide fishing intensity, and an example of that would be an FSPR, a spawning potential ratio type metric that Ian has already presented, and he's been presenting for a number of years. Once we do that, that defines our total mortality, and then we would simply use apportionment and relative harvest rates, as we've already been doing, and we can solve for the coast-wide catch that's then split amongst the regulatory areas. So this sort of diagram makes a little bit more sense to me in that it's capturing the total mortality on the stock, and you have a decision that you can make on the scale, and then given that total mortality, it distributes it across all the regulatory areas, and you have a decision how that's done. Currently it's done with apportionment and relative harvest rates. So it's a natural flow from the coastwide assessment to the regulatory areas. So I mentioned spawning potential ratio and this F associated with a certain spawning potential ratio. So I wanted to quickly define that for you. And it's basically the theoretical definition of it is the spawning biomass per recruit with fishing divided by the spawning biomass per recruit without fishing. So you can think of it, the spawning potential of a recruit, and whether that recruit, how long it can survive throughout its lifetime. It's subject to mortality such as natural mortality, but also fishing mortality, and compare that to the spawning potential of that recruit if there was no fishing mortality put on that recruit. So it's an equilibrium concept, a long-term average in other words, and it can be easily calculated in the stock assessment. The quantities are already there to calculate this value. It provides a measure of fishing intensity on all sizes and all sources over all the different fisheries. So this is the metric, this is a metric that could be useful for this new concept that I'm proposing. And basically what we would want to do is find a fishing intensity that results in a specific spawning potential ratio, or as Ian was saying earlier, a reduction in spawning potential. So this is what he has notated as F with a subscript SPR equals some percentage. And I'll show you what that means in the decision table shortly. So to map to this what I'm calling an SPR-based approach, to map our current harvest policy over to an SPR-based approach, all that we need to do is introduce an FSPR to set the scale. The distribution can remain the same for now using apportionment and relative harvest rates. But what we would do is be setting the scale with an FSPR. And Ian has already been presenting this in these decision tables for a number of years. So he set me up well for this. And I'll show you an example. He has this column called fishing intensity in his decision tables. And this is that F subscript SPR. So as I said, the subscript, the percentage, refers to the reduction in spawning potential. So without fishing, well, there is no reduction in spawning potential. So that's why there's 100% subscript there. Once we introduce fishing, we introduce a reduction in spawning potential. And Ian mentioned earlier that this blue line would reduce the spawning potential by 52%. And that's why this is a F48% SPR rate, or fishing intensity. Now, he's also identified a line here called status quo SPR, which is, as he put it, is basically what have we been doing over the last 3 years. So this is looking back and taking an average FSPR over the last 3 years based on the decisions that commissioners have made, and putting that SPR as the scale, setting it as the scale in this proposed harvest policy that determines the catch levels and the total removals. So you see there really is no change to the decision table. There's just a slightly different change to how we're thinking about the scale, and that we're accounting for total mortality now. And so you can see the catch levels under that status quo SPR are slightly higher, thus the SPR is slightly lower. It reduces the spawning potential a little bit more. So what are the benefits of an SPR-based approach? One, it accounts for all mortality over all sources. We're going for O0 here. Why not manage on O0? Two is separate scale and distribution so that you can make decisions separately on scale and separately on distribution. And three, what I'm most interested in is it allows for the evaluation of the scale in an MSE, or management strategy evaluation context. And that means that I can go away, work with the Management Strategy Advisory Board, and we can evaluate different values of the scale against certain objectives. With the current harvest policy, that would be difficult. This really makes it easy. So looking into the future, right now we've presented to you the status quo SPR, which is a stepping stone to map to a new harvest policy, this SPR-based approach. One, it's consistent with the decisions that have been made over the last 3 years. And empirically, those decisions have been good decisions. The stock is either stable or increasing. So empirically, maybe in recent years, not maybe in the long term, but in the short term, this could be a good harvest policy to follow, this status quo SPR that we presented. In the future, we would definitely want to investigate this with a management strategy evaluation. And that would be to investigate various values of FSPR to see what level of fishing intensity matches our goals or best meets our long-term goals and objectives for the management of Pacific halibut. So in the document that's available along with this presentation, at the very end there's a couple of recommendations, and one of those recommendations is to consider this proposed harvest policy, which is presented as the status quo SPR in the decision table. And two, to note that myself and the MSAB would like to use this modified harvest policy as in our MSE to investigate different values of FSPR and as a way to account for all mortality. So I'll take any questions after that, unless you want to wait for the presentation that Michelle and Adam will give on an update of MSAB progress in 2016. Thank you.
Thanks very much, Alan. Why don't we have the full presentations from Adam and, are you doing it, Adam or Michelle? Okay, so why don't Adam and Michelle come up and provide their presentation, then we'll take questions on the full suite.
Yeah. So thanks very much, Chair. And thank you, Alan, for setting the table for us. As you mentioned, Michelle and I, as the co-chairs of the MSAB or MSAB, I don't know, is it like Z or Z, about or about, whatever, Canada, I say MSAB. We'll provide a brief progress update, and then as Commissioner Rouse, just to take some questions on overall. So as folks will likely remember, at the annual meeting, Michelle and I presented on our progress for the past year, 2015. We talked about some newly recommended governance changes for the advisory board, some of the changes with commission staff that would affect the work of the group, and most importantly, perhaps, we were tasked by the commissioners with evaluating the current harvest policy. So with those orders in hand, to that end, we met twice in 2016, and we covered a number of topics. We solidified some of the governance changes that we had mentioned at the annual meeting. We talked about fishery objectives, which, as you'll recall, through a management strategy evaluation process, is iterative. So it seems like we're always talking about objectives, which is a good thing. We also talked about a number of management procedures and scenarios, including an evaluation of the current harvest policy. So we'll go through some of those specific discussion items in detail now.
Great. So just we'll briefly run through these items. Alan covered a lot of this also in his broader MSE update. So on the governance and work planning, we updated our terms of reference. And this is a document that describes our mandate, how we're organized, how we make decisions, the membership of the MSAB, and how our meetings will be conducted and reported out. So it's our understanding that IPHC staff are going to be proposing changes to the MSAB terms of reference to standardize them with IPHC rules of procedure. So there will be a thorough review of all IPHC advisory body terms of references for standardization. And then the 2-year work plan that Alan just presented to you, that was presented to the MSAB, that prioritizes the tasks that he'll be working on and identifies a timeline, and the MSAB thought that that was appropriate. And then we also revisited the goals and objectives. They were originally developed in 2014, and at the time we developed them, we were trying to think broadly, think long-term, what we would like to see the fishery looking like, and then in coming up with what the measurable outcomes may be, we put in some placeholders, if you will, and got down to some pretty specific amounts of female spawning biomass, for example, understanding that we did not know what the right or the exact amount should be to put in for those measurable outcomes. So the MSAB did a review of what's the underlying intent of those goals and objectives, what is it that we're trying to achieve, and did some fairly good discussion about that, but then also identified a need to revisit and refine the objectives and develop measurable outcomes to assist Alan with his progress for the MSE effort. And we identified that as an item for our agenda for our May 2017 meeting.
So as we continued on our progress into October, we ended up discussing scenarios and management procedures, which is really, we're getting to the meat of the closed loop simulation. And I guess it was fortuitous timing where we had an opportunity to talk about abundance-based management measures for a bycatch prohibited species catch limits as a potential scenario. The MSAB's mandate includes identifying management strategies that are robust to this bycatch. So it was a good case study, it was a good example for us to start wrapping our minds around how we might put forward management procedures and scenarios. We spent a fair bit of time talking about it, and I think it was really just about trying to get folks up to speed to understand what the next steps would be. The bulk of our October meeting, though, was actually spent talking about the evaluation of the current harvest policy. I think everyone felt that to be a very worthwhile exercise. So now, Alan's already given us most of the important details, so we'll just go through a brief summary here. Some of the context to be aware of that we felt was important was that we need to acknowledge that management has evolved considerably over time. A good example of that was a discussion we heard earlier this morning around how TCEY and FCEY have evolved, and we continually adding more and more components of the fishery into that. But it's still not an apples-to-apples comparison between regulatory areas of what's part of the catch limits. So if you want to go to the next one. So in getting the actual harvest policy itself, staff highlighted one particular concern that really stood out, and that's the challenges we face with eBio. So eBio is central to the harvest policy, but it's something that's really difficult to define. It's not well understood by stakeholders, or many it seems. And that's in part because the concept has evolved over time with the evolving harvest policy and management regime. What did become apparent through the end of the review, though, was that not all sources of mortality are accounted for within the current harvest policy, particularly the mortality from U26. I think Ian had said this morning that there was a 2.5 million pounds of mortality that's essentially unaccounted for using this current approach. So in light of the information that was presented to the MSAB at the October meeting, and in response to the direction from commissioners from the annual meeting, we found that the current harvest policy is unresponsive to under 26 mortality, and that the selectivity curves used to define the eBio are outdated. So with these concerns about the current harvest policy, we made a recommendation that the alternative harvest policies need to be developed to address these shortcomings, that the current harvest policy is out of date and we need some alternatives. We suggested that a spawning potential ratio-based harvest policy is one avenue for exploration, for the reasons that Alan just shared with us.
So just to follow up what we're looking ahead to our next steps, we typically meet twice a year in May and October, so we're looking for our May meeting to be the week of May 8th, and the preliminary agenda topics would be to get an update from Alan on the spatial area model development. We'll review and refine our goals and objectives, identify some measurable outcomes and performance metrics from those goals and objectives for Alan, and develop some scenarios including the abundance-based management and some management procedures to evaluate an alternative harvest policy, of which an SPR-based approach could be one of those alternatives. And we would anticipate reporting the results of that in October, and then have a potential alternative harvest policy that could be available for the Commission's consideration in 2018.
One additional point about the spatial area model development and goals and objectives, and I invite Alan and Ian to speak to this as well. A particular challenge that the MSAB and staff have faced over the past couple of years is trying to understand the trade-offs and then make a decision between having a single coast-wide assessment or multi-area based assessments. As folks know, at the annual meeting, everyone thinks about their regulatory area, and most folks' fishery objectives are explicitly about their regulatory area. The challenge with that is trying to develop a model for each regulatory area like we had in the past, and still use that within our within the Commission's existing assessment framework. So, the question is, do we spend a bunch of time investing in a bunch of multi-area models and that can answer our area-specific objectives, or do we try to make some progress now with the tools at hand, a coast-wide assessment model, and do things like evaluate our current harvest policy? So that's going to be a big item of discussion at our next meeting, is to see how the spatial area model development has progressed, and then staff will also need input from MSAB members to really understand what are our most important fishery objectives and goals, because if we have a priority to say we need specific spatial area questions to be answered, well then they'll need to invest time in that sort of modeling approach.
And I guess the only other thing I would add is that in discussing the abundance-based management, I guess we want to, the MSAB wants to make sure that it has a good understanding of what that is. We also want to be very respectful of the different management authorities relative to the North Pacific Fishery Management Council and its role, and the terminology associated with the management strategy evaluations, of which I'm rapidly trying to come up to speed on. So in looking at scenarios are items that are not under our authority or under our control, and there's various scenarios that could be acts of nature that we need to take into account, or management actions by other entities. And so management procedures, on the other hand, would be those items that the IPHC would be able to directly control through regulatory action. So just wanted to make that distinction, clarification as to how the MSAB may be looking at that through this.
All right, thanks very much, Michelle and Adam, and I think there probably will be questions for Ian as well, so I'll see if the U.S. Commissioners have any first. Linda.
I guess question to Alan, this is going back to the estimate of zero, going down to 0, I guess. And the estimate you came up with for the 2.5 million that was not included under the current harvest policy that would be included under an SPR approach. Can you talk about where that number is coming from?
I could. I think Ian might be better to answer that question if he may. He's more familiar with how that calculation is done.
So currently the U26 mortality estimates are based on the totals that are reported. Thanks, Adam. Are based on the totals that are reported. For example, for bycatch, we would get a total number of pounds reported, but we would also get the length frequency associated with that. And so we would use those length frequencies to delineate between the O and the U26 portion of that. And it's quite an involved calculation. It's all done with regard to the harvest policy. With regard to the stock assessment, those removals go directly into the stock assessment. We have a selectivity curve that represents them, and it all works just fine in the stock assessment. All the mortality in recent history has been included in the stock assessment. This is only a delineation that we're talking about with regard to the harvest policy.
Any other questions from the U.S. Commissioners? No? Canadian? Well, everyone's thinking about it. So I guess one question I might have for all three of you, it seems to me the biggest change potentially here is around the performance metrics that you're testing if you're going to move to the spawning potential ratio. If I'm hearing you correctly, the other parts of what would be potentially included as far as discussion between commissioners in setting regulatory area harvest levels would be still unchanged by what you're proposing right now.
That's correct. There are not many changes to the harvest policy with this SPR-based approach, and that's what Ian and I really wanted to do, was to show that we can map over to an SPR-based approach and still keep the harvest policy, and to show you that the harvest policy can still be exactly the same, the catch coming out of it. It's just really how you're thinking about it is different, in that we're accounting for all mortality, and we're thinking about the scale on the total coastwide stock, and then distributing it out amongst the regulatory areas. And so we're separating that scale and the distribution, which will hopefully help the decision-making process. With regard to the performance metrics, that is something I think independent of this, of whether or not how you have the harvest policy or how you set up the harvest policy. And in the MSE context, what we want to do are identify some performance metrics, and those might be things like the variability in the catch from year to year, or the size of the catch on average over a number of years. And so those different performance metrics can be constant across the evaluation of many different management procedures or different harvest policies. So then we can compare the harvest policies. And the nice thing that we would do here is take the current harvest policy and its performance and compare it to an SPR-based approach and see how different they are. And what Ian and I have tried to do right now is to map that over into this is an SPR-based approach that's consistent with the decisions you've been making in the last 3 years.
Jim.
I'm not quite sure to ask this exactly, but your envisioned revamped harvest policy, and I'm not sure I agree we have a current harvest policy, but the one that you would envision developing still would do nothing towards standardizing or giving advice, that's wrong, there'd be advice, nothing towards standardizing, for example, the exploitation rate across regions. Because I mean, you could, for example, in 3A have a spawning fishery intensity of F70, and then 2A you could have a F10. So your new harvest policy won't direct that kind of standardization or equalization or anything like that.
It is basically trying to standardize the mortality on the coastwide stock. So I think what you're saying is correct, is that we're not trying to standardize fishing intensity in each regulatory area, but we're really thinking about it as the coastwide stock, the halibut stock as a whole. And then the distribution is done through apportionment and relative harvest rates. And to expand on that, remember the harvest policy is a reference point for the commissioners to see the long-term averages of this harvest policy meet the objectives that were set out when the harvest policy was defined. And so, you know, the nice thing about separating scale and distribution is now you can separate those two decisions. You can say, I only want to have this sort of fishing intensity on the coast-wide stock, but I want to distribute it maybe a little bit differently than our harvest policy says to distribute it. And you can do those sorts of things much easier now than the current harvest policy allows you to do.
Maybe, oh, I'm sorry, Bob, go ahead.
So when you've completed this discussion, I have a comment to make, and I don't know where you're at on this, Mr. Chairman.
I just had maybe one other clarifying question, and then I was going to go to see if there's any public comments and then come back to the commissioners. That's what I was thinking, Bob. Is that okay? So what you're proposing is to, use SPR as, I'm going to use the word metric for what we want to do across the stock at whole. And that would replace eBio, which for a number of reasons that you just went through is problematic. The other piece of it is around the MSAB, which while we've been using, I would say, pretty much SPR for the last 3 years and making decisions around that to some degree to set how we determine what's going to be harvested in the directed fishery under FCEY. We haven't put rigor around the outcome of what that means to the stock, and the MSAB would be able to do that by testing out various, as Michelle said, scenarios where there may be things that are beyond our control, as she spoke about, whether it be climate change or whether it be harvesting different sizes of fish, or those would actually be a procedure, but the other may be is other regulatory agencies would have some control that how the Commission does, and we could test those out and see what the impact is. But it doesn't really change the other parts about how the Commission makes decisions. And you're still proposing to continue with the process of distributing that harvest if one agrees to an SPR to distribute that using apportionment across the various regulatory areas. So I guess that's what I was hearing from the presentation, so just seeking clarification.
Yes, Paul, that's a great summary, and thanks for that.
I was going to come back if that's okay. Okay. Are there questions online?
No questions online.
I'll just see if there's any questions in the room. Do you want to come up to the microphone? Yeah, I think that one's available.
Thank you. Okay. Hi, I'm Heather McCarty, and I have a question, I think, for Dr. Hicks. When you were making your presentation, and by the way, I know this is being brought up a couple of times, it would be really nice if the public could have the presentations online while this discussion is going on, because we can't run back through and check, where things are, and so that we can ask a real question. So this may be a little off, but you said that at one point that the decisions that the Commission had been making were the right ones because the stock was stable or slightly increasing. And then you said something about the new method would allow discussion about whether the decision making was meeting the objectives of the Commission. And it struck me that there was an assumption there that the objective was to stabilize or maybe slightly increase the stock. And I was just wondering if that had ever been actually stated, that this was an acceptable level of the stock, or whether that it was potentially an objective to increase the stock of Pacific halibut coastwide or even in different areas. Do you understand what I'm saying? It just struck me that we've all been sort of trying to stabilize things rather than taking a look at whether the stock should actually go higher, and we should work towards that.
Yes, thank you, Heather. That's a really good question, and maybe the use of the term right decisions wasn't the right term to use. Maybe good decisions is the right term to use. So the Commission has been making good decisions in that the stock has stabilized or is slowly increasing. And that is separate from the objectives. I didn't mean to imply that that is an objective of the Commission, that we wanted to stabilize the stock or increase it slowly. I think many people and what I've heard from a lot of the stakeholders in the halibut fishery is they would like to see an increase in the stock because we're at a pretty much a low right now. So the decisions that the commissioners have been making in the past are not bad decisions, in that we're headed in the right direction of what I think most people want to go to, and what we're working on in the MSAB, MSAB, Management Strategy Advisory Board, is to clearly define what the objectives are in the fishery. And we're currently really working on that. We have some broad definitions, but we're getting down to the details and exactly where do stakeholders want to see the stock in the future. And so stay tuned for what the actual objectives are and what harvest policies could bring us to those objectives. And you also make a great point in that part of the results that I will present from the management strategy evaluation are, one, how likely are we to meet those objectives, but how long might it take to reach that objective for certain measures. So thanks for that clarification.
Yeah, Adam, did you have something to add to
that? Just to follow up with Alan's comments, that the MSAB has been working on revising objectives. For Heather or those listening, our draft objectives are available on the IPHC website as an MSAB document. You're welcome to review them. I think we presented them a number of times at annual meetings and inter meetings before, but it's a place to start.
Okay, thanks very much. Jeff, do you have a question?
Yes, thank you, Mr. Chairman. Obviously, I'm from the Bering Sea region, but my question is not related to the Bering Sea. But the questions that I have are regarding the presentation that Dr. Stewart gave earlier. And it seems to me that there's some disconnect between the blue line staff advice and the commercial catches and the survey catches. So I wanted to highlight that, particularly looking at area 2B. Their survey was up by 2%, their commercial catches were up by 9%, but yet their blue line is down by 9.6%. When you look at 3A, I think their survey was up by 11%, their commercial catches were up by 7%, but yet their blue line was down by 11.7%. So just trying to figure out why the disconnect when we're seeing improvements in the commercial catches in the survey data, that the output on the backside in the blue line is actually a reduction from last year's blue line.
Thanks, Jeff. I don't have the presentation to get back to here, but that's a good point. There is an apparent disconnect there, but in fact, the cause of that is that the results of the space-time modeling that Ray presented, although they've shown an increasing trend in the survey, and that's consistent with what we see in the survey across Area 2, pretty much not just 2B, but also 2A and 2C as well, our estimate of the overall scale of the biomass in those areas relative to all the other areas has gone down slightly. And one way to think about this, the apportionment estimate is a percentage that sums to 100% in every year. And so it's not as simple as looking at whether a survey went up or down. For example, in one particular regulatory area, if the survey goes up slightly, but all the other areas go up to a larger degree, then it will actually get a smaller share based on apportionment because it's relative to the average across all the areas and because it all scales to 100%.
Do You have a follow-up question, Jeff?
Yeah, thank you, Mr. Chair. I just wanted to clarify, actually, I was talking about 2B and 2C, not 3A, so that should have been 2B and 2C.
Thanks, Jeff. Coming back to the presentations that we just heard from Alan and Michelle and Adam, did you have a follow-up question, Linda, or comment? Yeah, go ahead, Linda.
Thank you. I just wanted to follow up on a comment about the spatial area model development sort of versus taking a look at moving to a new harvest policy. I'm not sure I understood that trade-off. I think it was something that Adam said, and maybe I'm just not familiar enough yet with what the goals are of developing the spatial area model. But I wonder if you could just clarify whether that was a piece you were looking for some kind of direction from the commissioners on, or what the decision point is between those two.
So at the MSAB over the past couple of years, we spent a lot of time talking about fishery objectives that were regulatory area specific. At the time, the models that were available to us through the Commission weren't able to evaluate area-specific fishery objectives. And so we'd spent a fair bit of time going back and forth amongst ourselves around, do we want to hold off on advancing the MSAB work while staff develop area-specific models, or a way to evaluate area-specific objectives, or do we try to make some progress with what we had at hand and be able to bring that progress to the group? So for example, this recommendation to use an SPR-based approach to evaluating the harvest policy, that's possible with the coast-wide model. And if we wanted to wait for the area-specific models to be developed, we wouldn't be able to make this recommendation or subsequent steps for some time. I don't know if Alan or Ian would like to add more to it, but that's my recollection of where we are. And in terms of advice from commissioners, I don't know that there's something specific that we're seeking at this interim meeting, but we would greedily accept any advice or recommendations that you want to provide to us.
So you're open then, Adam. Alan?
Thanks, Adam. That was a good characterization. And I'm really excited about this SPR-based approach that I presented because it is thinking about coast-wide stock and the impact on the coast-wide stock. And I think that's a really good place to start with evaluations. And we can start with that by looking at the coast-wide, or using a coast-wide model, or a single area model is what I've been calling it. Moving to multi-area models, I think in the future will be necessary as we develop more of our goals and objectives. And right now we're developing goals and objectives that are like keep spawning stock biomass high, or above some certain level on a coast-wide basis. But as people get more into the process, they're going to realize, you know what, I want my area to have this sort of catch rate or this objective in my area. And that's when we'll need to start moving to the multi-area models. So this really is an incremental process as we grow over time. I'm going to have a job for a number of years because there's a lot of things to do here. And starting simple right now is good, and moving towards and then distributing it out is how we'll go in the future.
All right. Any other comments? Bob?
So, Mr. Chairman, I've been listening quite intently to where we've come from and stabilizing the resource the last 3 years, as Dr. Stewart pointed out, with some ups and downs, about half slightly up, slightly down in the different areas, in the 8 areas this year. But nevertheless, it looks like we've stabilized most of the resource throughout its range. And I'm not satisfied with just flattening off and stabilizing. I think the Commission needs to have a vision quest and be proactive in that vision quest. And Dr. Hicks was going through some of his objectives that he had lined out one of which was achieving MSY 80% of the time. Dr. Stewart, in his presentation, if you remember the green graphic of the last 100 years, I believe the total yield, including a variety of aspects for that yield in terms of commercial, sports, and other takes, was about 63 million pounds. I think we ought to try to achieve somewhere in a range of 55 to 65 million pound vision quest, and I'd like the staff to come back and tell us, does the current harvest policy get us there? Does the SPR policy get us there? Which one's better? There's a couple givens in here too that with the status quo of bycatch, both in total numbers and in structure, meaning there's a lot of smalls in the Bering Sea that are taken. What impediment is that giving us? And without changing the ratio that the commercial and sports and subsistence take versus the total bycatch now, so that I don't want the staff to come back and say all of this is achievable, just reduce the commercial catch by 50%. So those are sort of the givens, and I would invite other commissioners to comment. Maybe I haven't quite said this as succinctly as I need to for the staff to draft something up, so I'd look for some help, but I think we need to have a quest, Mr. Chair, and that's what I throw out there.
Great, thanks, Bob. I'll just see if any other commissioners want to weigh in. Linda?
Thank you. I agree with Bob. I think I would add to that based on the presentations that we've seen, based on the performance of the Commission over the last 3 years, that there has been somewhat of a broad recognition that the current harvest policy is not serving us well. And what I learned at MSAB, what you showed today, helped me to understand why a lot better than I understood before, of outdated selectivity curves, of problems with eBio, sort of mismatches between what part of the stock we were including when we looked at the harvest policy and how it was set. And I believe that the SPR is approach that a whole lot of aspects of this review of the harvest policy has pointed us towards. A big one for me is that it takes into account mortality of all sizes of fish, and I think so allows us to be explicit about what the mortality on small fish, what effect that has on yield, what effect it has on spawning biomass of the future, and so that it is a better direction for us to move. I think it's really important for the IPHC to have a consistent harvest policy, and to my mind, the SPR is the approach that we should be moving towards.
All right, thanks, Linda. Anyone else? Dave?
I agree.
Thanks, Dave. I think I'd offer a comment now too, in that from what you were saying, Bob, about you know, having a vision quest, and it relates to, I think, the question that Heather was asking us overall, that we, for the last number of years, that we've had a direction of not following the blue line, that we as commissioners have made choices and around risk based upon what we've heard from staff, and have first off not followed the blue line and have adopted different amounts in different regulatory areas, and not the same across all regulatory areas as far as ups or downs, but considering all the factors that we heard from and advice from the staff. I think we've also, for the last number of years, have been speaking about spawning potential ratio as a way to consider managing the stock too. I think it's a good overall direction. I do think there are still a number of other pieces, so in the harvest policy, that remain not covered if one just moved in that direction. I think we as commissioners may want to have some more discussion too about how we had word some advice back to staff to you spoke of, I think, Bob, you said from 55 to 65 million is trying to understand what that would take to achieve that. What I take from your comments is that it's not just enough to remain stable, that you're looking to see some growth in the stock, and you were putting out there that getting back to somewhere around the average would be a lofty goal, and see what the impact is.
Mr. Chairman, that's correct. Thank you.
So maybe we'll have some more discussion on this and think about how we'd want to word something back to both to staff and get some feedback on this as well. So if there's no other comments or questions on this at this point in time, let folks go here. Alan, and thank you very much, Michelle and Adam, for addressing and putting that presentation to us as the Commission. We still have item number 7 to go through, and we could start on it, Dave, or we could take a break now. I maybe seek your guidance. Okay, we're going to take a 15-minute break, and we'll get back together at 5 after 3. That is. All right, just before we go on to the next section, I think there was one more questioner from Commissioner Alverson.
Yes, Mr. Chairman, I had a question to Dr. Ray Webster. He's over on the far side there. So, had to do with hook competition, and one of the base assumptions I'm assuming you're making when the survey sets out a skate of gear, that skate of gear is 1,800 feet long with so many hooks per distance. Is that the base assumption that you're using? Because that's not necessarily accurate when the guys set the gear and you have tied and whatever, that gear is not necessarily stretched out 1,800 feet. So you could have hook density within your skate length at different levels for each skate, depending on how you set the gear. So are you taking into consideration or weighting that to any degree when you come up with the conclusions you gave us?
No, I'm not sure how we would do that. I'm not sure how we would get information on distances shortening on the bottom or...
Well, I guess my observation is if that's a base assumption, it's not necessarily an accurate assumption, because none of these skates, when they go down, they aren't necessarily just straight with an anchor on either end. Once the tide and stuff gets a hold of them, they sail and they do what they do, and you can have in that distance of 1,800 feet different densities of hooks in that area. So.
Okay. Well, we have, as you know, we've standardized the survey as much as possible, including distance between hooks. The analysis doesn't use distance anywhere in the calculations. It just uses the number of baited hooks and the number of baits that we get back divided by the number of hooks that were set. So they could be bunched up or stretched out, but it's just the number of hooks and the number of baits that were returned. that are the information that feeds into that adjustment.
But if there's more hooks in a given space versus
They could be fishing slightly differently. They could be more or less competition at a local level within a set. I guess there's this assumption involved in this, and those effects average out over many sets. There'll be some variation, and for a given set, that's part of the natural variability it's part of the variability in the data. There's a lot of things that affect catch.
What I was seeing in your conclusions, though, is that it could affect maybe up to 5% by area, and I'm just wondering if the base assumption isn't variable by 5%. So
if we have some way of getting information on that, we could try to incorporate it. Otherwise, it's just part of the variability. None of these things are absolute values that are known with complete certainty. So we work with uncertainty in the data, and that is part of the uncertainty.
Okay, thanks, Ray. I guess one of the benefits of what you're doing now, though, is that you are calculating that variability. And so what I think you may be saying as well is that that's going to be incorporated within that calculation. Is that correct?
That's correct. At least the variability amongst competition, the variability in the level of competition among stations is now for the first time incorporated into the uncertainty in the estimates of weight per unit effort. Yeah. Jim?
Since we made Dr. Webster come back up here, I was going to save this for the side, but so in one of Dr. Stewart's tables, for example, he looks at the status quo SPR, which is F46, but the range is from 32 to 60. So what contributes to that 32 to 60? Would it include things like uncertainty and your hook competition? Do all those parts of uncertainty build up, so that's why it's 32 to 60 at the end?
Yes, all those various pieces do accumulate, and the uncertainty that Ray gets from the space-time model is part of the overall uncertainty in the stock assessment. So the confidence intervals on the survey index are one thing that feed into, but it's also the information content of the survey index. Whether or not a particular piece feeds into those confidence intervals within Ray's analysis, I guess, would be a different question. But the assessment uncertainty is cumulative for all the various pieces going in.
Thank you.
Okay, thanks very much. We'll move on to the next agenda item, and we'll be starting off with the report of the 9th session of the IPHC Scientific Review Board. And Dr. Yanali, are you going to provide that? Okay, thanks very much.
Good afternoon, Commissioners. My name is Jim Yanali, and a member of the Science Review Board. This will be very brief. It's a very brief report. In the beginning, we note that we do a more extensive review during the July or the summer meeting, and that this one is just more of a fine-tuning for trying to help with the scientific staff of the Commission. We think the arrangement's working well, and certainly, personally, I enjoy interacting with the scientists and the work that's being done at the Commission. Our first topic that we covered in the report was the geostatistical approach to survey indices, and I think it's fair to say we were strongly supportive of this, as it takes kind of common sense approach to how space and time aggregation of fish occur in the ocean and how fisheries are able to target those and surveys are able to find them. Probably foremost, it eliminates a number of the ad hoc procedures in filling in spatial gaps and other aspects of the survey. We think that overall is a major improvement, and we look forward to the results well, as they've been presented here. We did have a couple of recommendations on the setline survey, treating of that, because we thought maybe some other surveys, including off the West Coast, if there's still some being conducted, might help with the deeper depths which the surveys don't extend into, and that could help with the edge edge effects on that. We also felt this research is really important contribution to the fisheries literature, and we hope that Commission would emphasize the importance of publishing this so it's more broadly available. There were other issues that we talked about specific to the set line survey treatment, and among those were the survey timing adjustment. We went through, that was probably the longer part of our meeting this fall in terms of thinking about it and trying to figure out what actually is being done. And we noted that it's somewhat circular. It involves the e-bio calculation and some calculations. And so we had a recommendation on how that might be streamlined a bit in terms of survey timing and the effective fishing that goes on in between prior to the survey. Hook timing adjustment, we noted that that's an improvement in that it's explicitly included now as opposed to a post hoc adjustment to the survey data. And I already mentioned that the geostatistical approach has advantages of smoothing over and making better use of expansion. And important part of that, I think, that some folks lose is that when you expand it, you're also accounting for that uncertainty. So it's not like you're knowing a lot about where you didn't sample. You're actually computing something that's a better, we think is a better average for that region, and also incorporating the uncertainty. So it's not just the point estimates that we think are better, it's also the estimates of uncertainty that are used in the assessment. Looking at the stock assessment overview, Dr. Stewart presented some iteration of things we talked about during the summer meeting, specifically on how to present sources of mortality and talking about that. And he also presented this spatially explicit model, which is a fairly complicated thing. And our basic feedback on that was, you know, as any good scientist is trying to make it, you know, consistency and everything hang together, but for this assessment model, it's not meant to be, in our view, something that would be used for annual advice. It's more for developing operating models to come up with management strategy evaluations in the context of alternative hypotheses on movement between regions, as opposed to saying that, yeah, we know exactly how many halibut move between regions in every year. We think that's a fairly difficult order, but we can hypothesize and develop hypotheses, scientists can, that can be evaluated to come up with policies that achieve as best as possible the objectives of the Commission. Just in terms of recommendations, we thought maybe the National Marine Fisheries Service trawl survey data might be helpful in this spatial model, especially with regard, so this is a spatial model here is the age-structured assessment model. It's not the geostatistical spatial model. So it's important to keep that distinction straight. Using the survey data may help with some of the juvenile abundance that and pre-recruits to the halibut fishery by region, and as I mentioned, might help with developing alternative movement dynamics. Alan Hicks covered the MSc work that's being done. Specifically, he presented a paper that I was involved with in my regular job on bycatch. As many of you know, the North Pacific Fishery Management Council is developing alternatives for changing PSC limits based on halibut abundance. And the small working group came up with, which Alan was a part of, came up with some alternatives there, and that's gone through one cycle of North Pacific Council review. So that was something that we also noted that in terms of how your decision table could be affected by PSC limits, that right now there's kind of an expectation of what bycatch will be like because of the current PSC. But down the road, if PSC was changing over time, there might affect how the decision table would be constructed. And I think it would add a bit of complexity there. So that's something that I think the council is aware of and something that needs to be considered going down the road. Also, in terms of bycatch specific, our report recommends looking at SPR rates in a sensitivity context. In other words, what would the blue line SPR value be if there were no bycatch fisheries, and what would it be if it was half or double the current levels, just to get an idea there. As the SAB just were commenting on, MSAB, sorry, you know, we also agree that phasing out the use of the eBio we agreed with, and think that some of those estimates are maybe misleading because they depend on selectivity estimates. And there's already a list of alternatives that can be looked at. Also, just some suggestions on how to express fishing intensity provided. In terms of biological research, you know, we're really encouraged by the amount of collaboration that's occurring between different agencies and in the research of Dr. Joseph Planas. In particular, our recommendations were a little bit more towards some of the applied issues, including discard mortality rates. We think that's an important concern. That's for both in the directed fishery, I think also in the bycatch. Also in terms of tagging, some simulation studies on the different types of tagging was recommended, and this may help with some of the mortality estimates. And being on a panel with Mark Mengel is a pleasure, because if you get emails from him, every month he changes lists of quotes, and this is what he contributed to the report on Pasteur's quadrant, which I hadn't known, but it was focusing on how applied problems can motivate basic understanding. So that'll conclude.
All right.
Any questions?
What I was thinking is maybe hearing from the report on the research board and then opening it up for questions, if that's okay. Thanks, Chair. Yes, I'm just going to briefly present a summary of the core outcomes and recommendations from the report of the 18th session of the Research Advisory Board. This report is hot off the press, having been adopted via correspondence yesterday, and it's available in the other reports section on the website and then also on the 360 or SharePoint sites. I guess it's worth just recalling what the mandate of the Research Advisory Board is. The RAB is essentially composed of members of the halibut community, whether it be processors or fishers, who are members of the Advisory Board and provide comment on the research activities being undertaken by the IPHC staff. The meeting itself was held, it's only a one-day meeting, it's quite informal at this point in time. It is the only advisory board of the Commission which still does not have any formalized rules of procedure, and we'll be addressing that over the coming months in preparation for the annual meeting. The RAB is currently composed of 11 members, as I said, from processors and fishers, 7 of which attended the session from the 2 contracting parties, noting again we had 4 absentee members which we'll need to be addressing.
Currently, there are only 2 Canadian representatives on the RAB, and again, this is something that we'll need to consider prior to the annual meeting. The RAB discussed a range of topics based upon the presentation which you're about to receive from Giuseppe on the 5-year research program from the IPHC, as well as a number of ad hoc topics for potential research to be undertaken by the IPHC staff on Pacific halibut. Of those range of topics which are outlined in the report, and I'm not going to go into those in any great detail, the RAB came up with 4 core recommendations for modifications or additions to the research program. As has been the case in this morning's presentations, there was some discussion around the survey expansion and what the likely impacts of potential population variability would have on the outcome of those expansion sites. So the RAB made the recommendation, so as not to misquote, you can see it on the screen here, that the IPHC staff develop an information paper associated with the survey expansion which details the likely implications of periodic survey expansion on the stock assessment and apportionment. And so the IPHC staff, if the Commission agrees, will undertake this to develop this type of information paper, which would also be put on the website to for ease of future reference. There was also quite a lot of discussion around discard mortality and ways to minimize the level of mortality based on best practice handling guidelines. And so as a result, the RAB recommended that the staff undertake a project to develop best practice handling guidelines for each of the primary gear types which catch Pacific halibut, both directed methods and also for the non-directed fisheries. This will not be a simple task, as you can imagine. There are many variations on the gears and the vessel makeups that are being used to catch halibut, but this is something that we will invest some time over if the Commission approves over the coming years. There was quite a lot of fruitful discussion around the IPHC closed area, with many of the members voicing concerns that the current IPHC closed area is not meeting the core objective, which was to protect the area's juvenile Pacific halibut. As a bit of background, the area, as you'd be familiar with, is designated as a potential nursery ground for Pacific halibut, but the only gear that is currently banned from fishing in the area is the directed fisheries, so longline in particular. As a result, the RAB recommended that as the closed area was designated to protect juvenile Pacific halibut, there is no scientific justification for retaining the closure in its current form. Thus, the closure should either be removed, noting that it would be unlikely that much longline fishing would occur in the area, as most of the fish are below the legal size limit, or it should only apply to gear which would interact with juvenile Pacific halibut. And that has been also, I guess, in support of one of the regulatory proposals that we'll hear about tomorrow. And then finally, to the surprise of many, chalky halibut has made a recurrence in areas 3A and 3B, and as a result, the RAB members were keen for the staff to undertake research to answer a number of questions. Obviously, what causes chalky flesh in Pacific halibut? Why does the occurrence of chalky flesh appear to be reoccurring after a period of limited occurrence? And then also, are there differences in the occurrence of chalky flesh in males and females, as well as fish of different sizes? So this is something that we could certainly incorporate into the 5-year research plan, but I will probably leave that to Giuseppe when he talks a little bit more detail about other projects that this could be piggybacked upon. That ends the core recommendations from the RAB, and I'll pass back to you, Chair. Thanks.
All right. Thanks very much, David, for that. I'll just open it up for questions now for either David or Dr. Iannelli around the Scientific Review Board report. report. Any questions from the U.S. commissioners? No? Any from Canadian? I just had one comment, I think, Dave, on your report. I note that it would seem to me that the recommendation around the closed area review is not so much a research thing, it's more of a regulatory item. Did you just mention that there was going to be something in the regulatory? Okay. Are there any questions online, Steve? No? Jim?
So this isn't a question, but it's a comment. You know, Dr. Iannelli said that here's a very brief report. We had a thorough review at the August meeting. The public doesn't get to see that, so I'm wondering if in the future we need to bring the review to the public's attention. Maybe the report's good enough, or maybe it could be fit into this schedule, but just something to think about.
Oh, good point, Jim. David.
Thanks, Chair, and thanks, Commissioner Bolsiger. One comment to note, of course, is that the SRB does review some potentially commercial in confidence information, such as the initial survey results. And so we could potentially bring to the attention of the public via an abbreviated version. That might be a suitable way forward before we make the full report public at this meeting or at an alternative deadline decided by yourselves. Thanks.
All right, if there's no further questions, I'm going to recommend that we move on to the next item. Is Ray going to provide the outline of the survey expansion?
It's a very brief presentation on our setline survey expansion undertaken in 2016, which this year was along the 4 CDE edge. So as I mentioned in my earlier presentation in the morning, we're undergoing a progressive expansion of the survey starting in 2014. A piecewise expansion of the survey started in 2014 in areas 2A and 4A. Again, continued in 2015 in the Eastern Bering Sea Flats, and this year, the third year of the expansion was in the Bering Sea also, along the edge. So we had a lot of stations up here. This map shows the expansions over the entire period of the expansions, and notice that the title of this talk says expansions out to 2019, so here they are. There's 2B and 2C in 2018, and 3A and 3B in 2019, and next year we have a very large expansion planned for area 4B. We'll look at 4B a little more closely. So we'll go straight for 4D, go straight to the summary of the results. We have 52 standard stations on the 4CD edge. I call it the 4, even though almost all of those stations are on the 4D edge, we do have 3 stations on the edge in the closed area, which we treat as part of the same area, 4CD edge. Those stations have been fished since 2000. There are 52 of them. 51 of them were fished effectively. One we couldn't use the data for some gear issues. And so we call these the existing stations in this table here. This is 032 weight per unit effort in pounds per skate. So we have the standard depth, which on the edge is 75 to 275 fathoms. We don't go as shallow there because that would start to include the flats, which is indexed by a combination of our surveys in 2006 and 2015 and the Stroll survey. So we had 52 annually fished stations, 51 of which were effective this year with a weight per unit effort of 18.7 pounds per skate. We added 84 expansion stations, 79 shallower than 275 fathoms, and 5 between 275 and 400 fathoms. The shallower ones of those caught 15.1 pounds per skate on average. The deep ones didn't catch any halibut, leading to an average for the new stations of 14.0 pounds per skate. So in general, We're estimating in 2016 the density is lower somewhat in the new expanded area than it was in the area that we've been surveying previously. So overall, weight per unit effort in the standard depth is 16.5 pounds per skate for 130 stations, and including all stations on the 4CD edge, we get a weight per unit effort of 15.8 pounds per skate from 135 stations. Now, in the past, we calculated these ad hoc adjustment factors to account for, actually this one maybe needs a bit of updating, to account for incomplete coverage in years in which we don't do an expanded survey. I think, I'm not sure this calculation is quite right, but I think it's in the vicinity of 0.83 or 0.84 would be the adjustment factor. We would have been scaling weight per unit effort down in years other than 2016 to account for the somewhat lower density we observed this year in the expansion stations. We don't do that anymore. We let the space-time modeling handle the estimation in those areas that are not covered by the survey. For some context, here are the weight per unit effort values we've got in 3 recent years. So 2015, from the 52 stations, standard stations, we had 27.2 pounds per skate. So even if we hadn't done this expansion, we would have had quite a significant decrease in weight per unit effort. In fact, much larger than the decrease because of the addition of the expansion. It would have gone from 27.2 pounds per skate to 18.7 pounds per skate. So most of the decrease we're seeing from what our estimate seemed to be last year was due to changes overall rather than the addition of these new stations. And as we can see in recent years that the weight per unit effort has jumped around quite a lot. Go back 2 years again, and it's much more similar to what we got this year at 19.6 pounds per skate. And then 2013, more similar to 2015, 24.2 pounds per skate. And these are historically low levels for Area 4CD. Go back a few more years and weight per unit effort is quite a bit higher. Oh, I had a map here and it's vanished. That's disturbing. Okay, well that doesn't give me anything to talk about. But okay, not that one. Nope, that's the next slide. Yeah, I'm not sure what happened there. My apologies for that. Hopefully, when the document gets posted, we'll find a version. We'll repost a version which has this map. What it showed was weight per unit effort by station, comparing the new stations with the existing stations, the previously fished stations. Which is a map I've shown in the past for expansions, and it showed some interesting things, and I can summarize those without the need of, yeah, is it, so you got it, Steve? You have it? Yeah, that's it, so some people have got it, I just, okay. Okay, I apologize to the people here and on the webinar who can't see it, but the commissioners apparently can see it, and Steve Keith has put it in front of me. So a couple of interesting things is that a lot of those low-density stations, first, step back. A large number of the stations, a large proportion of the new stations were in an area we've never previously surveyed, north of 60 degrees north, right up to the edge of the EEZ. And some of those stations actually had quite high catch rates of halibut, right up to the boundary there, much higher than average, where the average was around 16 pounds per skate, and some of these stations you can see, if you can see it, caught close to, over 50 pounds per skate. So an interesting finding there is that we have reasonable densities of halibut, at least reasonable for this part of the range, right up to the boundary of Russia. So we have no reason to think that there is some barrier there or some tapering off of the distribution of halibut as you approach the border there. And so it's likely that the distribution is continuous across into Russian territory. And yeah, we've also released some tags. I'm not sure if Tim's going to be talking about this today or some other day, but we released some tags as part of this, some pop-up tags, satellite tags as part of this work on the survey platform. It'd be interesting to see how many of those pop up on the other side. The other interesting thing here is that where we have other new stations, we have a mix of results. A lot of the low value, a lot of the low density, low weight per unit effort stations not in that northern area. They're actually in the somewhat shallower waters in the center, mixing in the range of stations that were already present. And indeed, in the very southern part of the range, the new stations actually had higher catch rates than the existing stations. So there's quite a bit of variability in our new stations, depending on where they were located and relative to the existing stations. And that was all I had to say on that. There's some technical work going on behind the scenes here. I can go to the next slide. Yeah, thank you. Yeah. So that was a very extensive expansion effort. We added 83 more stations, I think. 84 new stations, which was considerably more than the stations that we had previously. So it was a very large undertaking, very successfully undertaken. There was only one ineffective station, and it wasn't one of the new stations. Next year, we have an equally ambitious project, and that's an expansion in Area 4B. And we will be in the order of doubling the stations in Area 4B. We have some significant gaps in coverage in Area 4B, notably in the very east of the 4B, which is an area which, at least I looked at this a few years ago, has some reasonably high commercial fishing rates and high commercial weight per unit effort. It's adjacent to an area in 4A, which in our 2014 survey showed had relatively high catch rates as well, including in deeper waters. We have a gap right in the center of Area 4B between the islands there. And also we have some completely uncharted territory up on Bowers Ridge, where we have a large number of new stations planned for there. So these things are always extremely interesting to me when we go into unexplored regions. You never know quite what you're going to find. We always learn something new. We learn something new in Area 4A. We learn something new in California. We certainly learn something new on the 4D edge this year. So this is going to be quite an exciting survey for us to do next year. So are there any questions on the expansion, either current or past or future expansions?
All right, thanks, Ray. I'll just see if there's any questions from U.S. commissioners. Jim?
Thanks, Mr. Chairman. Dr. Webster, that's interesting, particularly up next to the Russian border, and you said it'll be interesting to see if any takes pop up over there. So do we have an arrangement with Russians through any scientific venue where you might expect to discover whether they pop up over there?
These are satellite tags, so we'll be recovering the information whether some information whether anyone picks that tag up or not.
Yeah, Bob?
So Ray, based on your previous presentation on forecasting and modeling what your catch rates would be, can you do a test and see if it works in these new areas, and for the survey stations that you're going to be looking at here? Particularly, maybe not on Bowers Ridge, but in the lower archipelagos there, where you're adding all those white dots. Are those doable?
We can do that, yes, indeed. What we need to do is next year when we get our survey data is we can fit the model twice, once with the complete data set and once without. So we can get the predictions that we would have got in the absence of the data and compare them with the observations that we would have obtained. So that does give us some validation tool, and that's the kind of validation tools that people often use for testing whether the model is a good fit or not.
Dave, you had a question?
Ray, this won't come into play till 2018 when you do the expansion that you're planning for 2B, but you're going to go up onto Dogfish Bank and I presume into pretty shallow water there. In my previous experience fishing there, you're going to find you get a starfish on every single hook after about half an hour soak. How would your hook competition plan handle that?
well, we would get fewer baits back, and so those would be areas of high competition, and whatever halibut we get, catch rates of halibut we get there would be increased much more than they would elsewhere. So the hook competition adjustment will hopefully get that back. We'll take care of that. Yeah.
I mean, the baits will come back. They'll just be a starfish wrapped around the bait.
Oh, okay. Well, the survey folks would have to help me out here how that's recorded in the databases, whether that's recorded as a bycatch species or that's recorded as a return bait. Maybe I can get a yes or no nod. Is that recorded as a bycatch species? Yes. Okay. So there we are. We're good.
So when you say we're good, Ray, you're meaning that the hook competition is going to take that into account?
We'll be able to take that into account. If it was recorded as a return bait, which Dave was suggesting might have been a possibility because the bait was still there, then that would be problematic because the halibut obviously didn't have access to that bait.
Yeah.
But if it's, since it appears to be recorded as a bycatch species rather than a return bait, then that will be incorporated into the adjustment.
Yep. Any other questions from U.S. or Canadian commissioners? No. I do see a question from the audience. Go ahead.
Yeah, hi, Don Lane here. I just want to discuss the hook competition a little more. As many of you know, I did halibut survey for a number of years with a predator, and I just wanted to touch a little bit on set length. In that some years we set 8 skates and some years we set 5 and 6, but let's just say we're setting a 5 skate set. On paper, that set should be 1.5 miles long. And typically when I make a set, I make a mark on the plotter, and then I make a mark on the other end where I drop the anchor, and all the time I'm using that length between the two marks as a reference to how that set's going to be in different areas. And rarely is it exactly 1.5. Sometimes it varies from 1.4 to 1.6. You know, it can vary that much, and I don't know if that affects hook competition. I don't know if the length of the set, if you're going to set 500 hooks, and that set is, you're going to set a hook density of 1.4 miles or a hook density of 1.6, is that going to affect the factor of the hook competition? And I don't, I'm just trying to expand this in my mind, but what I'm wondering is on the surveys, when I was doing the surveys, when we make a set every time we drop a rock at every skate, we write down the depth. I'm wondering if on the survey report, if you get the set length back, how long that set was, so we could start making some, if there's a linkage between the length of the set and the hook competition, maybe that might better inform how this could be, whether it's weighted or not, whether it needs to be weighted or not. I can't quite get my head around whether if you got more hooks in a tighter area, if that's going to affect hook competition or if they're more stretched out. Anyway, I just want to bring that up. Because when I made a set, I knew exactly how long that set was. The reason is because when I come back to haul that set later, if it's a short set, then I can expect snarls and drift snarls and tangles and all kinds of stuff. So that may affect who I put at the roller. When we haul that, he may need more skill level to deal with the problems, those kind of things. So I always knew how long that set was. And then in certain areas like Shellicop area, there's a lot of sleeper sharks there. Well, the only way to set that is tight. You want a 1.6. 1.65 is even better because if the sleeper shark gets on there, he wants to roll. And if it's tight, he won't tail wrap. And then so when you're hauling it, you're not dealing with a whole bunch of problems all the time. It just comes up faster. In doing that, does that affect hook competition? You see, those are all factors that I'm trying to get my head around, and I'm hoping that you, survey people, will think about that too, the length of the set and whether that affects it, because it's showing up more and more in our discussions.
All right, thanks for the question, Don. I think maybe that was what Bob was touching on earlier too, and Ray, I don't know if you have any more that, that you wanted to add.
Yeah, I appreciate that, and I've been informed that yes, we do record the start and end location accurately for the sets, and so we can get a measure of set length. Yeah, that's some exploratory data analysis that we can do, is to look at the relationship between these adjustments, or number of baits returned, or the hook adjustment factors themselves for each station, and the length of a set. So we can certainly explore that, and I appreciate the suggestions.
So, Ray, would that be something that you would be able to bring back at the annual meeting, or would that take longer to undertake that kind of exploration?
This would be for the coming year. I could do some preliminary exploration, but it wouldn't be possible to integrate that into the work we've already done.
No, I don't mean like for application, but as meaning for to provide some
information,
bit of information back, and then seeing whether more should be warranted along those lines. I wasn't thinking that you'd undertake it and then come back and say we're making these changes. But
yeah, we could do that. Yes.
Okay. Thanks, Ray. That would be helpful, because we did have a couple of questions around that particular topic, and it's clear that people would like to have a better understanding of what that impact is. All right. I don't see, Steve, are there questions on that? No, they're not. Thanks very much, Ray. So we would move on now, I believe, to the discard mortality rate. And Ian, you're going to cover that?
Yes, thank you. This is just a placeholder for a more detailed presentation we're going to be giving at the annual meeting. The staff has this fall produced a chapter for our document which outlines the basis and basically serves as a review paper of the various studies that have gone into the currently used discard mortality rates, both for the directed halibut fishery as well as for trawl and other hook and line fisheries. We've never, in recent years, we have not had a single location where somebody could go and see which studies have fed into those rates, what the various estimates were, what the sample sizes were, and essentially what the basis for the current DMRs that are being used actually is. We've now completed that chapter. Unfortunately, we didn't have time to complete a PowerPoint presentation for this meeting, but we anticipate both including that in our RARA document this year, as well as having a more detailed PowerPoint presentation at the annual meeting. So I think that will serve as a useful reference for much of our discussion. And as well, it's going to serve as a reference for some of the research that Dr. Joseph Planas is going to tell you about following me, which is going to focus on identifying the places where we need to focus most in our current understanding of DMRs.
All right. Thanks very much, Ian. All right. Are you ready, Joseph?
Great. Thank you, Chair. Okay, this is intended to provide a description of the research activities that the Commission is planning for the next 5-year period, as well as activities that we're planning for the following year. This description is summarized in one of the draft documents that you have. That's document 9211. So let me begin just by stating what are the primary objectives of the research activities at IPHC. And the first one is to identify and address critical knowledge gaps in the biology of the Pacific halibut. Second, to understand the influence of environmental conditions on halibut biology.
and third, to apply the resulting knowledge to reduce uncertainty in current stock assessment models. So we obviously have identified several areas where research is needed, and one is obviously the estimate of biomass, and in relation to that, the estimate specifically of spawning stock biomass, how this impinges on recruitment through the reproductive potential of the females that are quantified here, how discard mortality rates and or survival impinge also on the ability of this biomass to be exploited. So in conjunction with investigation on how the fishing pressure and predation also impinges on the biomass, we have a few research projects that are addressing specifically some of these questions. So these research projects impinge on migration and the distribution of the biomass throughout the distribution range of the species. There are studies on growth that are directly related to the estimate of biomass, but also they're important in understanding how these recruits will eventually contribute to the fisheries. And obviously reproduction, how the reproductive potential is important, how those females in fact will be able to successfully spawn, and also how will they successfully reach their spawning grounds. This is an aspect that is obviously related to reproductive adult migration, spawning migration. So the 5 areas that we are planning activities over the next 5 years are this 5 outlined here. First, reproduction, growth, discard mortality rates, and post-release survival assessment. Fourth, migration, and genetics and genomics is the last one. And this all activities are intended to answer specific fisheries-related questions. The first part in reproduction, the questions that we're asking is to provide information on the sex ratio of the catch, and also to improve maturation estimates of the spawning biomass. Questions that we intend to answer related to growth are the changes that Dr. Stewart described extensively before, changes in size at age and obviously changes in biomass, and also to develop tools to assess fish condition. The studies on DMRs and post-release survival assessment are intended really to eventually improve our estimates of bycatch survival. The studies on migration are intended to provide information on larval dispersal, but also adult feeding and reproductive migration, basically understanding the distribution of the species over time and space throughout the distribution range. And finally, genetics and genomics to understand the genetic structure of the population of Pacific halibut, and also to develop genomic tools in order to further our understanding of the genetics of the population and how this is changing over time and in response to environmental and anthropogenic influences, specifically to sequence the genome of the Pacific halibut. So let me start with the first research area, reproduction. Here we acknowledge there are important knowledge gaps on the reproductive biology of the species. There are several important aspects related to reproduction that we don't understand, and we specifically are aiming to improve the knowledge on the sex ratio of the catch, specifically by developing tools to identify with genetic means males and females, but also through at-sea marking, which is a project that is going on right now. And also to improve the maturation estimates of the spawning biomass. So what we think is needed to answer these questions is improve, obviously, knowledge on reproductive development, on maturation, on fecundity, on sex identification, sex determination mechanisms, basically, and how the environment and hormones control reproduction. We need scientific-based criteria to identify reproductive status and reproductive potential. We need to update our current estimates of age and size at maturation. We heard that this estimates are not completely current, and they need to be revised, I think. And furthermore, we need information on skip spawning. We need information on those females that, for whatever reason, they do not enter the spawning biomass at that particular year. There's no information for that in the Pacific halibut. So the new proposed studies to address these issues are, first, full characterization of the annual reproductive cycle, and second, to identify sex determination mechanisms and the influence of mostly environmental factors. The first study, the full characterization of the annual reproductive cycle, has the objective to understand temporal changes in reproductive development throughout an entire annual reproductive cycle in male and female Pacific halibut. Okay, and this will be done through histological assessment of gonadal development and maturation, through endocrine profiling, basically measure hormone levels in the blood, reproductive hormone levels, throughout the reproductive cycle. Also look at other parameters such as gene expression of reproductive related tissues, gonads, pituitary, and brain. Also look at the gonadosomatic index throughout the reproductive cycle. This summer we just had the first measures of what the gonadosomatic index in females are, and to finally complement these studies with ultrasound monitoring of gonadal development and maturation. With this, we intend to provide a comprehensive reproductive monitoring of the adult population in order to improve our estimate of actual spawning biomass. Also to improve our staging of reproductive status, to update maturity age estimates, and to obtain estimates of skip spawning. Okay, so this is one of the projects that I will describe at the end of the presentation that are being put forward for approval of the annual meeting. Staff involved, in addition to myself, is Dr. Tim Lohr, who has been instrumental in conducting studies on reproductive migration in the Pacific halibut. The second reproductive project is to identify sex determination mechanisms. The objective here is to understand how sex is established in Pacific halibut, what determines that males are males and females are females. First, by identifying sex markers, SNPs. This is something that is going on as we speak, the identification of genetic marks to tell males from females, to identify what are the mechanisms that determine sex and when they take place, when during early development, and importantly to identify possible environmental influences on sex determination, whether temperature could have an effect in changing sex ratios at the population level. There's evidence for that happening in other species. We don't know if that is true in the Pacific halibut, but there's evidences of skewed sex ratios in different areas. And this may be related to changes in the PDO, as Dr. Stewart had alluded to before this morning. Changes in towards positive or negative regimes that could actually influence how sex is determined. So with these studies, we intend to provide genetic sex markers through SNP assays. We intend to identify the genetic basis for sex and to provide information on possible environmental effects on sex ratios. This is a project that is being put forward also this year. We're doing this in collaboration with the University of Washington and also with the French Institute of Research Agronomic in France. And in addition to myself, Dr. Tim Lohr is involved in these studies. The second area of research is growth. Again, relatively little is known regarding what factors influence growth in this species. And growth, as was alluded to by Dr. Stewart before, again, is one of the attributed causes for the decrease in size of age, one of several causes. So what we need is improved knowledge on growth patterns and how the environment influences growth patterns in the wild. And we need improved understanding in the possible role of growth alterations in these observed decrease in size at age. The new proposed studies are two. First is to catalog the physiological markers to monitor growth. We need tools to monitor growth basically real time on the Pacific halibut population, and we need to evaluate growth patterns and how the environment influences growth in the species. The first one is a very straightforward project, and the objective is to identify and validate markers, and specifically molecular growth markers for growth studies through the identification of genes that are expressed in growth-related tissues, basically muscle, both white and red muscle and liver. And this is through RNA sequencing, which provides really an unprecedented view of the genes that are expressed in any particular tissue. With this, we intend to establish a growth-related gene sequence data set and, more importantly, molecular assays to monitor growth patterns in the Pacific halibut population. The second study is to evaluate growth patterns or study growth patterns and study the effects of our environmental influences. And the objective here is to identify molecular, biochemical, and isotopic profiles that are characteristic of specific growth patterns and evaluate the potential effects of environmental influences. The first is to evaluate or study different growth trajectories in the wild, and this can be done by selecting fish of different sizes or size categories of different age and see whether there's in fact a different set of markers that are expressed in age-matched individuals, and this would be evidence for different growth patterns in the wild. Probably a better approach is the following, is to really conduct experiments in captivity by establishing different growth trajectories in juvenile fish and identify these markers that will allow us to understand better the growth pattern. So this can be done either through feeding or fasting fish, or in fact growing fish at different rates and comparing low versus high rates. And this is precisely what we're doing right now in collaboration with the Alaska Fisheries Science Center in Newport, Oregon, where we're growing juvenile Pacific halibut that were caught off Kodiak this summer at 2 different temperatures, at 2 degrees and 10 degrees, and we're looking at temperature effects, and also we're looking at how temperature compensated growth takes place, and what are the markers that will come up that will allow us to study growth patterns. Also, we plan to do isotopic tissue turnover in muscle and liver to trace dietary and habitat shifts, and this is through the use of stable isotopes such as carbon-13 and nitrogen-15. And we're doing these studies also in collaboration with the Alaska Pacific University in Anchorage. Okay. Lastly, related to growth, we want to investigate the effects of environmental factors on growth performance. Obviously, I've talked about temperature, but changes in salinity are also relevant, dissolved oxygen, and water pH, specifically to look at eventually ocean acidification effects on growth. And also to identify the optimal environmental conditions for growth in order to understand how biomass can be changing in specific areas and over time. And also to understand the basis of the sexual dimorphic growth in the Pacific halibut, why females are in fact grow faster than males. So with these studies, we intend to identify and validate growth markers for field studies. We intend to characterize molecular and biochemical growth signatures that will allow us to differentiate fast-growing versus slow-growing patterns in the field, to look at environmental effects on somatic growth, mostly temperature, and to improve all these biological inputs that are used to estimate biomass. This growth-related projects are being proposed internally this year, and also we're preparing a grant to NPRB to address growth regulation in relation to the decrease in size at age. That will be submitted very shortly. In addition to myself, Dana Rudy is collaborating in the studies from our staff. The third area is discard mortality rates and survival. Again, we know relatively little regarding the factors that influence bycatch survival. The idea here is to provide better estimates of bycatch survival. What we think it's needed is to introduce quantitative, measurable factors that are linked to fish handling practices and to fish physiological condition, and ultimately to survival, in order to improve the current estimates of DMR. So the new proposed studies are 3. The first one is to, we propose to evaluate the effects of fish handling practices on injury levels and the physiological condition of captured Pacific halibut in the directed fisheries, of course. Second, to investigate the relationship between physiological condition post-capture and survival as assessed by the use of accelerometer tags, which provide an excellent mean to look at survival within a certain period of time after release. And lastly, to improve estimates of survival of Pacific halibut caught in the trawl fishery. Okay, the first study has the objective to understand the relationship between handling practices and physiological condition of captured Pacific halibut in the longline fishery. So here we're planning on assessing injuries associated with release techniques, so careful shake, ganging cut, hook straightening, and determining the physiological condition of all captured fish with an associated injury level after different deck exposure times. And with this we can relate to condition of the fish as assessed by condition factor indices, energy levels, specifically fat levels in the flesh, morphometric analysis, and then to measure the levels of stress and physiological disturbance indicators in the blood of all captured fish, and relate that to handling techniques. When we're specifically talking about stress hormones such as cortisol, but other metabolic stress indicators such as lactate or glucose or potassium. Okay. With these studies, we tend to provide an injury profile for different release techniques in the longline fishery, and importantly, to conduct a physiological assessment of fish handling practices. So basically to establish a fish condition index post-capture. Okay. The second study is to investigate the relationship between this physiological condition post-capture indexes and survival as assessed by tagging. And the objective here is to measure survival post-release in Pacific halibut and link this with the physiological condition and captured related events. What we're going to do here is to tag fish that have been exposed to different handling practices in the longline fishery with accelerometer tags, in addition to conventional tags, wire tags, and to assess the survival of fish according to size and physiological condition. Okay. And with this, we intend to provide information on post-release survival in relation to handling practices and physiological condition, and also to provide information on post-release survival in relation to size. Okay. So basically, we can establish a link between the first events, the capture and the handling related events, with an injury code, with physiological condition, and eventually with survival. Okay. And obviously, an important deliverable is also to estimate discard mortality rates by electronic monitoring, with the idea that if we can record handling events and we know all the steps leading to survival, we can directly estimate survival. This projects, this and the previous one, are proposed internally, but also are being written up for an SK grant that will be submitted next week. These studies are conducted by several of our staff, Claude Dykstra, Tim Lohr, Ian Stewart, and Alan Higgs are also involved. And lastly, to improve estimates of survival of Pacific halibut in the trawl fishery. The objective here is to assess the condition and survival rate of discarded Pacific halibut in the non-directed trawl fishery and improve our current estimates of DMRs in this fishery. We plan to continue and capitalize contacts with the industry, in particular the Amendment 80 fleet, to plan collaborative work to apply methods to assess physiological conditions in captured halibut in this fishery, determine survival rates of discarded halibut after tagging, and then relate physiological condition with survival rates of discarded halibut. The approach is similar to the previously discussed on the directed fishery. The deliverables are improved knowledge of survival of discarded halibut and consequently improved estimates of DMRs in the trawl fishery. And these studies are also conducted with several of our staff. Migration is the fourth large area, and this is traditionally one of the main research areas of the Commission. We intend to provide information on larval dispersal and adult feeding and reproductive migration. What we think we need is to really improve our understanding on this issue, specifically larval, juvenile, and reproductive migration, by incorporating, in addition to the classical migration and traditional migration techniques, incorporate additional sources of biological information on migration. Basically to move towards a more integrative view on migration, to specifically target larval migration and connectivity, and we're referring to connectivity between the Gulf of Alaska and the Bering Sea, and also eventually to look at swimming and migratory performance. more linking it to the physiology of the organism. So the first aspect towards a more integrative view of migration, what we intend here is to combine current tagging efforts with genetic and otolith and tissue composition analysis to better understand migratory patterns in the species, to conduct genetic analysis of tagged fish, to conduct microchemical and stable isotope analysis on otoliths, as well as tissue isotope analysis, and continue the reproductive monitoring of the adult females by continuing our satellite tagging, but also combine it with other sources of information on the physiological status of those females that are tagged through endocrine profiling, ovarian tissue biopsies, and ultrasound for ovarian staging. So with this, we intend to provide genetic and elemental and isotopic information on migratory adult fish, and to improve knowledge on reproductive migrations and identification of spawning areas. In particular, this coming year, we just heard that from Dr. Webster on the expansion on the 4B area. So there's a project, an internal project that has been proposed to tag females caught at the Bowers Bridge in the 4B area. And also, additionally, we're also proposing internally a project that is based on tail pattern recognition. So through photographic imaging of the tails and specific patterns, we're proposing a pilot study to see if this would be an avenue to identify females and assist in migration studies. And these studies are conducted with several of our staff, Dr. Lohr, myself, Claude Dykstra, and Tracy Gierney. Larval migration and connectivity is an important issue for us. The objective is specifically to understand the mechanisms of larval connectivity between the Gulf of Alaska and the Bering Sea through the collection of data from the NIMS ichthyoplankton survey and the mapping of larval distribution over time and space. The collection of larval samples from the survey to conduct genetic analysis. So here is a clear example of how we will try to link migration and genetics to assist in understanding the distribution of these species. These are some examples of larval distribution maps that Lori Sidoros from our staff has generated from data from the NIMS ichthyoplankton survey in a project that we're doing in collaboration with Dr. Janet Duffy Anderson and others from the Alaska Fisheries Science Center at Sandpoint in Seattle. And this is the base, in fact, of an MPRB grant that we're also proposing this year on the topic of larval connectivity. So with these studies, we hope to improve knowledge on larval distribution, migration, and genetic structure within the population. And lastly, the last area that I'm going to be discussing is genetics and genomics, with the aim to improve knowledge on the genetic structure of the population and the development of genomic tools, the genome. What we think is needed is improved knowledge on the genetic composition of the population. We also need to establish genomic resources for the species, which will aid in several of the projects that we're undergoing, and to perform genome-wide association studies to evaluate the genetic effects of fishery-dependent and fishery-independent influences on a variety of biological processes, including growth, reproduction, nutrition, etc. So the first studies that are proposed is to continue the genetic work on the population structure that was initially conducted at the microsatellite level, but now we're planning to increase it and expand it and improve it through novel techniques, specifically through rat sequencing, and eventually to identify genetic signatures of geographical population groups so that we can use the genetics also to assist in migration, as I said before. And this is an internal project that is being proposed this year, also in collaboration with scientists at the University of Washington. Okay, and Dr. Tim Lohr is also involved in this study. And finally, the last aspect is the genomic resources, basically to obtain a first draft sequence of the Pacific halibut genome. This has tremendous implications, and we're perfectly suited to attack this problem, and this will allow us to identify genomic regions and genes that are responsible for temporal and spatial adaptive characteristics, and basically link the genotype and the phenotype to better understand the biology of the species. This is also an internal project that has been proposed this year, and in collaboration with French INRA Center in Rennes. So the last couple of slides are to just give you an idea of the temporal chart of activities. So here we have the projects that I've described on reproduction. Some have started already in 2016, and the annual reproductive cycle and sex determination mechanisms will lead us into 2019. The next set of studies are genetics and genomics. Also, some of these studies have started already, but you can see how these studies can actually continue up until 2020, 2021. The studies on growth, again, some have started already, but we see those continuing throughout the next 4 or 5 years. DMRs and survival, we hope to start these studies next year, 2017, and to continue them for 2 or 3 years more. And finally, the studies on migration, which we're already doing, but that still represent a core of the research activities. As you can see, there are long-term plans relating migration. This is a list that you have in the document, in the draft document, of the projects that we're thinking of putting forward for 2017. I don't intend you to read this, but just to give you an idea, these are projects that are based on reproduction, that are based on migration, of some of the work that I've indicated throughout the presentation, work on DMRs, work on growth, and as you can see, and that's something that we're striving on, is to find interactions among the different research projects in order to capitalize the information that we get, but without forgetting that all these projects have important management implications, and also that some of these studies, in fact, should be contemplating environmental changes. So with this, I will finish my presentation.
All right, thanks very much, Joseph. I'll see if U.S. commissioners have any questions. Linda?
Thank you. I did have two, I guess one, just a short one and then a longer question. With skip spawning, when that occurs in the fish, do the females not create eggs, or do the females create eggs that are then absorbed, or do you see all different patterns for skip spawning?
If we draw from what we know from other species, and perhaps the closest one, at least geographically and life cycle, would be perhaps a sablefish. There's a point at which the females sort of make the decision, and I really don't like this term, but they stop oocyte development. So you will see their ovaries with a certain level of egg development, but that will not progress, and then eventually those eggs will be resorbed. But there's actually no production of eggs, but oocyte development will stop at a certain point. And histologically, you should be able to detect that. That's been done in the sablefish and several other species, but we still don't have evidence for that in the Pacific halibut, or we don't know how microscopically a skip spawning ovary looks like, so that we can also assess not only morphologically, externally, but also microscopically, which eventually is really what you need to do in order to determine, the incidence of skip spawning.
Thank you. And if I could, my second question was around the change in size at age and how that might be affecting the population. And I couldn't tell from what you were describing from this research if this is a question you would get at or not. But from what we heard from Ian this morning, the maturation schedule hasn't changed, so fish are still maturing at the same age, but they're a lot smaller, which would suggest to me as they stay smaller, they're vulnerable longer, probably to trawl bycatch, but they are mature longer before they're selected or recruited into the directed fishery. And I just wonder how those dynamics might affect the stock, the yield, and patterns that we might expect to see over the next few years at these historic low levels of size at age.
Right. Yeah. That's a very good point, and it's a very complicated question. And I don't think we have really the answers right now as to how growth is related to maturity in many species, not for Pacific halibut, there's no data for it, but growth influences the time of maturity, the time of when females will spawn for the first time. And high growth rates in many species, which is a result of high productivity, good environmental conditions, will advance the time of maturity. So if the conditions are right and the energy levels in the fish are sufficient, those females will start reproducing earlier than females that may not have the energy stores or resources available for investing energy in egg production. So that's something that we really need to investigate. We need to understand first how we can tell that a fish that is growing fast versus one that is not, energy levels, growth patterns. That's why I emphasized quite a bit on the development of markers for growth, so that we can correlate growth rates with maturity, how that affects their ability to not only mature but eventually migrate to their spawning grounds or migrate for their feeding needs. So those are really important questions, and I think we have to really be working on several fronts to address that complex issue.
Jim, did you have a question? Any Canadian commissioners? David?
Thanks for a very interesting presentation, Joseph, and it looks like a very ambitious schedule of investigations. As you were showing, or maybe it was, I'm thinking back to a slide that Ian showed of the size at age being small back in the 20s, or way back at the beginning of the data collection, and then getting very large and then coming back down again. I just wondered if it's possible that there's two different mechanisms in play there, and back in the day, back 100 years ago, maybe it was just density dependent, but it almost seemed like the decline started around the time that we put a size limit in, and so maybe that's not the mechanism in play today. Maybe it's the size selected nature of the fishery, so there are two different causes or something. Is there any way you could investigate that?
Yes. Yeah, as it was indicated before, there's been quite a bit of recent work as to the potential causes of the decrease in size at age over this time. Of course, we have to think that that historically, as well said, this decrease was preceded by an increase in size at age. So under very different fishing conditions. So what I'm getting at is that there are many causes. There are many possible causes for the decrease in size at age, and I think we should take a sort of a systematic way of approaching the different potential causes. And the one that is, in fact, closer, obviously, to my expertise is growth. Growth has been attributed as one of the potential causes for the decrease in size at age. And growth is related to density, is related to food source, it's related to food competition, interspecifically and between species, and it's also related to environmental parameters. And all these are changing, and it's quite. It would be a very interesting exercise, really, to establish good correlations between how growth has been changing with density changes and environmental changes, but eventually to understand how these individual factors affect growth. you have to take them apart and investigate them basically one by one. And that's what you can actually do in captivity. That's why we're proposing to do some relatively simple captive experiments by looking at, for instance, the effect of temperature, but also the effect of density, and and eventually the effect of energy, diets, so the quality of the food source. In order to make a little bit of sense of how growth may have been changing over time, I think we have to take this sort of systematic way of addressing the possible causes of growth changes. Unfortunately, we cannot assess growth historically in the population, and we tried to do that by looking at otolith increment analysis, and in fact our studies that were just recently completed and funded by NPRB showed that otolith growth is really not a good surrogate. It's not a good proxy for somatic growth. So that sort of puts a brake on how we can retrospectively look at how growth may have been changed, in somatic growth.
Any other questions, Dave? Thanks very much for that presentation. I had a couple of questions for you. You had that summary of research projects proposed for 2017 in your presentation and also in your paper. I was wondering a couple things about that table. One, was that all of the projects that are proposed, or is that just covering funding that's from the IPHC? And in your presentation, you talked about some projects that were going to be taken in collaboration with other partners. I was wondering if those are included in this table.
These are only the projects that we're proposing to be funded internally.
Okay.
The ones in that table.
I think it'd be useful to show the other ones too. I would say, because I mean what you're doing is basically, you know, showing collaboration and leveraging funds that working with other partners that share common interests and objectives to better understand this biology within halibut. So I think it'd be useful to show all of them. And I think it would be useful, at least for me, in this table, if you could expand it to have another column that would identify particularly the management implications of what's being addressed by each one of the different research projects. Maybe it's not, that's not the right title, but something along the lines of like that. And
I think that's a good point. That's precisely what I tried to do.
Yes, you did that in your end presentation, and I think that was really helpful too. And I liked the I guess the Gantt chart at the end as well that showed when you're starting the projects and when they're working through, which was really informative as well. I think as well that I think you've already addressed this question, but this is more for clarification on the DMRs. It was going to cover all sizes, both in directed and non-directed fisheries. Is the intent of trying to better understand basically discard mortality and across all spectrum of fisheries is what I heard. I guess that's just clarification I really is seeking. So
yeah, that is the case.
Good. All right, I think those were my questions. Any questions online there, Steve? Are there any questions within? Yeah.
I'm sorry, there is one that came in right as we were talking. Nicole Fredrickson asks, are there any plans to investigate how or if fecundity and egg quality change with size at age for Pacific halibut, and what the potential impacts on recruitment might be? For other species, there is evidence that fecundity and egg quality are reduced with size at age.
Yeah, that's a very interesting question. It's complicated by the fact that that fecundity is not an easy parameter to measure, and egg quality, which is something extremely relevant because it relates to survival at very early stages, would only be really attempted once we have a captive broodstock. my idea is, in fact, work towards that and be able to, in fact, look at early development, survival, and events taking place very early in development where, we cannot possibly get those samples from the actual fishery, from the environment. It's way too early. The earliest that we can get samples or live samples is really when we can catch those juveniles from the nursery areas, not prior to that. So we're sort of dependent on having a captive broodstock population of fish that we can do those type of analysis.
Are there any questions in the room here? No, I don't see any. So I think that concludes today's agenda. So we'd adjourn now, and for tomorrow we're back in the same room, and we're getting together at 9 a.m. in this room, right? And for commissioners, we'd get together at 8 o'clock in the Portland room again. Okay. So thanks very much for all the information that was exchanged today. That was very, very helpful to me. We'll see you here tomorrow at 9.